how do you go from idea to finished application using Java in Spring Boot? Well, in this video, I'll show you the process that I use and have used for the past 15 years to build countless applications. But this isn't just theory. We're going to build a real application to manage events like conferences and concerts, allowing users to obtain tickets, complete with a QR code that staff members can then scan in order to validate the ticket. All of the resources that I use in the video, including the source code and the written materials, can be downloaded for free from the Devtiro Discord server. There's a link in the description below, so you too can join the community. And if you're set on becoming a full stack developer, then the lessons in which we build the user interface are available to premium members on devtiro.com, link also in the description. So here's what we have coming up in this video. We're first going to start with some domain analysis. We'll then move on to designing the REST API and the application's architecture. We'll then set up our project, and this will include setting up Spring Security. We'll then implement our domain. We'll then implement the event creation and management functionality. We'll then implement the ticket sale and purchase functionality. However, it should be said that we won't be integrating with a real third-party payment system. No money is going to change hands here. And finally, we'll implement ticket validation, which will include generating QR codes and scanning those QR codes. So with all of that covered, let's get started. Now, this is going to be completely focused on building. So there are going to be some prerequisites in order to get the most out of these videos. Because we are going to be time constrained, we can't really divert too much in order to deep dive the theory. So here are my recommendations. So the things that you need to know in order to get the most out of these videos. You need to be comfortable with the Java programming language. That's the first one. You also need to know Spring Boot, or at least be comfortable with Spring Boot. You'd also want to be comfortable with Spring Security. You don't need to know any of the advanced stuff, but just be able to configure Spring Security in a Spring Boot application. And I have some recommended things to know as well. The first one is to be comfortable with OAuth 2 and OpenID Connect. And I also recommend to be comfortable with React and NPM. Again, you don't necessarily need to know how to build React applications. We're not going to be covering how to build React applications, but I am going to provide a React front end for you, so it would be beneficial to know how to run that and interact with that. In this lesson, we're really going to explore the project brief for our event ticketing platform, with the aim of trying to understand the requirements of the system that we are to build. So here we are in Miro, and here we have our project brief for the event ticketing platform. You can download this project brief as a PDF from Discord, and it's exactly the same one that you'll see here. Now, if you haven't seen one of my project briefs before, it's broken up into various distinct parts. Usually it starts with a summary, so just a high-level description of the system that we're going to build. Then we have some definitions. So I like to define some terms that we're going to be using, in this case, event, ticket, and QR code. And then we have a set of user stories. Now, each user story, we just zoom in a bit. So each user story has the as a, I want, so that format, and also a set of acceptance criteria. And together they describe the requirements of the system that we are to build. So in this case, we have create event. As an event organizer, I want to create and configure a new event with details like date, venue, ticket types, so that I can start selling tickets to attendees. And then we have a set of acceptance criteria, and these are statements that can either be true or false. So in case of the first one here, an organizer can input the event name, date, type, and venue. If we look at our built system, that statement is either true or false. And the idea is for all of these statements to eventually be true, and then we say that the user story is done, it's complete. In the case of this project brief, we have 1, 2, 3, 4 user stories. So let's start at the top and look to understand these user stories in more detail. Okay, in fact, let's just grab a highlighter. Okay, that should do us. So let's go through this. So a web-based platform for enabling users to create events, manage ticket sales, generate QR-coded tickets for attendees, streamlining the event management and ticket distribution process. So there's a few things that we can just learn from this. So for example, web-based platform says that we're going to be building some kind of web application. And then we mention here creating events, ticket sales, generating QR-coded tickets. Now that's another really interesting thing, QR-coded tickets. So we're going to have to use some sort of library to generate QR codes. And then streamlining the event management and ticket distribution process. So that's the value in building the system in the first place. So with that done, let's take a look at the definitions here. So we have the definition of an event. Where's that highlighter? So a planned gathering or occasion, specific date, time, and venue that requires ticketing for attendance management. So we'll come on to doing some domain analysis a bit later, but words like date, time, and venue, we'll want to take a look at those and track those a bit later. Now, For ticket, a digital or physical document that grants the holder access to an event, unique details for the event, and a unique QR code. So we're going to be generating digital tickets, which could then potentially be printed, which makes for the physical document. But each ticket has to have a unique QR code. And then we have the definition of a QR code, machine readable code, black and white squares, used to store ticket information and verify authenticity. So when the attendee gets to the event, has their ticket either digital on their phone or they've printed it out, the staff at the event are able to scan the QR code, and then they can tell almost immediately whether or not that ticket is valid. So with that done, let's take a look at the user stories, of which we have 4 here. So creating an event. As an event organizer, I want to create and configure a new event with details like date, venue, and ticket types, so I can start selling tickets to attendees. So this user story is really about creating events in the first place, because we need this concept of events in the system in order to be able to sell tickets for events. Let's see if the acceptance criteria support that. So an organizer can input the name, date, time, and venue. They sound like properties on our event object. Organizer can set multiple ticket types. So that's interesting. So it's not just one type of ticket per event. There can be many different ones, and they can have different prices. The organizer can specify the total available tickets per type. So there's a limited number of tickets per ticket type, and the event appears on the platform after creation. That makes sense. So that's creating an event. Let's go to purchasing an event ticket. So as an event goer, I want to purchase the correct ticket for an event. So correct ticket must be a reference to the ticket types up here, so that I can attend and experience the event. So not only does the ticket get them in the door, but depending on the type of ticket they have will of course affect their experience. So let's take a look at the acceptance criteria. An event goer can search for events. So we'll need to have some sort of event search functionality in there. The event goer can browse and select different ticket types available each event, which I suppose should probably be each event. Let's put a T on the end there. There we go. Nobody will ever know. So event goer can browse and select different ticket types available for each event, and the event goer can purchase their chosen ticket type. So basically, somebody who wants to go to an event can search for tickets, look at the different types, and then they're able to purchase them. So create an event with certain tickets and certain ticket types, and this is somebody being able to purchase those ticket types. So purchasing an event ticket. Let's see what else we have here. So managing ticket sales. As an event organizer, I want to monitor and manage ticket sales so that I can track revenue and attendance. So dashboard displays sales metrics, organizer can view purchaser details, system prevents overselling of tickets, and the sales automatically stop at the specified end date. So this is being able to set limits on how many tickets can be sold and not being able to sell any more after that, and then being able to monitor it. Here it says displays sales metrics. So everything an event organizer would really want to know. It doesn't specify how we're going to display these metrics, but we can explore that when we get to that point. So that's managing the ticket sales. And then we have our last one here, which is validating tickets. So as an event staff member, I want to be able to scan attendee QR codes at entry so that I can verify ticket authenticity. So this is the part that we were discussing earlier. So basically somebody's bought a ticket, they've taken it to the event, and then the staff at the event are able to scan that QR code and tell whether or not that's a valid ticket. So staff can scan QR codes using their mobile device. So mobile device is a big one. So at the very least, we need to be able to view at least one page of our application on a mobile device, the one that displays the QR code. The system displays ticket validity status instantly. Instantly is always a funny word in project briefs. Usually there's an acceptable range. We don't have any definition of what instantly could mean here, so we're just going to, for the sake of this build, mean as fast as possible. We don't want an event staff member scanning a QR code and then having to wait several minutes in order to see whether or not the QR code is valid. So we'll bear that in mind when we design our system. The system prevents duplicate ticket use. So we need to keep track of when a ticket is used. So when we scan a QR code, that needs to be stored somewhere. So if somebody tries to reuse that ticket, they're prevented from being allowed into the event. And staff can manually input ticket numbers if the QR scan fails. So we need to put some form of ticket number on the ticket, and then having the ability to enter that ticket number on the same screen that we scan the QR code. Now, before we wrap up, I just want to draw your attention to something here. So we have 4 user stories: as an event organizer, as an event goer, as an event organizer, as an event staff member. So we have 4 high-level features here, but it seems like we also have 3 different types of user: an event organizer, which is these two user stories here, and then an event goer, which is this user story down here, and an event staff member. So we have 3 different types of user, 4 high-level features that we need to implement. And although there's a lot of detail not in here, as we start to design and implement our system, a lot of those details should become clearer. So for the moment, this should be all that we need. So in summary, the system serves 3 different user types. We have organizers, attendees, and staff members. The platform manages a complete event lifecycle from creation of the event right through to the ticket validation. And we have several features, including the event setup, the ticket sales, the monitoring of those ticket sales, and then entry validation, whether or not that ticket gets you into the event. In this module, we'll create an initial user interface design for our event ticket platform. We'll do this by looking to understand our users, their needs, and how they'll interact with our system. The module is structured as follows. We'll start by exploring the user personas. We'll then explore the user journeys, and then we'll design the user interface. So now for the learning objectives. So by the end of this module, you will be able to describe the application's user personas, describe the application's user journeys, and produce the first iteration of a user interface design. So with that covered, let's get started. So let's look at some user personas which model potential users of our system. Please note that the following user personas were generated by an LLM based on our project brief, so we can be confident that these people are fictional and the user personas are as unbiased as possible. So we've identified there are 3 different types of user. We have organizers, which organize the events. We have attendees, which attend to those events. And then we have staff that work at the event. So each of the user personas that we're going to see fit into one of these 3 categories. So first, let's take a look at the organizers. So first, we have our corporate event manager. So the primary goal of the corporate event manager is to represent the company's brand values through professional events, while tracking attendee analytics for business development. This user persona represents a data-driven decision maker valuing detailed analytics. Because of the focus on the company brand values, this user persona is brand conscious and needs customization options. And this user persona is focused on security and privacy for customer data handling. We then have our event planning professional. So the primary goal of the event planning professional is to efficiently manage multiple events with different ticket tiers. The main challenge here is managing multiple events while preventing overselling. As you would expect, this user persona is detail-orientated with strong organizational skills. They are tech-savvy but value intuitive interfaces, and they are time-conscious and they appreciate automation. We then have our part-time event organizer. So the primary goal of this user persona is to create occasional events with minimal effort. The challenge is limited technical expertise and very limited time. They prefer simple guided interfaces with templates. They really value mobile accessibility, and they like to prioritize their customer-facing aesthetics. So now for attendees. We have our busy parent event attendee. So the primary goal here is to secure family-friendly event tickets in advance. The main challenge is coordinating multiple family members' tickets. They are a careful, advanced planner. They value clear venue information and accessibility details. And they really appreciate email confirmations and reminders. We then have our young event goer. Their primary goal is easy discovery and purchase of trendy event tickets. The challenge is finding affordable tickets and smooth validation, so getting into the venue smoothly with their ticket. They are digital native and they expect intuitive mobile experiences, and they are price sensitive but they value unique experiences. And they prefer last minute purchases and digital tickets. We now have our corporate networking attendee. So the primary goal here is efficient registration for professional events. The challenge is they need detailed receipts for expense reporting. They value a streamlined checkout process. And as you would expect, they require corporate expense documentation. And their ask is that they want calendar integration and professional reminders. Now for staff. We have our event staff coordinator. So their primary goal is to manage entry validation for large events. The challenge is they need consistent validation across multiple entry points. They're process-orientated and focus on security and accuracy. They need reliable, simple tools for their team, and they value speed and reliability over complex features. Then we have our entry-level event staff. Their primary goal is quick and accurate ticket validation. The challenge is handling high-pressure entry with minimal training, and they have limited technical expertise requiring an intuitive interface. And it may be their first job or a temporary position, and they need clear instructions and clear error messages. So in summary, we've explored the user personas representing organisers, attendees, and staff. These user personas will influence how the system is designed and implemented. So let's now explore some user journeys, how our user personas may interact with our application. So here we are back in Miro, and I'm going to take you through the user journeys of the 3 types of user that are going to use our system. We have organizer, attendees, and event staff down the bottom there. I've used a bit of imagination with these user journeys just to try and figure out how these different types of user would use the system. So this is by no means perfect. However, it should inform how we then go on to design our user interface, if only a little bit. So let's take a look through what we have here, starting with the organizer. Now we have several different types of organizer. We've already taken a look at their user profiles. So here's what I think they all more or less have in common. So they start by logging into the platform, creating a new event. There's all sorts of different types of event. We've looked through each of the user profiles and seen there's a whole wide range of event. Now, I imagine this particular step might include selecting an event template, but it remains to be seen. So after we've created a new event, we can then configure the types of ticket for that event. We've decided that there's going to be several types of ticket for that event, possibly. So we'll need to configure that maybe in the same step, maybe as a separate step, but it's explicit here as a separate step. And then we'll need to set pricing. Now, we haven't really delved into pricing too much other than saying that different ticket types can have different pricing, but I imagine this as a separate step in the user journey. So we have set pricing there. Then there's a step of reviewing the event details before it's then published. And I've called this event creation. So after the event is published, that's typically when attendees would then go and purchase tickets, but we'll get to that in a moment. We then have sales management. So the user personas mention wanting to track sales. So there's going to be monitoring of the sales dashboard, tracking ticket inventory, because of course events can hold only so many people. And then I've put in adjust ticket pricing, assuming that pricing is going to be variable based on supply and demand of tickets. We then have event preparation, and this is perhaps where the most imagination is being used. The organizer is present on the day. Perhaps they brief the staff on the check-in process. Maybe they test the scanning equipment themselves. Maybe they're not involved in this process whatsoever. But there's some prep just before the big event day. And then we have the event day, where they're going to monitor the entry analytics, see how many people, how many attendees have attended the event. And of course, there's going to be handling of ticket problems, if and when they occur. And after the event day, there's going to be the final reports. Each of the user personas mentioned reporting in some way. So there's going to be a step where we take a look at all of the numbers from the event day. So that is the organizer. Let's take a look at what I imagine the attendees' interaction to be. So they first have this discovery phase where they're browsing the events, they're seeing what's available. So once an event's been found, you'll then want to check the ticket prices. Because a single event can have multiple different tickets or with different prices, you may share the event with your friends. Or in the case of the corporate event attendee, colleagues, or in the case of the busy parent attendee, with family members. And then we have coordinating group attendance, so who can actually go. And then we have selecting the ticket quantity, how many tickets we to purchase. And then we have reviewing the fees and the total, completing payment. I've said mobile payment here because they're all mobile first users. And then receiving digital tickets with the option to print them off. The event preparation in this stage is storing the tickets in the digital wallet, sharing tickets with friends, getting that event reminder. And then on the event day, it's arriving at the venue, quick scanning the QR code, entering the event, and then the post-event, in the case of the attendee, is usually sharing on social media, maybe following the venue for future events. And then we have the event staff. Now, I've positioned this more to the right in the sense that their involvement doesn't begin typically until just before the event day. So we have the event preparation, so accessing the event details, seeing the different types of ticket available, seeing the rules of each of the tickets. Maybe in the case of the coordinator, briefing the staff on the procedures. And then on the event day, we've got testing the scanning equipment, making sure the system actually works before we actually go to use it. We then have positioning the staff members at the different entry points, maybe verifying radio communications. And then we get to scanning the attendee tickets, handling any ticket issues. And then after the event, we have the debrief, which was mentioned in the event coordinator persona. So this might seem a bit whimsical, and I suppose it is in a way. However, what it does, at least from a user interface point of view, is identify the different stages. So we know that there's going to be, in the case of the attendee, some discovery. So there may be a page in order to search for events, which there almost certainly will be. Purchasing, there's going to be a purchase page. Event preparation, this might be different types of requirements, storing in a digital wallet, sharing the tickets with friends. And the same can be said for the rest of the user journey and the different user journeys that we have. So this is just a high level overview. Hopefully it's been useful, but then we can take this information going in to our user interface design. So in summary, we've explored the user journeys for organizers, attendees, and staff. The user journeys offer insight into how different users may interact with the system. And the user journeys will influence how the system is designed and implemented. So let's now take a look at the initial user interface designs. So this time we are in Figma, and I'm going to take you through how I've imagined this user interface to be. Now, this is, I suppose, like a wireframe in a lot of ways. Just instead of lines, I've used shapes. There's a lot of detail not in here, but we'll fill it in as we go further through the process. So I've tried to bear a few things in mind when I've designed this. I've tried to bear in mind everything that we've learned from the individual user personas. I've also tried to bear in mind the user journeys and how we've imagined them to be. And you'll see the stages in the user journey should match up to the different pages that we see here. So let's explore what we have. So I've got some different flows, if you will. And the first flow that we have is applicable to all of our user personas, and that's creating an account. And I've just got a simple page for this: create an account, add maybe a username and password, click on sign up. It'll give you a confirmation page to say check your email, because we'll need a valid email. And then that will give them the ability to log in with their account. With this, I've gone for complete simplicity. It's got the bare minimum number of moving parts, and it should allow the user to log in. Now, we can choose different views for how they log in and what they see depending on the user type, but ultimately the login will be similar if not identical. So let's now explore our organizers. So we have our organizers up here. So I imagine the organizers have a different landing page than everybody else. They may have a page geared towards business to business. So it may be describing the benefits of the system rather than describing all of the events that are available. So we have here, create, manage and sell event tickets with ease, maybe a big picture on the right-hand side here. Maybe it goes down to testimonials, etc. So a user can either hit this landing page, log in, hit create event, sign up, but I've included this just for completeness. So let's assume that one of our organizers has signed up, logged in, and they're able to go to their dashboard where they can create a new event. Now, I imagine this being a form where the user can input all of the information that they need to create an event. So that's going to be the venue details, that's going to be the pricing, that's going to be the different ticket types, etc. It's all going to be on this form, which is at the moment just represented by these different boxes. But once we model our domain a little bit further, we should understand exactly all of the different boxes, inputs that we need to put on this page. And that will give us a next round of refinement for a design. So creating a new event. So let's assume we created several events and they've been published and they're out there. So there's going to be a dashboard, and the dashboard is going to have several buttons on the left-hand side here, which haven't been represented, but we'll see the pages that they link to in just one moment. But I think on hitting the dashboard, there should be some sort of visual representation, some sort of graph, which gives fast feedback, fast information on exactly how their events are doing. In the case of organizers that handle multiple events, I imagine multiple different lines to be on this graph in some way. Maybe it's ticket sales that we display on here. So hitting the dashboard, we just get some fast feedback on how everything is going. And then if we click on a button on the side here, perhaps we want more information on ticket sales. And then we can go to the ticket sales page and we can view the individual ticket sales. Maybe there'll be some sort of filtering on here. Maybe there'll be some totals and numbers. I've just represented these boxes, which will allow us to basically display the information for each sale, when it happens, how much was sold for, what ticket type it was. I imagine it all being in these individual boxes. maybe with pagination, maybe with filtering. So that's one page on our dashboard. I also imagine there being an Your Events or event management page. So all of the events that we've created so far, they can be listed here. Now, how these two pages, the ticket sales and the event page sales, interact, I'm not too clear on. And this would be something I'd ask a stakeholder. Would you want to see all of the ticket sales for all of your events listed together? Or would you want to go to your events, click on the event, and then see the ticket sales? So we'll make a decision on that, but largely the pages would remain visually the same. And then we have your ticket types. Again, this would be a great question to ask. Would you reuse ticket types across multiple events? Or would you have different ticket types but only used in specific events? But again, the listing of them here with all the details, possibly giving the user ability to edit them. And then we have a reporting page. So this is where the user can go in order to select each of the different reports. There's going to be some reports which are event specific, and in which case we may link to them on the Your Events page. However, there's going to be reports which are across the board for all of the activity in the account. And I suppose we'd want to see those in a dedicated place. So that's what this Your Reports page is. Again, this design isn't set in stone and it will change, but this is how I'm picturing it at the moment going in. So that's our organizers. So let's now take a look at our attendees. So if we go to the top here, now I imagine the attendees are going to see a landing page which is different to what our organizers see, because they're here for a very different reason. They want to find tickets really quickly, really simply. So I have a page here which looks pretty similar to the restaurant review platform that we built. However, it serves much the same purpose really, which is a user can go search for a ticket. They can maybe filter by ticket type, maybe price if they're budget conscious, each of these filters here. They can then sort, and there'll be some form of pagination. But ultimately, we'll represent each of these different events with a card with all the information that they'd want to see. On clicking the card, they would then go to the event details page. So there may be an image of the event, there may be a carousel, something like that, where you can see multiple images. There'll be lots of information on the event, and maybe we can use some icons to represent the different facilities available at the venue, which is something that's been expressed as information that people want in the user personas. I then imagine there being the different ticket types that are available for the event. Again, nothing super fancy on this page, just nice and simple information, the different ticket types available. When you click on them, it will display information on that particular ticket type, including the price, the rules, what it gets you, and then you can choose to buy the ticket. On buying the ticket, you then go to the purchase ticket page where you enter your payment details, click on purchase. Now this is typically where you would integrate with a third-party payment system. We're not going to do that. However, you can completely replace this page once it's built with a third-party payment system if you so choose. However, we'll not cover it in this build. So we'll purchase tickets on this page, click on purchase. Thank you for your purchase. You get a confirmation. That would then send an email. Again, we'll not integrate with an email sending, but this is the event where you'd send that email, that notification. And then they can choose to go back to the search page in this case for a attendee. And I imagine that the attendee would also want a dashboard where they can see all their tickets for all their events, especially in the case of, say, the young event goer persona, where they're going to 2 or 3 events a week. They'd want them all listed out so they're easily available. Log in, click, and then you get details on the event. And then there'd also be a link to be able to show the QR code. And I've also put the kind of number for manual entering on here as well. And then that will give the ability for scanning on the event day. Now there's some details which isn't displayed here. Now each of these pages I imagine working on mobile. They collapse down fairly simply in most cases. There's also the digital wallet aspect. Now the link between the digital wallet and say this page isn't entirely clear. Now I imagine there's probably going to be some hoops to jump through in order to interact with a digital wallet. So we may have to not go as far as that, but there will be this page that the user can display in order to scan their QR code. So that's the basic flow that I imagine for our event goers, so for our attendees. And then the last user type, which is our staff. So they log in. I've only provided a mobile view or perhaps a tablet view in the case of our staff coordinator, but it would be much the same. all of the cards for the events that are live for those particular staff members, assuming that there's more than one on the same day. They'd then click through and it would stay on that page or this page that you're seeing now for the entire time. So the user can scan the QR code using this big button here. It would then open up the camera. They can then scan the QR code and then they'll get immediate visual feedback whether or not the QR code is valid or not valid. They also have the ability to enter the code manually. That will then bring up the keyboard. They can enter that in. But ultimately, this page is very simple, which is scan QR code. Is it valid or not? Move on to the next one. I've put the Browse Events button up the top, so that will bring you back to this page, just in case somebody misclicks. But I didn't want somebody to accidentally hit this button, so I've not put it down the bottom with the rest. And these two are actually very spaced out. You'd have to go all the way up to the top of the page and then click on Browse Events, which if you're holding a phone would mean using your other hand to click the top of the phone. So very unlikely to happen accidentally. So this is the user interface that I've imagined for the moment, and we'll refine this further in the coming lessons. So in summary, we've designed the first iteration of the user interface. The designs have been influenced by user stories, personas, and journeys. So let's recall what we've achieved in the user interface design module. In user personas summary, we explored the user personas representing organizers, attendees, and staff. These user personas will influence how the system is designed. In user journey, we explored the user journeys for organizers, attendees, and staff. And the user journeys offer insight into how different users may interact with the system. The user journeys will influence how the system is designed and implemented. In UI design, we designed the first iteration of the user interface, and the designs have been influenced by the user stories, personas, and journeys. In this module, we'll create a class diagram that represents the application's domain, and this should give us all the information that we need to design the application's REST API. So this module is structured as follows. We'll start by establishing the domain model. We'll then add cardinality information to the class diagram. We'll then add data type information to the class diagram, and then we'll define each variable as either required or optional on the class diagram. So now for the learning objectives. So by the end of this module, you'll be able to describe the domain represented by the application's domain diagram, add cardinality information to the application's class diagram, add data type information to the application's class diagram, and finally add required and optional information to the application's class diagram. So with this covered, let's get started. So let's take a look at the high-level summary of the domain model. So after spending a bit of time analysing the project brief using a variation on the noun-verb analysis technique, I produced the following domain diagram. So we can see represented here the user, the different types of user, organiser, staff, attendee. We also have the event, which offers ticket types. Those ticket types have tickets associated with them, which also have QR codes associated with each ticket. A ticket can be validated and a ticket can be sold. If you prefer, there's this mermaid.js diagram as well, representing exactly the same thing, slightly less colourful, perhaps a bit more formal. So let's now explore the domain objects. So let's start with the event class. It has a unique identifier, that's its ID, and it contains event details like the name, the date of the event, the time the event starts. It includes the venue location. And we also have a sales end date, and that's the very last date and time that tickets are available for that event. So now we have our ticket type class, which is different from a ticket. So the ticket type has a unique ID for identification. We have a name on the ticket type, such as VIP or standard. We also have a price for that ticket type. And we also have a total available property. And that's a number and defines the total number of tickets available of that ticket type. And now the ticket class has a unique ID. It also has a status, and that will allow us to have the status of cancelled, perhaps, if we do cancel a ticket. We also have a created date time, which records the date and time the ticket was purchased. We only create tickets when a user purchases a particular ticket type. Then we have our QR code, has a unique ID, and we have this generated date time, which stores the date and time it was created. And we also have a status. So if we did want to invalidate a QR code, we would do that by setting the status to invalid and generating a new one. We then have our user class, has a unique ID, and it stores basic information like the user's name and email address. And I've said here extended, but actually we haven't really formalized what that relationship looks like. But we have organizer, attendee, and staff, which are types of user. We then have our ticket validation class. That contains a unique ID, and it has a validation time. So that's the time that that particular ticket was validated, which may represent the time that a particular person tried to get into an event with that ticket. We also track the validation method used. Was it validated via a QR code, or was that ticket number manually entered? We also store the status of the validation result. Was the ticket valid, or was it not? So in summary, events can have multiple ticket types, each with their own pricing and availability. Users can act as organizers, event goers, and staff. Tickets include QR codes for validation at event entry. And ticket validation ensures proper event access control. So let's now add cardinality information to our class diagram. So here we are back in Miro. At this point, we've got a domain diagram. We have analysed some user personas. We've taken a look at some user journeys, and we've created our very first initial user interface design. Now we're going to get a bit more granular. On the assumption that our application is going to expose a REST API, we're going to evolve our domain diagram into a full-blown class diagram, and that will then allow us to design the REST API. So here is our domain diagram. We're now going to evolve this into a class diagram. So the process that we're going to follow is going to look a little bit like this. So the first step that we're going to follow is add cardinality to our diagram. If you're not sure what that means, don't worry, because we'll cover that in a moment. We're then going to add data types. So we've got properties identified, ID, name, date. What types are we going to use for those? And then 3, we're going to add the required or optional clarification on each of our properties. Which ones do we actually need? Which ones are truly optional? Let's just move that over here a little bit. And there are some other steps that we could follow, but for our activity today, we're just going to do these things here. This should give us enough information in order to then design our REST API. So let's start at the top. So we're going to need a text block for this. I'll put a star in there for the moment. Okay, so let's now move on to cardinality. So with cardinality, we're basically adding more information on the relationship. Relationship comes in 2 parts. We have a user here and we have a ticket. We're going to specify, in the case of the user, can a user have 1 ticket or multiple? And then the inverse. For each ticket, is there 1 user associated with it, or no users, or many users? We can define that all here. Now, where I say class diagram, we've already started using sticky notes in Miro, so we're going to carry that on, and then I'll formalize it in Mermaid.js. So let's get started and see how we get on. So let's start with this user ticket relationship. So a user purchases a ticket. So for each user, how many tickets do they purchase? Well, they don't purchase 0 tickets because there wouldn't be a purchase at all. They can purchase 1 ticket or they can purchase many. So we're going to say 1 ... star. Let's make that a bit smaller and we'll put that there. And what that means is for each user, they can purchase 1 or multiple tickets. However, of course, there is the case where the user hasn't purchased any tickets. So actually it is 0 to many tickets. You don't need to have purchased a ticket in order to create an account, I suppose is the assumption, especially when you consider that organizers and staff may not purchase a ticket and they are users. So that's much better. Let's just make that a bit smaller. There we go. So in the case of the ticket, is a ticket always associated with a user? Now, this is a good question. Do we only create tickets when a user purchases them? I think yes. Let's make that assumption to begin with. So let's say 1. So what this means is in the system, a user can have 0 tickets associated with them. They could have never purchased a ticket. They just simply have an account. Or they could have purchased many tickets, 1 or more. The inverse is to say that for a ticket to exist in the system, they need to be associated with a user. So I think we only create a ticket object when there's a purchase. And then we generate the QR code, and then that ticket is associated with the user and they can see it on their dashboard. Rather than having a whole bunch of ticket objects sat there that we then assign after the fact. Let's make that assumption and see how we get on with that. So that's our user ticket relationship. Now, in the case of the ticket QR code relationship, how's that going to work? Let's take a copy here. A ticket will have, I'm going to say 1 or more QR codes. And here's my rationale, here's my reasoning for this. When a ticket is created, we'll also create a QR code to be associated with that ticket. However, we may want to invalidate the QR code for any reason whatsoever. So therefore, we change the status of the invalid QR code to say invalid, and then we generate a new QR code and then assign that to the ticket. Now, in the case of the QR code, for a QR code to exist, does it always need to be associated with a ticket? I think yes, it does. Otherwise, we just have a whole bunch of QR codes without any context. And then considering a QR code would include the ticket information, it will almost certainly be associated with that ticket. Okay, let's move on. So this is just the initial thinking, by the way. It almost certainly will be incorrect at some point and we'll need to correct it. But this gets us moving. So let's now take a look at the ticket and ticket sale relationship. So when a ticket is sold, we get this ticket sale object, which we've separated out because we could have this information on the ticket, I suppose, but we've separated it out with the idea that if it's its own thing, we could potentially then collect them together for reports. So let's take a look at this ticket sale relationship. So a ticket can only be sold once. So we're going to say 0.1. Now I'm still a bit unsure on whether or not this ticket sale deserves its own object. It would have benefits when it comes to reporting, I think, because we can just interrogate a collection of ticket sales rather than the ticket themselves. So it would be dedicated for the purpose, but again, it's a bit abstract at the moment, so we'll have to see how it goes. But that's to say a ticket can either be, but that's it, isn't it? We've decided that we can only have a ticket. Yes. So a ticket must be associated with the user because a ticket is only created once it's sold. So I think what I'm going to do then actually is we're going to take the information from ticket sale, and even though the ticket sale is still an event that we need to be aware of, we might send notifications at that point, I'm going to add the information from ticket sale to ticket and then delete that object. Because actually I think it may very well be the same thing. If we're only creating a ticket once it's sold, then it will almost certainly have a purchase date time, a status. And I suppose if we did invalidate that ticket for whatever reason, we could then assign a new ticket to the user. That may be the way that we deal with it. So what about ticket and ticket validation? Now, whereas a ticket and a ticket sale, there'd only be one ticket sale per ticket because you can only sell a ticket once. I suppose there's a concept of resale, but we'll not support that in the system. So you can only support a ticket once. So it made sense to combine ticket and ticket sale. But I don't think that same argument is valid in the case of ticket validation because a ticket could potentially be validated multiple times. It could be a simple mistake. Perhaps the device scans the QR code twice, or it could be something more malicious, like a ticket is copied and several people attempt to get into an event using the same ticket. In either case, I think we should store ticket validation separately because it's going to be this case where a ticket can have 0 to many ticket validations, and a ticket validation must always be associated with a ticket. Okay, so now ticket and ticket type. In fact, I wonder, because this ticket type relationship, at least in my mind, is a bit unclear. So I'm going to come back to this and instead go up to the organizer manage relationship here. So we have an event and an organizer manages an event. What would the cardinality be for that? So I'm going to say an organizer can manage 0 to many events. It may be the case that it's a brand new account, doesn't have any events associated with it yet. Or it could be our corporate event manager that deals with hundreds perhaps. For each event to exist, does it need to be associated with an organizer? I think it does. So we'll do it that way. So an organizer can have 0 or more events, but an event always has one organizer. In the case of a team setup, because I think that occurred in the customer personas a few times, I think there'll still need to be a nominated individual that owns it. Maybe the team sharing, if that feature ever gets implemented, will then be a secondary mechanism. So the staff member works at an event. So I think in the case of the and we'll probably need to separate these out just so it's obvious which line's which. So the staff member works at an event. I think the staff member works at no events up to many. They can only work at one at any given time, but maybe they're working at multiple events in one day, for example, and therefore they're associated with many at the beginning of the day, is my thinking. So a staff member can be associated with 0 or many events. An event can be associated with 0 or many staff members. If the event's just created, I don't think it's going to have any staff members associated with it. That may only happen on the day, on the event day. So I think that's a valid state to be in. Now for attendees. So an attendee can have, and we'll put this, it might get a bit unclear. So let's move that on that side and move that on that side. So an attendee can have 0 or more events. So let's say somebody's just created their account. They're not going to have any events yet. However, they may have many events if they've attended or they're about to attend many events. So the attendee to event relationship is 0 to many. In the case of the event to attendee, I think it's probably the same. So we'll put that here to say that an event can have no attendees associated with them, so 0. It might be a brand new event, or it could have many attendees associated with it. Okay, we'll not put any cardinality on this relationship with staff, user, organizer, user, and attendee user, because I think this may be a subclass role relationship. It certainly is a relationship. So we'll not put any cardinality on that. So that leaves us determining the relationship between event, ticket type, next. So each event, I think, will have 0 or more ticket types. I think for an event to be published, it will definitely need at least one ticket type. However, when an event's first created, I think it's valid for an event to exist in the system without any ticket types associated with it. In the case of a ticket type, this kind of comes back to something I was wondering earlier, which is, can we just create ticket types in the system and share them between different events? Or is ticket types specific to the event? And I think I'm going to make a design decision to say that the ticket type is specific to the event. So that's to say that a ticket type is only associated with one event at any given time. So now ticket type and ticket. So the way that I'm picturing this in my mind is that an event can have multiple ticket types. Each ticket type has a total available count of tickets of that type that can be sold, like an inventory count, if you will. Every time there's a purchase, we create a ticket, we generate a QR code for that ticket, and then that ticket is associated with the user, which actually means, thinking about it, the created date time and the purchase date time of a ticket is going to be the same thing. But what about the cardinality? So each ticket is only ever going to be associated with one ticket type. And in order for a ticket to be created, there must be an existing ticket type. A ticket type, I think, can have 0 or more tickets. In the case of a brand new event that's just been published, I don't think there's going to be any tickets associated with that, 0. But in an event that's just before event day with loads of tickets sold, that's going to be a 0 to many association. We've been talking a lot about publishing events, and I've come to realize that we don't actually have a status on event to say that an event can be published. So let's add status while we're here. Okay, I believe that's all of the cardinality added to our domain diagram. So that's one on the list done. Next, let's add some data types. So in summary, we've added cardinality information to the application's class diagram. So let's now add data types to our application's class diagram, using the phrase class diagram loosely because we are using sticky notes here, but we will formalize this. So in order to add data types, we're going to go through our individual domain objects and then determine the data type of the individual properties. Now, the notation I'm going to use for this is the colon notation, which is a little different from what we'd see in Java, but I think it will make it more readable, at least for the time being. We can always change it when we formalize it in Mermaid.js. So let's start with the user. So a user can have an ID. Now, what type of ID can a user have? I think for maximum scalability, we should probably go with a UUID. So an ID is a UUID. A name, let's just go with a string for a name. an email is going to be a string. See this colon notation rather than put string in front. So that's our data types for user. Let's carry on through. So for a ticket, I think having an ID as a UUID makes perfect sense. Now for status, the status of a ticket, I think this should be a ticket status enum. There should be some clearly defined statuses for our ticket. Cancelled, active, I think they should be initial ones. I'm not going to represent ticket status here, but just know that we'll use an enum for this. Maybe we just rename it enum to make it obvious. Okay, created date time, that's going to be a local date time. So we're actually going to use the Java class in this particular case in order to be specific. In fact, for consistency, perhaps we should do that up here. There we go. In actual fact, a UUID may also be represented as a string type, but we'll leave it as UUID in order to communicate that. And we've got status twice for ticket, so let's remove that one. Let's see if we can just make that all fit. Not easily. Okay, so that's the types for ticket. What about QR code? I think QR code is going to need a UID type as well for consistency. Generated date time is going to be a local date time. Status will have another enum, QR code status enum, which I think might be very similar. So active, cancelled, invalidated, something like that. Okay, what about our ticket validation? It's going to need a UID as a type. We'll use that consistently now. Ticket validation, that's going to need a status enum, I think. So ticket validation enum. And that'll be whether or not the ticket passed validation or failed validation. Or maybe there's a third status where the validation itself was removed or invalidated. I think it gets a bit meta at that point. But basically that will describe whether or not the ticket validation was a pass or a success. Validation date time, we'll use local date time for this. Validation method, again, that should probably be ticket validation method enum. Clearly defined choices for this one. It's either a QR code scan or it's a manual entry. And they're the two options that we know about so far. So that is a good use case for an enumeration. So what else do we have over here? So ticket type. At this point, we know that's a UUID. The name of the ticket is almost certainly going to be a string. Total available. We'll have to think about the proper numeric type for this, but I think an integer is probably going to cover most cases. We might have to go larger to a long, maybe a big int. We'll have to see. For price, how are we going to represent price? I think there's a few different ways of doing this, but we'll assume that it's a double for the time being, I think. Okay, so that's done, that's done, that's done, that's done. Event, let's do event next. So ID is going to be a UUID. Name, string. Date, local date time. Oh, we have a separate date and time. Maybe we should, Now this is a good point. I think what might be a better way to do things if we say start date and then, or start date time, or maybe just simply start and then end, like that. And then we have clearly defined start and end times for the event. And then from that, we can extrapolate things like the duration of the event, the venue. Now, the more I read into this, I'm starting to think a venue is probably its own object. But for this first iteration of the system, we'll just do a string, a description of the venue and its various different facilities and amenities. Sales end date, local date time. Maybe we should also have a sales start date. You may want to schedule a ticket to go live at a certain time. So let's add that right there. And then we have a status for an event. So I think there's going to be an event status enum. Again, we can determine what sort of statuses an event can be in. I think draft, published, cancelled, but we can confirm that when we come to implement it, as long as we know we're using that enum. And then we have our organizer, staff, and attendee, which are types of users, but are almost certainly going to have information associated with them. In the case of the staff member, they may be assigned a certain entry point, which is a concept that we've not yet represented in this diagram. But as the entry point is also event specific, I think rather than go down that rabbit hole, we'll just leave it for the time being. So organizer, staff, attendee. Okay, so looking at these objects, it looks like they all have types at this point. So we've done number 2, we've added our data types. So in summary, We've added data type information to the application's class diagram. So let's now define whether or not a property is required or optional on our application's class diagram. So let's now look to capture the required and the optional instance variables on our classes. We're going to represent a required instance variable with an asterisk and then an optional with a question mark. And I'm going to put this on the type. So in the case of the ID, we'll certainly need an ID. So that's an asterisk. A name, that's going to be required for a user, as is an email. For the ticket, we'll certainly need an ID. We're going to need to know the status. A ticket should always have a created local date time. In the case of a QR code, we're always going to need an ID. We're always going to need a generated date time, which for consistency perhaps should be created date time. And we're always going to need to know the status of that QR code. So another required. For ticket validation, we're always going to need an ID. We're always going to need to know the status of that validation, otherwise it's not going to exist. Validation date time, that's required, as is the validation method. Over on the ticket type, we're always going to need to know the ID. We're always going to have a name for a ticket type, a friendly name. Total available. Now this is interesting. Do we need a total number of ticket types available? I'm actually going to mark this as optional. And my thinking behind this is there may be an edge case somewhere whereby we can sell unlimited number of tickets for an event. And I'm thinking maybe like an online event where space isn't an issue. So in the case that tickets are unlimited, rather than put in a really high number here, let's just make it null and never have a limit. So I'm going to make that optional. Price. I think even in the case that it's free, we should specify 0. So let's make that a required field. So let's go up to event now. Asterisk, we need an ID, we need a name. For an event, do we need a start and end time? Are we ever going to have an event without a start and end time? I don't think that we are. So we're going to go with an asterisk saying that it is required. Venue, yes, we're going to need to have a venue, a sales start date and a sales end date. I think we're going to make this optional. I think in order to be published, which is the status, which is required, we're going to need to specify a start and end date for sales. But if we've just created an event and it's in draft status, we don't yet know when it's going live, I think having sales start and end date as optional parameters makes more sense. And looking at things, I think that is everything marked up. So I think with that, we've completed step 3, which is we've added required and optional annotations to each of our instance variables. So the next step for me now is I'm going to formalize this into a Mermaid.js diagram, but next we're going to design our REST API. So in summary, we've added optional required information to the application's class diagram. So let's now recall what we've achieved in the domain modeling module. In domain model summary, we established that events can have multiple ticket types, each with their own pricing and availability. Users can act as organizers, event goers, and staff. Tickets include QR codes for validation at event entry. Ticket validation ensures proper event access control. In domain modeling, cardinality, we added cardinality information to the application's class diagram. In data modeling, data types, we added data type information to the application's class diagram. In data modeling, required and optional, we added optional and required information to the application's class diagram. And in data modeling, required and optional, we added optional required information to the application's class diagram. In this module, we'll design the REST API for our event ticket management platform. This design will work as the blueprint for our implementation. The module is structured as follows. We'll start by designing the event organizer's REST API endpoints, and then the event attendee's REST API endpoints, and then the staff's REST API endpoints. So now for the learning objectives. So by the end of this module, you will be able to design REST API endpoints for event organizers to create and manage events. Design REST API endpoints for attendees to browse events and purchase tickets. Design REST API endpoints for staff to browse events and validate tickets. So with that covered, let's get started. Let's analyze the organizer user interface flow in order to identify some REST API endpoints. Now that we have a class diagram and we also have our user interface design, we can get to designing a REST API. To do this, we're going to go through our user interface design. We're then going to determine what endpoints it would use, write up the endpoints on the notepad on the right-hand side here, using our class diagram in order to fill in the blanks. So let's get started. So we have our sign up page. Now, I think for the initial build, we're just going to skip over the concept of a sign up page. It'll be simple enough to add one afterwards, but I think we'll just create users in whatever platform that we're using, say Keycloak, and log in as those users. So we'll deal with the sign up page in the next iteration. However, the login page, that's certainly going to be required. Now, assuming that we're using OAuth 2 and OpenID Connect, the front end will redirect to Keycloak where the user logs in, and then we'll redirect back. So in the case of the login page, I don't think that we need any endpoints. We don't need to design any REST API endpoints for that. So let's move on up to, here we are, the event sign up page. So looking at this, I don't think we need to create any endpoints here either. Create an event, browse events. Yes, we'll certainly need to implement REST APIs for those, but not in the case of this page, I don't think. So let's scroll down to create a new event. Here we are. So we'll certainly need a REST API endpoint for this, at least one. So creating a new event, that's typically going to be a HTTP post request, where in the body is going to be our new event. So in the case of our event diagram here, we'll be sending a representation of this object, which if we imagine it's JSON, for example, it may also include the ticket type. So in this case, then I'm going to say a post to / we'll use this API prefix. We might as well version it while we're here. API v1 events, going with that plural. And as a post, we'll assume that that's going to have, in fact, we'll note it down. The request body is going to be an event object. And for better notes, let's say create event. So that's our create event endpoint. Do we have anything else on here? We'll construct the JSON using this form, and we could very well post it as a form, but we'll handle it, I think, in JSON. And then I think that's all for that particular page. So let's continue on. Okay, so the dashboard page. Now we haven't quite determined what we're going to display as the diagram, as the chart on the dashboard page. I think it's going to be ticket sale data. So I'm going to actually make a note here and we'll say to do dedicated endpoint for report data. Report endpoints can get quite tricky, especially when they have to aggregate and combine different data. So I don't think it's going to be as simple as requesting data from a resource endpoint. So in the case that we have one represented here. So that's I think that conversation gets quite abstract. So we'll leave that to do up until the point that we actually look to implement that diagram, that chart on that page. But I think that's all that's represented on that page. Logout will be done via Keycloak. Dashboard is just a navigate to this page. So what about ticket sales? Here we go. So we've combined the concept of a ticket sale object and a ticket object. So over here, it's just ticket. There's no more ticket sale. So in which case then, I think to populate this page, it's going to be a get call to API v1, that being our prefix, and it's going to be tickets. Although that does make the assumption that we want to see all tickets for all events. Because if we look at our class diagram here, tickets must have a ticket type and a ticket type must have an event. We know so because of the cardinality of 1, 1. So actually, I'm starting to think that the page flow should be with the events first, and then once you click an event, you then have the option of viewing the ticket sales. So in which case, let's park that for one moment and think about this your events page. So we'll almost certainly want to list the events. That's going to be a HTTP GET call to API v1 events. And we'll call this one list events. And that's what's going to populate this list. Now there may be some kind of modal, maybe it's a separate page which displays detailed information about an individual event. In which case we'll need a get event or a retrieve event endpoint, which just returns 1, which will be get API v1 events, and then the event ID. Basically the same as we've got for list events, but specifying the ID, and that will return a single event. And we typically do that because this endpoint will contain more information than on the list endpoint, which will usually contain like a summary, a subset of all the information available for each event. Would we delete events on this page? Possibly. Would we update them on this page? I think yes, possibly. So I think clicking on some kind of edit button down here would then redirect back to the same form that we used to create an event, but with the data populated, let's say. So I think we're going to need full CRUD for this. So let's say we need an update event endpoint, which let's just make it a put endpoint at the time being. We can make a patch endpoint, which means, but the difference being that we need to provide a full representation of the event every time that we call the put endpoint, but we can only provide a partial one for the patch endpoint. Let's make it a put because they're typically simpler to implement and we might be time constrained. We can always move over to a patch endpoint if there's benefit in doing so. So we have an update event endpoint, and with that, the request body is going to be an event, a full event. And we also decided that we're going to support deleting events, which is going to use the delete endpoint, API v1 event specifying the event ID. There we go. So full CRUD for the event now, and that will make this page possible. So what about ticket sales? So we've decided that there's going to be some way of navigating from the event to the ticket sales where the ticket sales is on a per event basis. So what that means for the endpoint, well, first we want to list ticket sales. So we're going to do a HTTP GET API v1, but because of the way that the ticket and the event is associated, the way that they're related, the relationship, we're going to say events, event ID, / tickets, in order to only see tickets for that event. And that will allow us to populate this table, this list, with tickets for that particular event. I don't think we should support the ability to delete a ticket because it's very likely that somebody has purchased one of these tickets. They have purchased one of these tickets in order for it to appear in this list. What about updating a ticket? I think we should support the ability to cancel a ticket, and I think we should do that by partially updating the ticket status. So remembering that we've got a ticket with this ticket status enum. To cancel a ticket, we would perhaps update this enum to be from active to cancelled. That would trigger a notification to be sent then to the user saying the event's been cancelled, please contact customer support, etc. So we'll do that with a partial update endpoint. Let's go back to our user interface. And that will be exactly the same endpoint as we've used for list ticket sales, but rather than get, we'll use patch, and the request body is going to be a partial event. We only provide the status in the case of the HTTP patch. That's the convention. There we go. We don't want to add deletion. We do want to add partial update. Do we want a retrieve? Yes, we probably do want a retrieve endpoint. So if we were to click on one of these rows, do we want to get more information about that ticket? Yes, we do. So we're going to add another endpoint, retrieve ticket sale, and it's going to be get API v1 events. In fact, we're just going to copy this. And it's going to be / tickets and then / ticket ID. There we go. So that will allow us to retrieve an individual ticket that's associated with an event. And I believe that's all that we'll need for this page. Now, if we scroll down to ticket types, it's a similar layout. We'll want to see the individual ticket types for the event. Now, this is interesting. So we've got two pages, ticket sales and ticket types. Would you want to see sales from all the ticket types in one place? Or would we want to see sales broken down by ticket type primarily? If I'm picturing it in my mind, I think ticket sales would display all of the tickets of all the ticket types. There may be a filter, however, as some secondary functionality, and there may be an indicator on each of these rows to say what the type of the ticket is. So that means the API endpoints that we've created here for tickets are still valid. We don't need to nest them in ticket types. So what that means is when it comes to ticket types, and we're going to have a list ticket type, endpoint now, HTTP GET, API v1, is still going to be nested in the event. So event ID / ticket hyphen types. And that's going to list all of the ticket types for that event. And that will populate this list. We'll probably want a retrieve. So a retrieve ticket type. And that will be exactly the same as list ticket types. But the convention is, of course, to specify the ticket type ID. And that will give the information for the individual ticket type. Do we want to support the ability to delete and update a ticket type? Let's take a look at the ticket type over on the class diagram here. So a ticket type has 0 or more tickets associated with it, has a name, total available, and a price. So we did have that requirement that, or I say requirement, when I imagined the customer journey, I pictured that somebody might want to update the price once the ticket type has already been made live and available to purchase. But then if we're storing the price on the ticket type rather than the ticket, that could make things complicated. So having thought on it, I think if we were wanting to support the ability for a user to update the price of a ticket type after the ticket type or after the event associated with the ticket type has been published, then that would mean that we wouldn't necessarily store the price on ticket type. We would have to introduce or reintroduce the ticket purchase object and store the price on the ticket purchase object. Because if the price on the ticket type can change, we'll need to keep track of the price that was paid for that ticket before the change, so at the time the ticket was purchased. Again, that's a bit abstract. So in order to keep things a little simple for this first iteration, I'm going to say that we can't update the ID of a ticket type. We can't update the price. We should be able to update the total available, and we should be able to update the name. So that's going to be a partial update. So let's make a patch endpoint for this. So we'll say partial update ticket type. And that's going to be a patch to exactly the same endpoint as our retrieve ticket type. So specifying the ticket type ID, where the request body is going to include a partial ticket type, which just includes either the name, the total available, or both, but not price and not ID. I think we should support the ability to delete a ticket type, but we should add some additional validation on that so that you can't delete a ticket type that has tickets associated with it, because that would cause issues. So if we copy our retrieve ticket type endpoint, change it to be delete ticket type, change from get to delete. There we go. I think that should give us everything that we need to use this page. And then we have the reports page. Now, it would be very easy for me to prescribe the type of reports that we're going to see on this page. Maybe a return on investment report or something like that, something which shows the revenue per event. Maybe an attendance report. But I think what I'm going to do instead is we'll defer the design and implementation of reports until the rest of the system is implemented, because then we'll know exactly the type of information that we have available to us, and then we can design the REST API for reports in that iteration. And that'll be much easier because we'll have much more information at that point. So with that done, let's just go over to the next row here, and this is the event. So this is the attendee row, and there'll be lots more to add right here. So in summary, we've identified multiple REST API endpoints from the organizer user interface flow. Let's continue our user interface analysis, this time the attendee flow, trying to identify those REST API endpoints. So here we have our landing page for attendees, where you can search using the search bar, you can filter your results, the results are displayed as cards, and we support pagination and sorting. Now my immediate thought is we need a HTTP GET call to API v1 events, but we already have that right here. And this call is used on the dashboard to display events that an organizer has created. Now there's a couple of different ways that we can approach this. we could go API v1 events /search, but search is a verb. We don't really want a verb in our URL path because that doesn't follow best practices. We could do a query parameter, and wherever we provide a query parameter, it might be Q for query, then we return a search result. And if it's not there, we just return a list of events. But again, with this approach, it's different functionality on the same endpoint. So that doesn't sit quite right. So I was thinking about this, and what we're doing here is we are searching for published events. So I think what I'm going to do then is down the bottom here is we're going to say the endpoint is called search published events, and it's a get call to API v1 published -events. And that differentiates it from listing the events which are then associated with the user, typically the organizer. Let's just change that to be published events. There we go. So I'm not completely happy with that endpoint, and we'll see if we can refine it in future designs, but that should do what we need it to. It should allow us to search, support sorting, filtering, pagination, and return results. So I think we'll move on and see if we can refine that once we learn a bit more. So now we have the event details page. Again, we also have an endpoint to retrieve an event, which is this one here, API v1 events event ID. However, I think because we've separated out this concept of a published event, and it will almost certainly be the case that we'll have different information in the response body for published events versus just an event, which may contain more sensitive information. I think we should carry on with this concept of published events to populate this page. So we'll call this one retrieve published event, and it will be HTTP GET API v1 published -event with the published event ID. And that will return an individual published event, which will be all the information to populate this page. And none of the sensitive information, which you may see on the other endpoint up here, so the retrieve event endpoint, which is only used by organizers. So what else do we have on this page? We have details about the event's ticket types. I think in this particular case, we should nest that information in the returned published event. So I think that should all be driven by the same endpoint. But then we have this by ticket endpoint. I don't think we'll need an endpoint to drive that. In the case of, say, a third-party payment system, you may need a back-end endpoint to initialize a payment session, perhaps. But as we're not integrating with a third-party payment provider, we'll just say that this will redirect to the purchase ticket page. Now, because we're not integrating with that third-party provider, we should probably create an endpoint at least to mock out the ability to purchase tickets. We certainly wouldn't want anybody to enter real credit card information into this, but it will allow us to develop a system which is as close to real life as possible. So, in order to do that then, let's create a purchase ticket endpoint, and we'll say that it's a post endpoint to API v1, and I think we should say published -event, the published hyphen or published _ event ID, the naming convention. Syntax highlighting has changed. Shell script. Let's change that back to Markdown. There we go. The naming convention doesn't matter too much. So that represents the published event ID. But then we'll also want to specify the ticket type. So we'll then say ticket hyphen types / ticket hyphen or _ types ID. So it's a bit involved, but basically we're specifying the published event, the ID of that published event, and then the ticket type ID that we want to purchase. We then post, in the case of a real payment system, that would be payment details. In the case of our system, we'll just post some mock details. We'll post, and then that will purchase the ticket and then go through that payment flow on the back end. So I think that's going to be enough to drive this entire page. This is just a notification and a back button. And then we have your tickets, which is a list of all tickets associated with that user. Now, this is interesting because if we scroll up here, we have list ticket sales, which is probably the closest endpoint, and it's tickets nested within events. So actually, and it is consistent with the rest of our API, to create a list tickets, and I'll put in brackets for user, a get call to API v1 tickets. And that will simply list all tickets associated with that user, which will populate this page. We may also want to do a few things, I suppose, with that ticket. We may want to retrieve the ticket details. That's something we've been doing with the UI, or assuming that we're doing with the UI. So retrieve ticket. And this endpoint will be a get call to ticket underscore ID. And that will retrieve the details to say if we were to open up a modal with all of the ticket details in there, do we want to offer the ability to cancel a ticket, to delete a ticket, update a ticket? I don't think so, not in this iteration. So I think listing a ticket, retrieving a ticket, this is like a read-only page. And I think that's enough to drive this entire page then. Okay, and then we have the ticket QR code page. So this is, I believe, going to be an image that will load. So let's create a dedicated endpoint for it. I think this number could very well be, no, I think what we'll do is we'll say this information will be in the retrieve ticket. This will be the additional information that's in retrieve ticket. This number here, but this is an image. No, it will need a dedicated endpoint. So let's say retrieve ticket QR code, and it will be the same endpoint with QR codes after it. That will return the image. Now, there's various different ways to do this. You might have a CDN, in which case you won't need to have an endpoint like this. But for the sake of our system, let's have this endpoint, which returns an image, which is that QR code. All the other information, including the number for manual entry, that will be in the retrieve ticket. Okay, and with that done then, I think that completes the REST API design for the attendee flow. So in summary, we've identified several more REST API endpoints from the attendee user interface flow. So now for the last UI flow. Let's explore the staff user interface flow, trying to refine our understanding of our REST API endpoints. So let's start on page 1 of 2, which simply lists all of the events associated with that event staff member. Now, if we look through here, I think this would be this endpoint here, listing events. So we previously used this in the organizer flow to list events associated with the organizer. So events the organizer has created, perhaps ones that they have access to from other team members if we get to the point of implementing that feature. I think this will work just as well for this page here. So it lists all of the events for the staff member that they're associated with. We could use the information, assuming something like OAuth2 and OpenID Connect. We can use the information in the JWT to determine which events to return, because we can use that to identify the user. And the event object structure returned from this endpoint should be the same as for the organizer. So yes, I'm pretty confident we can reuse this endpoint in order to drive this entire page. So with that done then, we can move on to the second page here, which is the QR code scanning page. So this page does one thing, but it does it in two different ways. It scans QR codes in order to see if they're valid or not, and then allowing the event staff to determine whether or not the person is allowed into the event or not, or doing that same flow, but rather than scanning the QR code is entering the code manually. So how would we model that in our REST API? If we scroll down to the last endpoints that we've created here, so I think this is going to be a new endpoint, but I think it's going to be nested under the event. So if we scroll up and put that with the other event endpoints, so we have create event, list event, retrieve event, update event, delete event. I think there should be another endpoint here, which we'll call validate ticket. And it will be a post to API v1 events, because it will be on a per event basis. We'll specify the event ID, and it'll be / ticket hyphen validations. And a post to that endpoint using data either from the QR code or entered manually should then return a response, which then gives the user the feedback that they need to make their decision. And I think we can use the same endpoint for both QR codes and entering manually. And potentially, we could then extend this with get or list, perhaps, list ticket validations, and it will be exactly the same endpoint, but using get. And we can use this endpoint on the dashboard to then return a list of ticket validations for that ticket, which would be helpful in then determining if there's any problems with a ticket. And we can do this because if we go back to our domain model here, we have a ticket, and a ticket can have 0 or more ticket validations. So we can list them out using this endpoint and then look at each of their statuses. So I haven't quite got it figured out in my mind yet, but this endpoint would then drive the feature by which an event staff member or an event organizer could look at the list of ticket validations for a ticket and get the history and figure out what's going on. This ticket has 200 ticket validations and only the first one has worked. Why is that? So this should give the users the information they need to make decisions, which is something that was mentioned in the user personas, I believe. So I think with that, if we just go back to our page in Figma here, I think that completes this flow, which gives us our initial design for our REST API. So let's expand this and just go through what we have. So we have a create event endpoint, post to API v1 events. Let's zoom in a bit more. So create event, post to API v1 events. We need to provide the request body, an event in the request body. We have an endpoint for listing events that will return a JSON list of event objects. That will be used to populate dashboard pages. Retrieving an event, the same as list events, but we specify an event ID in order to get more information about that particular one event, again used on the dashboard. Updating an event, we're using HTTP put, so we need to provide the full event information in the body, and we can see that here, request body event, and that will allow us to update the event. Thinking on it, we've used patch everywhere else, so we may swap this from being a put to a patch, but we'll see. Then we have delete an event, and that allows you to delete an event by specifying its event ID, also used on the dashboard. We have our validate ticket endpoint. That's a post to API v1 events, event ID, ticket validations in order to create a ticket validation and give feedback on if that ticket is valid or not. We have list ticket validations, which would drive a page listing the history, the ticket validation history of a ticket. We've got list ticket sales, and that's all of the sales of tickets associated with an event. Retrieve a ticket sale, just like list ticket sales, but returns one ticket sale by specifying the ticket ID. We then have our partial update ticket endpoint, and we're going to use this on the dashboard in order to update a ticket status. So it should be partial event, but it should be partial ticket, which is a synonym for ticket sale in this context. They're the same object. So we then have list ticket types for the event, retrieve a ticket type for the event, so that will have more information in there, delete a ticket type for an event. We should add some validation to make sure we can't delete ticket types with tickets associated. Partial update the ticket type. So that will be updating the name or perhaps the total number of tickets available. Again, we would probably need to add validation for that. And then we have searching published events, and that will drive the landing page for attendees. Retrieving published events, that will be the published events details page. Purchasing a ticket, API v1, published event ID, ticket types, ticket type ID, including, in our case, dummy payment information, but in the case of a real live production system, this would probably be an endpoint that's on the third-party payment provider's side. We then have listing tickets for user. That will drive their dashboard. Retrieving tickets for user. Again, this specifies the ID to get more information about that ticket. And then retrieve tickets QR code, which has the QR code suffix here in order to just return the QR code image. And with that, we have our initial design of our REST API for our application. So in summary, we've identified several more REST API endpoints from the staff user interface flow, and we've completed the initial REST API design. We've learned a lot about the application that we are to build. Let's use this knowledge to design our application's architecture. We've learned a lot. We've gone through our domain, we've gone through user personas, user journeys, we've designed our UI, we've created a class diagram, and we've designed our REST API. So we have a pretty good idea of the basic functionality our application needs to provide. However, one thing is for certain, and that's that our application is going to be a Spring Boot application. So let's make that green, let's put that in the middle, and we'll say event ticket app backend, and that will be a Spring Boot application. So that's going to expose a REST API. We're going to use a single page application like a React or an Angular application rather than rendering the pages server side in the Spring Boot application. Now you can do that, of course, but the single page application is considered by some the more modern way of doing things. So let's create another sticky note here, and we'll say event ticket app front end. And the technology, my technology of choice at the moment for front end applications, single page applications, is React. So we're going to build that one in React rather than Angular. Let's just format that consistently. So that's going to communicate with our backend via the REST API. And that text is very small, so we can make it bigger. So we have our event ticket app, our React application. That's what our user is going to interact with. And then we have the backend, which is Spring Boot. And then we have that REST API. Where are we going to store our data? Now, if we go back to our class diagram, which I believe is this one here, we can take a look at this and see the relationships between the classes are pretty clear. So this would certainly work with the relational database. And in the spirit of keeping things simple, in order to build our application, I think we should use a traditional relational database for this. Although that's not to say that you can't use a NoSQL database like Mongo, or perhaps something like DynamoDB for this. But the approach would be different. So let's use, if we go back over here, let's use another sticky note, maybe make this one yellow. And we're going to say database. And now to choose the database. Now my database, relational database of choice is PostgreSQL. And PostgreSQL happens to have some pretty good fuzzy searching capability as well. Otherwise, we would potentially need to spin up some Elasticsearch instance or something like that to handle searching. But I think in the first instance, we'll use Postgres just so we can limit the amount of infrastructure that we need to set up. So we have somewhere to store data, we have somewhere to put our business logic, expose a REST API, and then we have some means of exposing an application to a user. What are we missing here? Well, we need to deal with authentication and authorization. And rather than build that from scratch, I think we should leverage another piece of architecture to handle that for us. So let's create a purple post-it here. And as it's easy to run locally and it won't cost you anything to run, let's make this Keycloak. And that's going to be our authorization server. See if we can fit that on one line. There we go. And that's going to be Keycloak. And we can run that in Docker, and our backend is going to interact with that, but then so is our front end. So we can make those lines a bit more obvious. There we go. And I think initially that's all we're going to need. We could plug in all sorts of different pieces of software in order to add additional features, but I think we've got the basics of what we need. We have somewhere to store data. We have our Spring Boot application where we're going to be coding all our business logic. We have our React application, which will allow the user to interact with a front end, with a user interface that then interacts with our backend via a REST API. And we have ourselves an auth server. So we have Keycloak, and through that we can handle user creation, and we can handle authentication with the backend and authorization as well. And we'll need to do authorization in this app because we have those different types of user, the organizer, we have ourselves the attendee, and we have the staff member. And each user type, and we'll need to control what each user type can access. So I think that's all we're going to need initially for our architecture. So I think initially this is our architecture design. So in summary, our architecture includes a Spring Boot backend, a React frontend, a PostgreSQL database, and a Keycloak server. So let's summarize what we've achieved in the system design module. In REST API design organizer flow, we identified multiple REST API endpoints from the organizer user interface flow. In REST API design attendee flow, we identified several more REST API endpoints from the attendee user interface flow. And in REST API design staff flow, we've identified several more REST API endpoints from the staff user interface flow. And this completed the initial REST API design. In architecture design, we established that our architecture includes a Spring Boot backend, a React frontend, PostgreSQL database, and a Keycloak server. In this module, we'll set up a new Spring Boot project and configure it with all the tools that we need to build an event ticket platform. This includes creating the project, connecting it to a database, setting up authentication, and configuring helpful development tools. The module is structured like this. We'll first create a new Spring Boot project. We'll then explore the project structure. We'll then set up and connect to PostgreSQL. We'll then set up and connect to Keycloak. And then we'll configure MapStruct for object mapping. So now for the learning objectives. So by the end of this module, you will be able to create a new Spring Boot project using the Spring Initializer. Describe the structure and content of your new Spring Boot project. Run PostgreSQL and connect your app to it. Run Keycloak and connect your app to it. And configure MapStruct in the application. So with that covered, let's get started. Let's create the new Spring Boot project that will serve as the foundation for our event ticket platform. We'll use the Spring Initializer to set up our project with all the necessary dependencies and configurations that we need. So here we are back in the Spring Initializer, so on start.spring.io. Let's go about creating our skeleton project that we can then build our application from. And the Spring Initializer is going to help us to do just that. So let's select some configuration options for our project. Let's use Apache Maven as our build management tool, and we're going to use the Java programming language. Now, as for Spring Boot version, we're going to choose the latest general release version, which at the time of filming is 3.4.4. We're going to ignore any of the snapshot versions, and we're going to ignore the M3 version here, so milestone 3, because they won't be as stable, at least in theory, as 3.4.4. So we'll select that one there. So for the project metadata, I'm going to go with com Devtiro. For the artifact, I think I'm going to go with tickets. For the description, an event ticket platform. So the package name is com.devtiro.tickets, and that's fine. For packaging, we're going to go with jar. We're not going to be deploying to a running application container. We want it bundled into the jar. So we're going to select jar. It makes it easier to run our app. For Java version, we're going to select Java 21 as the latest long-term support release at the time of filming. So that's the left column complete. Let's now head over to dependencies. So we click on add. We know from our architecture design that we're going to need a REST API. So we're going to select web. We could select reactive web and make use of that reactive programming model. And when streaming data, that would be a great idea. However, it does have some more cognitive load. We need to do more thinking when working with that model. So for our event ticket platform, at least initially, let's select Spring Web, as it will be simpler for us as developers to build, and it will still give us very good performance. Now, we're also going to be building a secure application. So let's select Spring Security from this list as well. And as we're using Keycloak, our Spring Boot backend is going to be a resource server. So let's select OAuth 2 resource server from the list as well. Now, as for saving data, we're going to be doing that in a Postgres database. So let's grab the Postgres driver, and let's also grab Spring Data JPA. And this will allow us to interact with our database using Java objects rather than writing SQL. So let's add it to the bottom of the list. And to make things easier on ourselves, let's also use Project Lombok. That will reduce the boilerplate code that we write in our project. Now, there is one more dependency that we're going to need to add here, and that is the H2 database. Now, it's not strictly needed. However, if we do use the H2 database, we can then use that inside of our tests. We won't be actively writing tests for this project. We will just be focusing on the building side of things. However, there will be a single test when we download our project from the Spring Initializer, and it would be nice for at least that one test to pass. Without the H2 database, it will only pass if we connect to a PostgreSQL database, which in this case is going to be our production database, for lack of a better word. So if we use the H2 database, that will run in memory in our tests, and they'll be isolated from our real PostgreSQL database. So that's on the bottom there. So in summary, we have our H2 database, we have Lombok, we have Spring Data JPA, we have the PostgreSQL driver, we have OAuth 2 resource server, Spring Security, and Spring Web. So if we now click on Generate, that downloads our project as a zip file. So what we need to do now is unzip this file and then open it up in our IDE, which in this case is going to be IntelliJ. So in summary, we've created a new Spring Boot project using the Spring Initializer. We've set up core dependencies for web, security, and data persistence, and added development tools like Lombok to improve productivity. Let's now explore the structure and the content of the Spring Boot project that we've just created. So here we are in IntelliJ, and I've opened up the project that we've just downloaded from the Spring Initializer. So let's do a quick overview of this project to make sure that we are familiar with it before we start building out our event ticket platform. So let's start expanding these directories. So we have ourselves here the standard Maven project structure, source main Java, and inside of there, com Devtiro tickets, which was the group that we specified in the Spring Initializer. If we open up this class here named tickets application, we can see it's a main class. So public static void main, Spring application.run, and we can see we've got this Spring Boot application annotation on the top of our class. So all that to say that this is the entry point to our application, and it will run our Spring Boot application. Let's see what else we have in this project. So in source main resources, we have a static directory, which is empty, templates, which is also empty, and then the application.properties file. Now we're not going to need static and we're not going to need templates, so we can delete those. We would only need those directories if we were doing server-side rendering of our HTML pages, which we're not, because we're going to be using a single page application, so our React front end, so we can safely delete those. Let's take a look at our application.properties file. So this is where our Spring Boot configuration will be. And at the moment, it only has a single property, which is spring.application.name, specifying tickets, so the name of our application. Now we also have a source test Java directory here. We can also see com.devtiro.tickets, so the same group inside of our source main Java, so they're mirrored. However, we can see we have a single test class inside of here, tickets application tests. So our application only has one test, and this test should pass out of the box. It simply just tests that the Spring context loads. So if we try running this test, just pull that up. There we go. We can see that the test passes absolutely fine. So if we minimize this, it is worth noting that if we didn't include the H2 database dependency, our test wouldn't pass. It would fail because we're currently not running our PostgreSQL database. However, as we did include that H2 dependency, our test passes fine, as it has a complete Spring context using that H2 database. So if we now minimize our source directory, let's take a quick look through the other files that we have here. We have our IDE file here, so we'll not worry about that one. We have .mvn, and we also have mvmw, so that's a shell script, and then mvmw.cmd. And these three files together make up the Maven wrapper. So we can actually run Maven without having it installed because it's already bundled into this project. We have our target directory, which has all of our compiled resources in there. And then we have some Git files in here as well. We also have this help.md, which you get when you download a project from the Spring Initializer. Pretty helpful, worth a read. But then we have our pom.xml file. So let's take a look at this. So here we can see we're specifying the Spring Boot starter parent with the version of Spring Boot that we specified in the Spring Initializer. We can see the group ID, artifact ID that we specified also, the version 001 snapshot to begin with, the name of our application, and the description that we specified in the Spring Initializer. We have some empty configuration here. We're specifying Java version 21, and then we have each of the dependencies that we specified. Spring Boot Starter JPA, Spring Boot Starter, in fact, let's expand that. Spring Boot Starter OAuth 2 resource server, Spring Boot Starter security, Spring Boot Starter web. There's our H2 dependency. However, the scope is currently runtime. Let's make that test so it only ever runs in our tests. There's our PostgreSQL dependency. There's Project Lombok, Spring Boot Starter test, Spring Security test. And then we have some plugin configuration here. So the Maven compiler plugin is all set up in order to use Lombok. And with that, that completes our overview of our project. So in summary, the project uses the standard Maven structure with Spring Boot configuration. The main application class serves as the entry point with Spring Boot annotations. The key dependencies include Spring Web, JPA, Security, and PostgreSQL. And the H2 database is now configured for our tests. In this lesson, we'll set up PostgreSQL using Docker and configure our Spring Boot application to connect to it. So we've decided that our application is going to use a PostgreSQL database. Perhaps one of the easiest ways to run Postgres is via Docker. So back in our IDE, let's go ahead and create a new file, and we're going to call this one docker-compose.yaml. And let's expand this. To run Postgres in Docker is fairly straightforward, and the configuration to do so looks a little bit like this. You can find this in the lesson notes. Let's just take a quick look through it now. So we're in Docker Compose, so we're going to define our services. We have a service here named DB for database. It uses the latest version of the Postgres Docker image. We've mapped ports 5432 so we can connect to Postgres on localhost port 5432, which is exactly how our Spring Boot application is going to connect to it whilst we develop it. We've set restart to always, so the container will be restarted if there's any problems. And here we've specified the Postgres password environment variable with this value, change me in prod. Now, when we run the Postgres Docker container, the default user that we can access is called Postgres. So we already know the username. This Postgres password environment variable allows us to specify the password. In this case, change me in prod. And that's our database. But there is a second service here, and that's AddMiner. I find it really handy to have a visual representation of the database, and AddMiner allows you to do that. So we run AddMiner as a second service in our Docker Compose environment, using the latest version of the AddMiner Docker image, restart to always, and then we've mapped AddMiner, which runs on port 8080, to port 8888. Because our Spring Boot application by default also runs on port 8080, and we don't want them to conflict. And port 8888 is as good as any, so that's how we can access AddMiner. Now, in order to run Postgres, let's open up a terminal here, and we're simply going to run docker-compose and up. And with that, we now have our PostgreSQL database running, but the story doesn't end there because our application currently doesn't know how to connect to the database. So let's configure our application now as well. So let's minimize that terminal. Let's go over to our project. Let's go to source, main, resources, and let's open up the application.properties file here. Now, typing this all out by hand could get a little bit tedious, so I am going to put this in the lesson notes below. Let's go through these new properties. So we have two blocks of new properties. The first one is all about the database connection. So here we're specifying via Spring Data Source URL how our application can connect to our database. So we can see here a JDBC URL. We're specifying the PostgreSQL protocol and saying our database is available on localhost, port 5432, and we want to connect to that Postgres database. So when we run an instance of Postgres, it almost always has a default database called Postgres in the same way that it has a default user called Postgres. So that's the database that we're going to connect to, at least for development. Talking about that user, via the Spring Data Source username property, we're specifying the username of Postgres. So that default user that's available on our running instance of Postgres. And via Spring Data Source password, we're specifying the value change me in prod ! Which is exactly the same value that we specified in our docker compose.yaml file. There it is. And in that way, we're able to tell our Spring Boot application where to find PostgreSQL and then the username and password to use to connect to it. It's worth mentioning that you shouldn't include passwords in plain text, and certainly don't check them into source control. We're only doing so at the moment for local development purposes. So let's take a look at this second block. Now, we selected the Spring Data JPA dependency when we were in the Spring Initializer, and this is some configuration for that. We've specified in this top line Spring JPA Hibernate DDL Auto, and this will automatically create and update the schema in our database based on the Spring Data JPA entities that we create in our application. This is really handy for local development because whenever we add, say, a new instance variable to our entities, the table will be updated in the database in order to support that. At a certain point, though, you will want to lock down your schema before you go to production, and therefore using a database migration tool like Flyway would be a great thing at that point. However, to speed us along, we're going to use DDL Auto in local development. Show SQL true, print out SQL, always handy in local development. And then we have a Hibernate property for formatting SQL, and then we specified the PostgreSQL dialect for Hibernate. Hibernate being the technology that works inside of Spring Data JPA, Hibernate does a lot of the actual hard work. So you can think of it like the implementation for the JPA interface, if you will. So in a high-level summary, we're able to connect to our database now, and we're also automatically configuring the schema in our database based on the Spring Data JPA entities that we create in our application. So in summary, PostgreSQL runs in Docker for consistent local development. Adminer provides a web interface for database management. Spring Boot connects to Postgres using configuration properties, and JPA automatically manages our database schema changes. In this lesson, we'll set up Keycloak to handle our authentication. We'll configure Keycloak using Docker Compose and create the initial realm, client, and user settings needed for our application. So we have a running instance of Postgres and Adminer. Let's also get a running instance of Keycloak. Now we're going to run Keycloak inside of our Docker Compose environment, as it's perhaps the easiest way to run Keycloak for local development. So let's add a new service here, and you can find this configuration in the lesson notes. So here's our new Keycloak service. You can see we're using the latest version of the Keycloak Docker image. There is the option to pin a version if you like. So rather than use latest for Keycloak, latest for Adminer, and latest for Postgres, you can add specific versions if you want to. However, I'm just going to use the latest for each of these images. We can see that we have some mapping here, port 8080 to localhost 1990. And that's because Keycloak runs on port 8080 by default. However, we're remapping it to port 9090 because our Spring Boot application by default also runs on port 8080. And then we have some environment variables. We have Keycloak admin and Keycloak admin password, and they're both set to the value of admin. And what this means is that we can log in as the administrator using the username admin and the password admin. Of course, it goes without saying, but you shouldn't do this in production. We're only doing this as it's local development, and we want a nice, easy way to log in to Keycloak. So next we have some volumes. Now this is where the setup differs from Postgres. See, Postgres doesn't have any volume set up. So what that means is when we restart our Docker Compose environment, the database will be white. And perhaps it's personal preference, but that's exactly what I like in a development environment, because if we change the way that we've implemented something and want to reset the database, it's a really nice, easy way to do that. However, for Keycloak, I only really want to have to configure Keycloak, create my users once, and I want to persist them throughout Docker Compose environment restarts. So in order to achieve that, what we do is we configure Keycloak to save its configuration to disk, which is this dev file option. And then we use this volume, which will basically persist it between restarts. So with that done, let's run Keycloak. So let's open up a terminal here. Let's Control C anything that's already running, and we'll run Docker Compose up now that we have our new service. Okay, that looks like Keycloak is started up fine, and our database is started up fine, and we have Adminer running. So with that done then, let's open up a browser. So here we are on localhost 9090, and we have ourselves a Keycloak sign-in. So I'm going to attempt to sign in with admin. Here we go, and we're now logged in to Keycloak. So now that we're here, let's do some initial configuration of Keycloak. Let's first create a realm. So let's head over to Manage Realms, and we're going to create a realm. We're only going to specify a realm name in this case, and we'll go with event-ticket-platform. We don't need to worry about resource file or anything like that. We need to make sure that we're enabled event ticket platform create. Okay, so event ticket platform has been created, and it's now our current realm. The next thing that I'm going to do is create a client, and that's going to represent our single page application, so our front end, and give us all of the configuration that we need when we go ahead and create that. So let's head over to clients here. I'm going to create a client, OpenID Connect as the client type. And for the client ID, I'm going to go event ticket platform -app. That's going to be the name of our front end client. For the name, it's not mandatory, but I'm just going to use the same value. We click on next. So we want to make sure that client authentication is set to off. If you hover over this little question mark here, we can see that when it's set to on, a secret will be generated, and that's okay if we had our backend connecting to Keycloak in that way. However, we can't expose a secret on the front end, so we make sure it's set to off for public access. So here's authorization. We can't do anything with that. For authentication flow, we're just going to go with the standard flow, and we'll click on next. So let's just set some initial configuration for that front end, HTTP, running on localhost, and we'll go with 5173 /. So that's going to be the port that our front end is going to run on, at least the local development server. So we'll copy that. For redirect URLs, we'll specify the same thing, but we'll remove the trailing slash. That's what's required for this. This is the URL that's redirected to after a successful authentication. Post logout, let's do the same. We'll leave off that trailing slash and we'll leave root URL and web origins empty. So with that done, let's scroll down, click on save. The valid redirect path that we want to use is now going to be /callback. So with that done, let's save this. Client successfully updated. And the last part of our initial Keycloak configuration is going to be to create some users. So let's create a new user here. Let's scroll down. So for the username, we're going to go with organizer. And this is going to represent our organizer user. And for the email address, I'm just going to go with an email address here. Of course, please use your own email address, not mine. And then for first name and last name, let's just go with organizer user. And we'll leave everything else as the default configuration for now. We may tweak it in future. If we click on create, we have a user created. Let's set some credentials by going to the credentials tab. Let's set a password. I'm just going to set it to be the word password. So password. Of course, don't do that in production or anywhere near production. I'm only doing this as it's all going to be running locally to me. And then for temporary, I'm going to select off. I don't want to have to reset my password. I just want a test user with the password of password. And then I'm going to click on save. Save password. Okay. And with that, we've created a realm. We've created a client in order to represent our front end. And we've also created a brand new user, our organizer user, with the password of password. There's one last thing that we need to do, and that's just set up our backend to know about Keycloak. And that's very straightforward. So we head back to our IDE. I'm going to open up project, go to application.properties, and we're going to add a new configuration property. So let's expand this, and it will look a bit like this. You'll find this in the lesson notes. So here we are. So Spring Security OAuth2 Resource Server JWT Issuer URI. So this is a configuration property from our OAuth2 Resource Server starter. And we're specifying here localhost 1990 realms event ticket platform, which is the name of the realm that we've just created. And with that, we have a running instance of Keycloak and we've completed our initial configuration. So in summary, we've set up Keycloak using Docker Compose with data persistence. We've created a realm, client, and a test user in Keycloak. And we've connected our Spring Boot application to Keycloak for JWT validation. In this lesson, we'll integrate MapStruct with our event ticket platform to efficiently handle object mapping between different layers of our application, whilst ensuring it works smoothly with Project Lombok. We're not quite there yet, but we are going to need a way to be able to convert our entities to DTOs and DTOs to entities. So we're going to need some form of mapper. Now we could do this manually, or we could use a library. As it will save us quite a bit of time, we're going to use a library. So let's set up MapStruct. Now, as we're using Project Lombok, there is an additional challenge to make these two libraries play nice with each other. But there is a way forward. So if we go to our pom.xml file here, let's expand this. Let's scroll up to the top and let's look for properties. So this is where our Java version is specified. Now I'm going to use properties to be able to specify the Lombok version and also the version of MapStruct as well, as we want to be very specific with these versions to make sure that they are compatible with each other. The MapStruct version that we're going to use with the property here org.mapstruct.version is 163. I'm also going to pin the Lombok version as 118.3.6. I happen to know that these two versions work well together. Now, if we scroll down, we're going to have to add the MapStruct dependency. So let's put it just after Spring Boot Starter Web here. So org.mapstruct, the artifact ID is MapStruct, and we're using the $embraces syntax in order to reference our org.mapstruct.version. So we have MapStruct in our project. Now, the next thing that we'll want to do is to pin our Lombok version. So we've already declared Lombok down here. So what we're going to do is simply declare version in here with the $embraces syntax specifying the lombok.version property that we've specified up here. And we'll leave everything else the same. So essentially what we've done then is just brought in MapStruct as a dependency at a particular version and then pinned Project Lombok at a specific version as well. Next, we'll need to configure the Maven compiler plugin. As both of these tools generate code, we need to make sure that they do so in the correct way. So let's scroll down to the Maven compiler plugin here, and we can see that Project Lombok is already on the annotation processor paths inside of the configuration. What I'm going to do is replace that particular path node with these three here. So we're still specifying project lombok inside of the annotation processor paths. We are pinning that version in here as well. And then we have MapStruct afterwards. So we can see here org.mapstruct, MapStruct processor, and then pinning that MapStruct version. And then we have the lombok MapStruct binding. And it's this particular dependency that makes lombok and MapStruct work well together. Now in the documentation, it's a little bit vague as to whether or not you need to do the dependencies in this particular order. However, I found that you do in order for everything to work successfully in previous projects. So I'm going to keep them in this particular order here. Now, just to make sure that we haven't broken our project, I'm just going to go to the lifecycle and I'm going to run clean install. Okay, great. We have a build success. Now we won't be able to test properly that the lombok and MapStruct configuration works as expected until we start writing entities and mappers. However, for the time being, it looks like everything is working as expected. So in summary, we've added the MapStruct dependency and version property to the project. We configured the Maven compiler plugin for annotation processing, and we've set up the lombok MapStruct binding for compatibility. So let's now recall what we've achieved in the project setup module. In new project, we created a new Spring Boot project using the Spring initializer. We set up core dependencies for web, security, and data persistence. And we added development tools like lombok to improve our productivity. In Explore the project, we saw that the project uses the standard Maven structure with Spring Boot configuration. The main application class serves as the entry point with Spring Boot annotations. Key dependencies include Spring Web, JPA, security, and PostgreSQL. And a H2 database is configured for testing. In running PostgreSQL, we ran PostgreSQL in Docker for a consistent local environment. We learned that AdMiner provides a web interface for database management. Spring Boot connects to Postgres using configuration properties. And JPA automatically manages database schema changes. In running Keycloak, we set up Keycloak using Docker Compose with data persistence. We created a realm, client, and a test user, and we connected our Spring Boot application to Keycloak for JWT validation. In configuring MapStruct, we added the MapStruct dependency and version property to the project. We configured the Maven compiler plugin for annotation processing, and set up the lombok MapStruct binding for compatibility. In this module, we'll create our entity classes, which represent our domain. The module is structured like this. We'll start by creating enum classes. We'll then create the user entity class, and then we'll create the event entity class, and then the ticket type entity class, the ticket entity class, the ticket validation entity class, the QR code entity class, and then we'll generate equals and hashcode methods for each of the entities that we have created. So now for the learning objectives. So by the end of this module, you will be able to create the enum classes used in the domain, create the user domain entity, create the event domain entity, the ticket type domain entity, the ticket domain entity, ticket validation entity, the QR code entity, and generate the equals and hashcode methods for each entity. So with that covered, let's get started. In this lesson, we'll create the enumerations that we'll need when we start implementing our entities. We're going to implement the enums first, as they're the simplest to implement, and it will allow us to build our domain from the bottom up. So before we jump right into our IDE, let's identify the enums that we are to create. So here we have our very informal class diagram over in Miro. So let's just identify these enums. So the first one is over on event here. If we scroll in, we're representing the status of the event as the event status enum. Although it's not mentioned anywhere, I imagine the status of the event to include things like draft, or published, or cancelled, or perhaps completed. Each one of these values representing a particular point in the event lifecycle. So that's the first enum that we are to create. If we carry on down to ticket here, we also have the ticket status enum. And that represents the different states a ticket can be in throughout its lifecycle. So a ticket is only created once it's been purchased. So I think the default status would be purchased in this case. Although we should allow the option to cancel a ticket for whatever reason, so another status for the ticket status enum may be cancelled. If we carry on down to the ticket validation here, we have the ticket validation enum. And that represents the outcome of validating the ticket. Was the ticket valid? Was the ticket invalid? Has the ticket expired? We're going to represent that with the ticket validation enum. There's a second enum on this class too, which is the ticket validation method enum. There's two ways to scan a ticket, via the QR code or via manual input. We want to capture that, so we're going to do that via the ticket validation method enum. And I believe there's only one more enum that we need to implement, and that's over on the QR code here. And that's the QR code status enum. We may want to replace the QR code on a digital ticket, and we can do so remembering back to when we modeled our domain here. A ticket can have one or many QR codes, but the idea is only one of those QR codes is going to be the latest and therefore valid. This is going to allow us to cancel and regenerate QR codes if we ever do need to. So I imagine the QR code status enum to include values like active for an active QR code or expired for a QR code that we no longer want to use. So with that high level overview done, let's head over to our IDE. So here we are in our IDE. Let's go about creating these enum classes. So first, let's keep things organized. So over in com Devtiro tickets, I'm going to create a new subpackage, and I'm going to call this one domain. That's going to include all of our entities and our DTOs. We'll reorganize this package as we go. So let's create a new Java class straight in com Devtiro tickets domain, and we'll call this one event status enum. And this is going to be an enum. So this is to represent the different states that an event can be in. So I imagine that to include draft, for when an organizer is creating an event but not yet ready to publish it, published, for an event that's published and available to the public, cancelled, for an event that didn't go ahead and is no longer available, and then completed, for an event that did go ahead and has reached the end of its life cycle. So I think that will do us for the event status enum. Let's now create a second enum in here, new Java class, and we'll call this one ticket status enum. And this will be an enum. So the ticket status enum is going to have two values. We're going to go with purchased, which is the default status of a ticket, remembering that we only create tickets when they've been purchased, and we'll say cancelled, allowing us to cancel a ticket purchase for whatever reason. So that's the ticket status enum. Let's now create the ticket validation status enum. So let's go to domain, new Java class, ticket validation status enum, and this will be an enum. So this represents the different outcomes of validating a ticket. That includes valid for a valid ticket, invalid for an invalid ticket, or perhaps a QR code that doesn't exist, it's been faked in some way, and expired for a ticket that was perhaps for a different event that you can no longer use to access this event. So technically invalid, but a special case of invalid that we should probably capture. So that's one of the enums on the ticket validation. The second was the ticket validation method. So let's create that too. Ticket validation method, and this will be an enum. And the two that we're going to capture here is QR code or QR scan, I think. So somebody at the door has scanned the QR code on that ticket, and that's how we validated this ticket. And the other one we should capture is manual. So that's the manual entry that somebody on the door can do. So talking about the QR code, we should also create the QR code status enum. QR code status enum. That's an enum as well. And the values for this one are active. This is an active QR code that can be scanned, and then expired. This is no longer a valid QR code. And with that, I believe we've created all of the enums that we've identified at this point. So in summary, the event status enum represents the state an event can be in. The ticket status enum represents the state a ticket could be in. The ticket validation method enum represents the different way a ticket can be validated. The ticket validation status enum represents the state a ticket validation can be in. And the QR code status enum represents the different states a QR code could be in. With the enums created, let's now moving on to creating our user entity. So as a reminder, our user entity is this one here. Now, we've identified three different types of user. We have the organizer user, the staff user, and the attendee. There are various different ways that we can then implement our user in our system. We could choose to have an abstract user class, and then that user class could have various subclasses, including organizer, staff, and attendee. And that would give us the benefit of being able to leverage polymorphism. However, implementing that could be more complicated than the value that it does give us. So in this case, what we're going to do is separate the idea of the different types of user from the user entity itself. So we're going to have different roles inside of Keycloak for organizer, staff, and attendee. And we're simply going to have one user entity in our system. If that idea seems a bit abstract at the moment, don't worry, because of course we will implement it. What it means for us now is that we're only going to implement one user entity and not a separate one for organizer, staff, and attendee. So let's head over to our IDE. So here we are back in the IDE. Inside of the domain package here, I'm going to create a new Java class, and I'm going to call this one user. And this time, let's expand this. Now this is going to be a JPA entity. So let's start by adding the entity annotation to the top of this class, coming to us from Jakarta Persistence. While we're here, let's also specify the name of the table that we want this particular entity to map to. So we'll use the table annotation, where the name value is going to be users, lowercase and plural. Now we have Lombok in our application and we could use @data. However, there is a problem with doing so. We are very likely going to implement bidirectional relationships, where object A references object B and object B references object A. And with the @data annotation, it generates our equals and our hash code for us. And if those bidirectional relationships exist when it tries to generate the code, it can lead to a Stack Overflow exception. So rather than use @data, which is a combination of many different Lombok annotations, we're going to specify the ones that we need and then manually implement our equals and hashcode methods. So let's use @getter to generate getters for our instance variables, setters to generate setters. We'll go with the noArgs constructor to generate a noArguments constructor, and we'll also go with an allArguments constructor. And I'm a fan of the builder pattern, so we'll use @builder as well. So a lot of annotations there, but a lot less work than generating this or writing this all by hand. So let's start capturing the different instance variables of our user class. So the first one that we'll need to capture is the user's ID. And this is going to be a UUID, and we'll call that one ID. As it's the ID of an entity, we're going to put the @ID annotation on the top. And we're also going to specify with the column annotation, the name, so the field that this instance variable maps to in the database, which is ID, which is the default, but we want to specify some additional arguments on the column annotation. Updatable, false. We don't want the ID of a user to be updatable. Nullable, false. We don't want a user with a null ID. So that's the first instance variable. Let's just scroll down a bit. The second instance variable that we'll want to capture is the name of the user. Private, string, name. And we'll also specify on the column annotation here, the name, which will be name, which is the default and we could omit it, but we'll be explicit in this case. The main reason we're doing this is because we want to specify nullable as false. We always want the user to have a name, never null. So that's the name of our user. What about the user's email address? Now we could rely on just getting this from Keycloak, but let's capture it here as well. And that will allow it to be easily accessible. So let's go private, string, email, and then we'll go @column, the name is going to be email, nullable equals false. We always want our user to have an email. If we go back to our class diagram now, we can see that the user references a ticket, and that's via this relationship here. The user, which is also modeled by these three boxes, references an event. The user, as we're only using the one entity, will also need to consider these three boxes. The organizer user type manages an event, so we'll need to reference organized events or managing events. The attendee attends different events, so we'll need to capture a user attending events, that relationship. And then the staff member staffs the events. We'll also need to capture that relationship, I think. Now, as we don't yet have an events entity, we'll just put some to-dos in so we can come back and do those later. So let's head back to the IDE and we'll go to-do, organized events. Just scroll down a bit. We'll do a second to-do, and this is going to be our attending events. And a third to-do, and this is going to be staffing events. So as we're using our one user entity, we're going to reference all of the events that this user organizes, all of the events that the user is attending, and then all of the events that the user is staffing. Depending on the role of the user, some of these may have information in, others may not. Now let's include some audit fields because it's always best practice to know when a particular entity has been created and updated. So we'll go private, local datetime, created at, and we'll put some annotations on here so it's automatically populated. Let's go with created date, and let's specify some column information here as well. So for consistency, let's say the name of this column is created at, and we'll say updatable is false and nullable is false. We always want a created at local datetime, and we don't want that to be updated ever. And let's go with another column here, and let's go with the updated local datetime, updated, and we'll put the last modified date annotation on here. That will populate that, and we'll go with at column. For consistency, we'll go with updated at. In fact, let's rename that to be updated at. Updatable, of course, will be true. That will be the default, so we don't need to specify that. Nullable will also set to false. We always want an updated at specified on the user. Okay, so with that, we've implemented the initial implementation of our user entity. So in summary, we've created a user class to represent a user of the system. We'll use the same user class for attendees, staff, and organizers. We'll model the user's permissions using roles, which we can assign in Keycloak. And we've added the created at and updated at audit fields. Now let's create a class to model the event in our event ticket platform. So we've created our user, and therefore the organizer, staff, and attendee. All of these different sticky notes reference the event. That is what we're going to create in this lesson here. So the event, ID name, start and end, venue, the sales start date, sales end date, and then status, which is the first use of our enums. In this case, the event status enum. So we'll create this event entity class, and we'll also update the user class with references to this event. So let's head over to our IDE. So back in our IDE, let's create a new class in domain, and we'll call this one event. So just like before, let's expand this and let's add the annotations that we'll need. At entity, at table, and we'll specify the name of events. We'll go with at getter, setter, no R's constructor, all R's constructor, and builder. And that's a lot of annotations, but again, a lot easier than writing this all by hand. Now, I didn't mention when we were creating our user, but we're not going to create the equals and the hash code until right at the end. Because we're making updates to all of these classes, rather than have to regenerate it, let's just do it in one go right at the end. So with that covered then, let's get started on the event class. The first thing that we'll need to do is specify the ID. This again is a UUID, and we're going to put the at ID annotation on the top here. Now where this ID is different from the user, let's just bring the user up now, put the user on the right hand side, there we go. So where this is different from the ID on user is the ID from user is going to be specified in Keycloak. Whereas the ID on event isn't, we'll need to generate that. Now, there's a few different ways of doing that, but perhaps the easiest is to the event here, we're going to add the annotation generate a value with the strategy of UUID. There we go. So let's just close user. So what this will do then is it will generate a random UUID whenever the ID is null on an event and we go to save it. We'll want this for the event and for the majority of the entities that we'll implement, but we don't want this for user because our ID will come from Keycloak. So before we move on, for consistency, let's add the at column annotation here. We'll go with name, we'll go with ID, we'll go with updatable false, and we'll also go with nullable false. Okay, so that's the ID. Let's now do the name. Private string name. We'll go with the at column annotation. The name of this one is going to be name. Scroll down and we'll go nullable is false. We always want an event to have a name. Next, we'll go with a private local date time, and this will be the start, date, and time of the event. So we'll simply call that one start. And for the column, the name is going to be start. And we'll also go nullable false, I think. We always want a start, date, and time of an event to be specified. Now let's go with the end date and time, local date time. We'll call that one end, column annotation, name, is going to be end, nullable equals false. We always want an end date to be provided, or an end date and time, should I say. Now let's specify the venue information. Now we could build out the venue to be its own object, but for our first iteration, let's just represent the venue information as a string, which we'll call venue. We'll put the column annotation on the top here. The name of this one is venue, and we'll say nullable equals false. We always want venue information to be provided. Private, local datetime. This is going to be the sales start. So the date and time that the tickets for this event go on sale. We've modeled this on the event, so it will apply to all tickets, all ticket types associated with this event. Column, name. We'll call this one sales start. And we're going to say nullable true. It may be the case that we don't yet know when the tickets are going to go on sale, which I think is a more likely case than not knowing when the event is planned for initially. It may be that for whatever reason, there isn't a definitive sales start and end time, it's just all of the time. So we'll make that nullable. Although now that I think about it, let's make the start and end time also nullable. So we'll remove that from start and end, and then we'll remove that from sales start. At least it's consistent then. So we don't need to specify a start and an end date for an event. Maybe it's happening all the time. And we'll also do the same for sales start. We may need to change this later, but that seems like a reasonable thing to do at the moment. So let's also do the sales end. It's going to be pretty much identical to sales start in the sense that it's a local date time. We'll call it sales end, and the name is going to be sales end, and it can be nullable. So let's now reference our event status enum, which we're going to call status. So let's put the column annotation on the top here. We'll say the name is going to be status. Nullable is going to be false. We always want a status to be provided. Now, whenever we use an enum, it would typically default to its numeric value in the database, at least when using Hibernate. So if we specify the enumerated annotation here, and we'll say enum type string, that means that the string representation of the enum will be stored in the database. And that's typically easier for a person to read when they're looking through the database. So that's status. Let's now reference our user. So each event is going to have an organizer. Private, user, organizer. Now the relationship is that one organizer can organize many events. We're currently in the event class. So let's put the many to one annotation on our user organizer. And whenever we do this, let's say fetch type is lazy. And we do that for efficiency reasons. Helps to combat the n+1 problem. And whenever we do this, we also need to specify the join column. And the name of the join column is going to be organizer ID. So that's the name of the column on our event table in the database. That's going to reference the ID of the organizer, which is a user. So it would be a user ID. So that's our reference to the event's organizer. For completeness, let's also get a reference to all of the attendees of this event. So we'll say a private list of user. We need to import list, and we'll call this one attendees. And we're going to initialize it to a new array list, and that will help prevent null pointer exceptions. Now let's put the many to many annotation on the top of our attendees, because of course, an attendee can attend many events, and an event typically has many attendees. So many to many. However, let's not put the configuration, all of the information on this relationship inside of the event, because in my mind at least, it makes sense for the user to own this relationship. So what we'll do then is we'll say mapped by, and we'll specify the name of the instance variable that we'll have to create on the user class very shortly. So we'll call this one attending events. So what this means is this instance variable we'll need to create on the user class in a moment, and we'll need to add annotations to that instance variable that defines all of the properties of this particular relationship. But for the event class, this is all we need to do in order to reference our attendees. Let's also do staff. So private list of user, and we'll call this one staff, and we'll initialize that to a new array list as well to help combat those null pointer exceptions. Again, we'll put the many to many annotation. A staff member can work at many events, and an event typically has many staff. We're also going to place the configuration for this relationship inside of the user. So let's define the instance variable of staffing events that we'll also need to create on our user class in just one moment. So that's the reference to staff of the event. Let's now add the audit fields like we've done on user. So in fact, let's go to user here. We'll copy the created at and updated at, and let's place that also on our event class here. There we go. So that's our event class with an ID, name, a start and an end date, venue information, a sales start, sales end date, a status, and then reference to the event's organizer, the event's attendees, and the event's staff, and then some audit fields created at and updated at. But we're not done. We'll need to update our user class now. So let's head over there. So here we have these 3 to-dos. Let's start with organized events because it's the easiest to configure. So we're going to say private list of events because an organizer can organize many events. And let's call this one organized events, and we'll initialize it to be a new array list. We're going to put the one to many, which is the inverse of the annotation that we had on event. Event was many to one. We're in user, so we're going to say one to many, and then we'll say mapped by organizer, and we'll say cascade type of all. So what this means is the information about this relationship can be found on the instance variable organizer inside of event, which is this one here. It's typical for the many side of the relationship to have the configuration, at least when you're building entities with Spring Data JPA. Let's go back to user. Now, cascade type all means any changes that we make to the events that the user references is then saved. We have to be careful when we specify cascade type all, because perhaps the most alarming thing is that if we delete the user, all of the events associated with that user are also deleted. In a real system, you may want to do some soft delete functionality. However, rather than get sidetracked with that, for the moment, we'll just go with cascade type all. So that's the organized events instance variable. Let's now move on to the attending events. So this is a many-to-many relationship, and we mentioned a moment ago that this user class is going to contain all of the configuration for this relationship. So you might be wondering why we put the information about the organized events relationship in event, but we're choosing to put the information about the relationship for attending and staffing inside of user. Well, the convention is the many side of a one-to-many relationship typically owns the relationship and therefore has the configuration in. So in the case of organized events, that's event. However, in the case of a many-to-many relationship, there isn't necessarily a convention like that. So it typically goes with whichever entity conceptually owns the relationship. In my mind, the user should contain information about its relationship to attending and staffing events rather than the event itself. But you could very well just put this information on event if you so choose. So let's get to it. Private list of event, attending events, and we'll initialize that to be a new array list. Let's just make sure that we got that field name right. So go back over to here, attending events. Yes, it matches. Back to user. So now let's put the annotations on the top here. This is a many-to-many relationship. And now we're going to specify the information about this relationship with the join table annotation. Now the name of the join table, let's call it user attending events. For the join columns, we need to use a nested annotation, which is join column. And the name's going to be user ID. So inside of that join table, user ID is going to reference the user, and the inverse join column, the name of this is going to be event ID, and that's going to reference the event. And that's all we'll need to do for the attending events relationship. So let's now do staffing events. Private list of events. This one is called staffing events equals new array list. And let's just double check the name of the instance variable over an event. Yep, it matches. Great. So back to user. And now we're going to place our annotations on the top. Many-to-many annotation, join table. The name of this join table, let's call this one user staffing events. For consistency, let's just scroll down a bit. Join columns. Well, let's scroll up a bit so we can reference the attending events. So join columns, we need to use the nested join column annotation, where the name is going to be user ID. And then for the inverse join columns, join column annotation, the name is going to be event ID. There we go. And that's all of the to-dos completed. So with that, we've created our event entity and updated our user with all the relationships to the event. So in summary, we created an initial event class and we added event references to the user class. Now let's implement the ticket type entity. So we implemented our event and our event is going to reference our ticket type entity. So let's create a ticket type entity, and then we didn't do a to-do in the event class, but we'll also update the event class to reference ticket type. So let's head over to our IDE. So inside of domain, let's create a new Java class, and let's call this one ticket type. And this is going to be a class. Let's expand this. And just like before, we're going to add @entity, @table. We'll give this one the name of ticket_types, getter, setter annotations, no ours constructor, all ours constructor, and we'll go with builder as well. So that's our ticket type annotations. Let's actually implement our class now. Private UUID, ID. As this is an ID and an entity, we'll add the @ID annotation, and we'll also want this to be automatically generated for us. So let's add the generated value annotation, where the strategy is generation type UUID. Okay, now let's add the name of the ticket type, private string name. We'll add the column annotation on the top here, where the name is name and nullable is going to be false. We always want a name to be provided. And in fact, let's also add a column annotation while we're here to ID. Column, name, ID, nullable false, updatable false. Okay, that's nice and consistent. So we have ID, we have name. I believe next on the list was price. Now we're representing price as a double. And we'll call this one price. And the column annotation on this one, the name is going to be price. And nullable is going to be false. We always want a price of a ticket type to be provided. Now we'll need to specify the number of tickets available of that type. So we'll use integer for this, and we'll say total available is the name, and we'll go with column annotation where the name of this column is total underscore available, and we'll say nullable is true, so we don't actually need to provide that. So you don't need to provide the total number of tickets that are available. It may be infinite, in which case null may be a way to represent that, but we've decided to make this nullable. Now let's reference the event to which this ticket type belongs. So private event, event. Let's put the many to one annotation on the top here with the fetch type of lazy, just like we did before. And we'll need to specify the join column, and we'll specify the name of the join column to be event underscore ID. So this is going to be the name of the column inside of our ticket types table, which references the event to which the ticket type belongs to. So let's do a to-do for tickets, because of course we'll need to reference the tickets of this particular ticket type in some way. And let's also add those audit fields that we were using. See if we can grab them from event, and we'll place those on ticket type as well. There we go. So we're capturing when the ticket type was created and when it was last updated. So with that, let's go over to the event class and add the references to the ticket types. So we've got the event class here. Let's place the reference above the audit fields, and we'll say private list of ticket type, and we'll call this one ticket types, and we'll initialize it to a new array list. And as we already have our many to one annotation over on ticket types, we can place the one to many annotation on this instance variable, specifying the mapped by of event, and we'll specify cascade type of all as well. Okay, so with that, we've created the ticket type entity, and then we've added a reference to ticket types on the event entity. So in summary, we created the ticket type entity class to model the different types of ticket available for events. And we added a ticket types reference in the event class. Now that we have our ticket types class, so we've done event, we've done ticket type, we have ticket here, and that's what we're going to do next. So a ticket, we identified an ID, the status, which is represented by the ticket status enum, and then we've done a created date time here as well, but we'll be adding our audit field, so that should cover that. And then the ticket has relationships to a QR code, and then a ticket validation that we'll implement in the subsequent lessons. So let's head over to our IDE and implement our ticket entity. So back in our IDE, let's head over to the domain package here, and let's create a new Java class, and let's call this one ticket. And let's expand this. So just like before, we're going to add the @entity annotation to the top here. Table, we'll give that the name of tickets. Getter, @setter, @noArs constructor, @allArs constructor, and we'll add the builder annotation as well. So with that done, let's add some instance variables. Private, UUID, ID. We'll add the @ID annotation. We'll also add the @column annotation. The name of this one is going to be ID. Nullable is false. Updatable is false. And we'll want to generate this as well. So let's add the @generated_value annotation, where the strategy is going to be UID. There we go. So let's scroll down and let's add the ticket status next, I think. So go private, ticket status enum, and we'll call this one status. We'll add the column annotation to this, where the name of the column is going to be status. Nullable equals false. We always want a status to be provided. And let's also add the @enumerated annotation with the enum type of string to save string representations of our enum in the database. So with that done, let's add the reference to the ticket type next. Private, ticket type, and we'll call this one ticket type. Now the relationship is many to one. A ticket type can have many tickets, whereas a ticket will only ever have one ticket type. So we'll say fetch type is lazy. And now we'll set the join column to be, let's say, ticket type ID. There we go. And we'll update the ticket type entity in a moment for the other half of that reference. So we've got our ticket type. Let's now add reference to the user that purchased the ticket. Private, user, purchaser. And this is also a many-to-one relationship because a user can purchase many tickets, but a ticket will only ever have one purchaser. So we'll say fetch type of lazy, and then the join column, we'll give this the name of purchaser, spell this correctly, purchaser ID. There we go. So we mentioned that a ticket has several other references, so let's add some to-dos for those. The first one is the ticket validation, and the second one is the QR code. And we will get to those. However, first let's add those audit fields. We're using the same one, so let's copy those. We could extract that out to be in a abstract class, for example, but let's just add those there for the time being. Okay, so our ticket has an ID, has a status. We reference the ticket type, the purchaser, and we haven't yet created our ticket validation or QR code, but we will update this when we have. And then we have our created @ and updated @ audit fields. So with that done, let's now head over to our ticket type entity, which is this one here. Let's update this to reference the tickets of that ticket type. So we'll say private list of ticket, importing list, and we'll call this one tickets, and we'll initialize it to be a new array list. We'll then add the one-to-many annotation on the top, and then we'll say mapped by, and then it's the name of the instance variable over in ticket, which was ticket type. So back to ticket type, we'll place that in there. And then we'll also say cascade type of all. As we start to build out our application, we may be a bit more specific, but we'll use all for the time being. Okay, and with that, we have created ourselves a ticket entity, and we've updated our ticket type entity to reference the tickets in that ticket type. So in summary, we've created the ticket class to model a ticket to an event, and we've added the tickets reference to the ticket type class. So let's now implement the ticket validation entity. So as a reminder, we've already implemented our ticket. We're now to implement the ticket validation. We've identified the instance variables of ID, status, which is represented by the ticket validation enum. We've got the validation date time, but we could very well replace that with a created audit field to be consistent. And then we have the validation method. Was it a QR code scan or was it manual? So let's head over to our IDE and implement this class. So back in our IDE, let's go over to the domain package here and create a new Java class. And we'll call this one ticket validation. Let's expand this and we'll add the annotations to the top of this class at entity. We'll specify the table name and let's say ticket validations, then getter, setter, all ours constructor, no ours constructor, and we'll add builder as well. So with that done, let's add the instance variables. So let's start with ID, private UUID ID. We'll add the @ID annotation, column, name is going to be ID, nullable is false, updatable is also false. And then we'll add the generated value where the strategy is going to be UUID. Okay, so we've seen that before a few times now, so we're able to speed through that. Let's now add reference to the ticket validation status enum. So private ticket validation status enum, and we'll simply call this one status. We'll add the column annotation, where the name of this column in the database is status, and we'll say nullable is false. We always want a status to be provided, and we'll also add the @enumerated annotation, where the enum type is going to be string. So we get to store the string representations of the enum in the database, so it's easier for us to read. Let's also add reference to the ticket validation method. Let's call that validation method rather than ticket validation method. For the column, we'll call this one validation method, and we'll say nullable is false. We always want one to be provided. And again, enumerated, where the enum type is string. Now for the ticket validation, this is only ever going to be created when we validate a ticket. So the created time for the ticket validation is going to be the same as what we would have represented with our validation time. So what we'll do then is let's head over to, let's say event. Let's copy these two fields, go back to ticket validation, and then we'll add those to our ticket validation class. Okay, so ID, status, validation method, created that, updated that. We don't yet have a reference to our ticket. So let's add that. So private ticket, ticket. And this is going to be a many to one annotation. And let's specify the fetch type of lazy. And then we'll say join column. And I think we'll just give this the name of ticket ID to be consistent. And that should be all we need to do. So let's head over to ticket and update the reference that side. Okay, here we are. So let's handle this to do here. So let's say private list of ticket validation. And we'll call this one validations, and we'll initialize it to a new array list. And now we'll add the one to many annotation on the top here. We'll say mapped by ticket, which is the name of the instance variable over in ticket validation. There it is. Back to ticket. And we'll also want to specify the cascade type, and we'll say the cascade type of all, and that should do it. So we've created ourselves a ticket validation entity, and we've updated our ticket class to reference the list of ticket validations. So in summary, we've created a ticket validation class to model a ticket being validated at the event, and we've added the validations reference to the ticket class. Let's now create the entity to represent our QR code. So we have created our users, we've created our event, we've created our ticket type, our ticket validation. We've now to create the last entity on our list, which is the QR code. So the QR code has an ID, a generated date time, and then a status, which we represent with the QR code status enum. So let's head over to the IDE and create this. Okay, back in the IDE, let's head over to domain. We'll go new Java class, and we'll call this one QR code, and it'll be a class. There we go. So let's expand this. So to the top of this class, we'll add @entity. We'll specify the name of the table as QR_codes, and then we'll go getter, setter, all ours constructor, no ours constructor, and builder. Okay. So let's add the ID now. Private UUID, we'll call it ID, ID annotation, And then the column annotation, where we specify the name is ID, nullable is false, updatable is false, and then generated value, where the strategy is UUID. There we go. So next, let's represent the status. So private QR code status enum, and we'll call this one status. For the column annotation, we'll say the name is status, and nullable equals false. We always want a status to be provided, and we'll also say enumerated, where the enum type is string. Now, something we didn't represent on the sticky note was the actual value of the QR code. Now, I'm not quite sure what this is going to look like yet. So what we'll do at the moment then is we'll say private string, and we'll say value like that. We'll have to figure out how to generate and store this QR code, but we can deal with that a bit later. For the time being, let's just say there's a string value, which represents the value of that QR code. Say column, name, we'll call that one value, and nullable equals false. We always want that to be provided because that's the actual value of the QR code. So now we'll want to reference the ticket, I think. So we'll say private ticket, and we'll call this one ticket. And we'll say a many-to-one relationship where the fetch type is lazy. And then we'll specify the join column here where the name is ticket underscore ID. Okay, so let's now get the audit field. So we'll go over to event, we'll go copy, go back to our QR code, and let's paste those in, expanding this. So we have our QR code entity, has an ID, a status, a value. We may have to change that in future once we understand more about how to generate a QR code. We have the reference to the ticket to which this QR code belongs. And then we have our created at and updated at audit fields. So let's update ticket with a reference to the QR code. So that should deal with this to do here. So let's say private list of QR codes. We'll say new array list, and we'll call this one QR codes, and we'll initialize it to be a new array list. We'll add the one-to-many annotation on the top, mapped by ticket, which was the name of the instance variable over in QR code, I believe. Yep, it's called ticket. And we'll say the cascade type is all, and that should do for the moment. So with that, we've created ourselves a QR code entity class, and we've updated the ticket to reference the QR codes. So in summary, we've created a QR code class to model a ticket's QR code, and we've added the QR codes reference to the tickets class. So now that we have the first iteration of all of our entities, let's now generate the equals and hashcode methods for those entities. So here we are back in our IDE. So let's go ahead and generate the equals and hashcode methods for these entities. We're going to leverage the IDE for this. We won't be writing this by hand. So if we start with event, what we'll do is we'll right click, go to generate, equals and hashcode. We'll select the default. And this is the important part. We may want to change this later, but for the time being, we're going to decide that we won't use any referenced objects, or at least reference entities, the ones that we've created, in our equals and hashcode methods. So what I mean by that is, if we go through this list, ID, name, start, end, venue, sales start, sales end, status, that's great. We can include those. We won't include the reference to the organizer, or the attendees, or the staff, or the ticket types. We will include created at and updated at. And this will help us to sidestep those Stack Overflow errors from that bidirectional relationship, but we may need to add some of these back in later and handle those cases. But we'll cross that bridge when we get to it. So we go next, create, and that's the equals and hash code created for this class. So we're going to skip the enums and go to the next class, which is QR code. Create a space here, generate, equals and hash code, next. So ID is fine, status, value, we'll untick ticket, we'll keep created at and updated at. Great, so that's QR code done. Ticket next. Let's right click, generate, equals and hash code, next. ID, status, ticket type, we'll untick, purchaser will untick, validations, QR codes, will untick, we'll keep created at and updated at. So next, create, ticket type next. So we'll go generate, equals and hash code, next. We'll keep ID, name, price, total available, we'll untick event, we'll untick tickets, and we'll keep created at and updated at. Okay, ticket validation next. Scroll down here, and we'll go generate, equals and hashcode, next, we'll keep ID, keep status, we'll untick validation method, we'll untick ticket, and we'll keep created at and updated at. There we go, looking good. We'll skip ticket validation method and ticket validation status, and that just leaves user. So we'll scroll down to the bottom here. We'll go generate, equals and hashcode, next. We'll keep ID, name, email. We'll untick organized events, attending events, staffing events, and we'll keep created at and updated at. So next, create. There we go, and that's our last entity. Now, I should mention that this is just the first iteration of these methods. We haven't really put much thought into their implementation. We just want to prevent that Stack Overflow exception to get us moving. We may well revisit these methods in future and tweak them if we need to. But for the time being, we've now implemented the equals and hashcode methods for each of the entities that we've created. So in summary, we have used our IDE to generate the equals and hashcode methods for each entity class. So let's recall what we've achieved in the domain module. In create enums, we established that the event status enum represents the state an event could be in. The ticket status enum represents the state a ticket could be in. The ticket validation method enum represents the different ways a ticket can be validated. The ticket validation status enum represents the state a ticket validation could be in. The QR code status enum represents the different state a QR code could be in. In create user entity, we created a user class to represent a user of the system. We established that we'll use the same user class for attendees, staff, and organizers. And we'll model the user's permissions using roles which we can assign in Keycloak. And we added the created at and updated at audit fields to the user class. In create event entity, we created an initial event class and added event references to the user class. In create ticket type entity, we created a ticket type class to model the different types of ticket available for events. And we added the ticket types reference in the event class. In create ticket entity, we created a ticket class to model a ticket to an event. And we added the tickets reference to the ticket type class. In create ticket validation entity, we created a ticket validation class to model a ticket being validated at an event. We added the validations reference to the ticket class. In create QR code entity, we created a QR code class to model a ticket's QR code. We added the QR code's reference to the ticket class. And in equals and hashcode, we used our IDE to generate the equals and hashcode methods for each entity class. In this module, we'll implement the automatic creation of a user the first time that they interact with the REST API. As we need a user in order to create an event, this is a prerequisite to our create event functionality. The module is structured like this. We'll start by creating a custom filter for user provisioning. We'll then configure Spring to use the filter. We'll then enable the JPA audit field annotations. That's the created at and updated at annotations that we've added to our entities. And we need to enable these because we're using these on our user and they're a prerequisite to save the user. So now for the learning objectives. So by the end of this module, you'll be able to implement a filter to create new users in the database, configure Spring to use the user provisioning filter, and enable the created and last updated annotations used in entity classes. So with that covered, let's get started. Before we can create an event, we need an organizer user in the database. In this lesson, we'll implement the use of a provisioning filter, which will check the JWT in the authentication header and create a user in the database if needed. So here we are back in our IDE. So let's start in our repository layer, so in our persistence layer. So let's create a new package here. And I'm going to call this one repositories. And within repositories, I'm going to create a new Java class, and I'm going to call this one user repository. There we go, user repository, and it's going to be an interface rather than a class. There we go. So let's maximize this. We need our user repository to be able to save users in the database, and that's a basic create operation. So luckily, we don't have to implement anything custom for this. So if we put the @repository annotation on the top of this class to begin with, so we don't forget, marking this as a repository, and it will allow us to inject it throughout our application. we're going to extend JPA repository, passing in our user as the entity and UUID as their ID type. Let's just import UUID. Okay, so as a reminder, we already have our user entity. Looks a bit like this. The ID is a UUID type, and this has all the relationships and everything we need already set up. By extending JPA repository, if we were to control click through here, JPA repository itself extends the list CRUD repository, which extends the CRUD repository, which has a save operation already. So the user repository should give us everything that we need in order to create a user, save a user in the database. So next, let's create the provisioning filter. So we'll open up our project here, and I'm going to create a new package inside of Devtiro tickets, and I'm going to call this one filters. And within filters, I'm going to create a new Java class, calling this one user provisioning filter. And let's expand this. Okay, so I'm going to put the @component annotation on the top of this class to begin with. I'm not going to use @service because it's strictly not a service. We're going to use the more generic @component. That will allow us to inject things into this class and for the class to be injected where needed. Now, the important part, we're going to extend once per request filter. And you'll notice that this comes to us from org Spring Framework web. So filters aren't a Spring concept. They're a servlet concept. But by using this, we can then inject things via Spring. By using the once per request filter, we can also make use of Spring Framework. Now we have a red squiggle. Let's hover over this, and it will tell us we need to implement some methods. So we'll need to implement doFilterInternal. Great. Okay, so let's put this on some new lines so we can read everything. Okay, and this is our to-do. This is what we need to implement. So we know for a fact we're going to have our user repository in here, because that's the whole purpose of this filter. So I'm going to put the required Rs constructor on the top of this class, which will allow me, if I declare a private final user repository, we'll call that one user repository, this Lombok annotation will create a constructor for me, which will essentially inject user repository via Spring Framework. So we now have this user repository available to use in our implementation. So how are we going to implement this? So we're going to insert this filter after the Spring Security authentication has taken place, which means we should have access to that authentication object. So we're going to say security context holder dot get context dot get authentication, and we'll assign that to a variable called authentication. Now let's do some validation on this authentication object. Let's just scroll down a bit. So we're going to say if authentication is not null and authentication is authenticated and authentication dot get principal, and we'll use instance of in this case. I try to avoid it where I can, but I think it's necessary here, is instance of JWT, which comes to us from OAuth2 JWT, and it's the type of the principal that we're expecting, at least when using the OAuth2 resource server. Then what do? Well, let's put this on some new lines to begin with so we can read things. Let's just reformat this. Okay, so if the authentication object is not null, and if we're authenticated and the principal is a JWT, well, first of all, let's extract the Keycloak ID, so the ID that Keycloak has assigned to this user. So in order to do that, let's put the word JWT here. So we have reference to our JWT, and then we can say JWT dot, and let's say get subject, because the subject is going to be the user's ID, and it's going to be a UUID. Now I'm going to say UUID from string, which isn't completely safe. So if it did throw an exception for whatever reason, bubbling up to the top may not be the worst thing. So let's assign this to a variable, and I'm going to call this one Keycloak ID. Now let's check whether or not our user exists. And for that, we're going to use the user repository. So we'll say if the user repository exists by ID, passing in the Keycloak ID. So if the user, exclamation mark at the front there. So if the user does not exist in the database, then we'll go about creating a user. So we're going to say user equals new user. There we go. Now, although we did annotate our user objects or user entities, or in fact, all of our entities with the @builder annotation, having thought about it, I'm deciding against using builder And I've come to that conclusion for a couple of reasons. Builder is great. However, it does require us to put additional annotations on instance variables where we have initialized collections. At the moment, the builder would completely ignore this new array list and would assign null to staffing events. In addition to that, we've also made use of the JPA order annotations like created date and last modified date. So I'd rather not cause any issues for that. I'd rather that work as expected. So with that in mind then, the value of using builder is sort of outweighed by the risks of using builder. So I am going to remove it from the user class while we're here, and we'll continue our implementation of the user provisioning filter now. So let's just remind ourselves what a user has. So if we split the screen for a moment and then have our user provisioning filter here. So on the user, we're going to set the ID first of all. So user.setID is going to be the ID from Keycloak. We want to make sure that they match. The name, well, let's say user.setName, and we can extract the name claim. Its preferred username is the one that Keycloak uses. So we can say jwt.getClaims .get, and we'll say preferred underscore username, and we'll call toString on that. In fact, let's put this on some new lines so we can read everything. That looks a bit odd. Let's see if we can reformat that. Okay, let's just scroll down here. We'll just leave that on one line. That format's a bit strange. That will do. So we're setting the name on the user. We want to set the email as well. Then we have organized events, attending events, staffing events, created that and updated that, which will be populated for us, equals in HashCode. So we only really need to worry about setting the email other than what we've already done. So let's close that so we can see everything. And let's say user.setEmail, and we'll say jwt.getClaims. Although strictly speaking, we could do getClaim as string and do it that way, email. In fact, let's do that up here, and then we can have a bit cleaner code. That's much better. There we go. So if the user does not exist, the user identified by this Keycloak ID, then we're going to create a new user entity. We're going to set the ID, the Keycloak ID, on the user. We'll then set the name from the preferred username claim that Keycloak uses as a part of OpenID Connect. We'll also set the email from the email claim. And then all that's left for us to do now is say user repository.save, and we'll save the user in the database. And then right at the end, so outside of all of the ifs, let's just minimize this so it's obvious. We'll want to call filter chain dot do filter request and then response. And that will continue the filter chain. So as a high level summary of this component, we are extracting the authentication object. We're checking it's not null. We're checking that the user is authenticated. We're then extracting the principal, which is going to be of type JWT. If it is, then we're going to extract the subject, which is the UUID, into this variable Keycloak ID, which should identify the user in our database also. So we'll check whether or not the user exists by ID in the database. And if they do not, then we need to create them. So go about creating them by creating a new user entity, setting the ID, the username from the preferred username claim, and then the email from the email claim, and then saving that user in the database. And then we continue with the filter chain. So in summary, we created the user repository interface and implemented the user provisioning filter. Creating a filter isn't enough. We also need to configure Spring Security in order to use it. In this lesson, we'll create a Spring Security configuration file. So back in our IDE, let's create a new package in Devtiro tickets, and we'll call this one config. And within config, we'll create a new Java class, and we'll call this one security config. Let's expand this. So security config is going to be a configuration class. So let's add the configuration annotation to the top here. Now we're going to use this to configure Spring Security. We're going to insert the filter that we've just created into the filter chain. So for that, we'll need to declare the appropriate bean. So we'll say bean, public, and it's the security filter chain. We'll call this one filter chain, and it takes a HTTP security. We'll call that one HTTP. And then we'll also inject the user provisioning filter, which we'll call user provisioning filter. And that's the filter that we've just created. Let's put this on some new lines. Great. Now this will throw an exception. Now we can get to implementing this. So we're going to call http dot authorize HTTP requests. Whenever we configure the Spring Security filter chain, we definitely want to make sure that all requests are authenticated. So within here, it's a Lambda. We're going to specify authorize as the parameter name. And then we'll say authorize dot any request dot authenticated. So this is like a catch-all rule, basically saying every single request will be authenticated by default. So next, we're going to call .csrf. Now, although it's completely possible to use CSRF with a REST API, we're not going to in this particular implementation. And you'll find that's not particularly uncommon out in the wild. However, of course, if you do use a CSRF token mechanism, you will benefit from that additional security. CSRF, and we'll say CSRF.disable. Next, let's deal with session management. As we have a REST API, or as we're building a REST API, it can be completely stateless. So let's specify that so we don't have any overhead from managing sessions. So this is also a Lambda, session management. On session, we're going to call session creation policy, and we're going to set that to session creation policy stateless. Okay, so as we're replacing the security filter chain bean, we should also specify the OAuth2 resource server configuration. We'll call this one OAuth2, and we'll say OAuth2.jwt, and you'll notice actually, if we do this, we have a deprecated JWT call here. So the way of calling this has changed recently, or fairly recently. So we'll say JWT, and then we'll say customizer with defaults. We're just going to use the default configuration, and then we're going to add our filter. So add filter after, and we're going to add the user provisioning filter, which we've injected up here, and we're going to add it after the bearer token authentication filter, like so. And that should make sure that the authentication object is present and the user is authenticated. And with that done, all that we have left to do here is return http.build. There we go. So we now have configured our security filter chain. But there is some additional configuration required before we can test this out. And that has to do with the JPA audit fields that we're using on our entities. So in summary, we created a basic Spring Security configuration file. We disabled the CSRF mechanism on our REST API, and we configured Spring Security to be stateless, and we configured Spring Security to use the user provisioning filter. So simply adding the created at and updated at annotations to entities isn't enough to populate these variables with data. We also need to enable Spring's JPA audit functionality. In this lesson, we'll do just that. So when creating our entities, here we have our user, we added these audit fields. We added the created at and updated at audit fields. And we did this as a best practice because we want to know when these entities are created and updated. And to make things easy, we've used this at created date and at last modified date annotations. There are various different ways to enable these annotations. They're not enabled out of the box. The way that we're going to do today is the way of enabling them globally for our application rather than adding annotations to each entity individually. So to get started, we're going to go to our project, go to our config directory, create a new Java class, and we're going to call this one JPA configuration. And we're going to add the at configuration annotation to the top of this. And we're going to add at enable JPA auditing. And the class, other than this, is going to be completely empty. At enable JPA auditing is the key annotation that we want here. So the next step is to update a configuration file. So to do that, we're going to go to the resources directory. So source main resources. And within here, we're going to create a new directory. And the name of this directory is very specific. Capitals, meta-inf. And within this new directory, we're going to create a new file called orm.xml. So before we go any further, because I appreciate this is quite an odd approach, I just want to draw your attention to the documentation here. So JPA auditing documentation, we can see here created by, created date. So we can actually store the principal using these annotations also. But if we scroll down here we go. So the configuration. So we need to register a auditing entity listener. And to do so, we're going to configure our orm.xml. And here we can see an example right here. The alternative that I mentioned earlier is we can put the @entity listeners annotation on each of our entities. However, if we can update it globally, like we're going to, that's my preferred solution. So orm.xml. Now, unfortunately, the XML example there wasn't complete. So this is what I've come to make things work. Let's just expand this. So you can see here, we have the auditing entity listener, fully qualified in entity listeners, inside of our orm.xml. And I'll put this in the lesson notes so you can paste this in as well. Now, you might be wondering about this meta-inf directory, but basically when the application is built, anything in this directory will be bundled in, and therefore the configuration file will be made available to Hibernate when it's running. So with that, we have now enabled our JPA audit annotations. So in summary, we've created the JPA configuration class with the @enable_JPA auditing annotation, and we've added the orm.xml configuration file enabling the audit fields. So let's recall what we've achieved in the user provisioning module. In user provisioning filter, we created the user repository interface. We implemented the user provisioning filter. In Spring Security configuration, we created a basic Spring Security configuration file. We disabled the CSRF mechanism on our REST API, and we configured Spring Security to be stateless. And we configured Spring Security to use the user provisioning filter. In Enable Spring JPA Audit, we created the JPA configuration class with the @enable_JPA auditing annotation, and we added the orm.xml configuration file enabling the JPA audit fields. In this module, we'll implement the create event endpoint, allowing a user to create an event in our system. The module is structured like this. We'll start by designing the implementation. We'll then add any custom exceptions that we're going to need. We'll then implement the service layer. We'll then implement DTOs and mappers, and that will allow us to implement the REST API endpoint. We'll then add error handling, returning any errors in the correct format and with the correct status codes. We'll then test our brand new create event feature. So now for the learning objectives. So by the end of this module, you'll be able to summarize the user interface and any additional requirements it introduces to the backend implementation. Design the create event service layer implementation. Implement an exception thrown when expected users do not exist. Implement the create event business logic in the backend. Implement the DTOs and mappers required to create an event in the backend. Implement the create event REST API endpoint, and appropriately return errors to the callers of the REST API. And finally, test if the create event functionality is working by using the user interface. So with that covered, let's get started. In this lesson, we'll review the user interface and consider anything that we need to bear in mind when we implement the create events endpoint. So here I have the front-end code, and you can download this from the Devtiro Discord server. Now, what makes this build different from others is that this isn't the completed front-end. This is just the first iteration. So you'll see this evolve over time as the backend evolves as well. And that should hopefully represent the real way that these things are developed. So now that we have the code locally, how do we run it? Well, first things first, we need to run npm install. This will install the dependencies. Now here's the thing, we have a bunch of errors here, but that's sort of expected. So because of the dependencies that we're using, shadcn specifically, we do have some conflicts. However, this is all documented on their website and should hopefully go away soon. So for the time being, rather than npm install, you may need to use --force. So with that done, what we can do is go npm run and dev, and that will run the dev server, making our application available on localhost port 5173. So if we copy this and then go to this address in our browser, here we are, a pretty anticlimactic white page with a login button. However, this isn't what we're going to be using. This is just the default landing page, which will eventually be where people will go in order to search for tickets for events. We're currently implementing the organizers flow. So if we were to go to /organizers, so here we have something that's slightly more refined. So this is the implementation of the designs. As a reminder, the designs for the organizers landing page looked a bit like this. Let's just zoom out a little bit. So we were to have some login buttons in the top right here. We'd have some text here, an image on the right, create event, and then browse events. At the moment, we're implementing the create event flow. So it's only the create event that's been implemented. Now, something else that's different for this particular build is I've recorded the entire front-end build as well, and that's available over on devtiro.com. So this is a design, and this is our page. So let's go to create an event. So we've been redirected to the login page. So this is Keycloak. The username that we're using was organizer, and the password was password. We've been warned to change our password naturally, as it's not very secure at all, but this is my local dev environment. And here we are on the create event page. Now this is the first iteration, and this will be refined over time as well. However, we have our navbar at the top here. We have our OR for organizer user, the email address of the organizer user here, the ability to log out. And then we have the form for creating a new event. So again, as a reminder, let's look at the design for this. So that's our landing page. So the design for this one, we didn't really have a lot to go on. We knew that we wanted a navbar of some kind, we wanted a title, a subtitle, and then the various input fields in order to create an event. We hadn't really nailed down what the structure would look like at that time. This is what we have at the moment. So we're able to specify the event's name, and then optionally, because when we were doing our domain modeling, we decided that start and end, in fact, event start and end, event cell start and end, they would all be optional. So if we did want to provide those, we could go ahead and provide a date and a time. That would then be sent to the REST API. We have our venue details. So we learned from the user personas that some users want a lot of details about the venue, so we've made this a text area. At the moment, venue details is only a string, but we could build that out to be a more elaborate object in future if we choose to. So event start, event end, venue details, event sales start and event sales end. So when tickets go on sale and when tickets stop being on sale. Again, optional. And then we have the ability to add ticket types. So when we were modeling our domain, we decided that an event can have multiple ticket types. So we use this in order to add those ticket types. We may want to define a VIP ticket. It may want to be, say, 99. Total available might be 100. And we can also add a description in there for that particular ticket type as well. We can also go ahead and edit it, and we can also delete it as well. And then we're able to specify the status of our event. Is it draft? Is it published? And within the front end, this builds up a JSON object. And when we click on submit, that will then be posted to the Spring Boot backend that we're building to the endpoint that we're going to implement in this module. Now, something I should point out because it's rather important. If we go into the ticket type here, we have name, we have price, we have total available. And we sort of glanced over the fact that there's this description. Description is a new field that the front-end developer, myself, introduced as a part of the front-end development process. Again, this happens a lot in real life. So we're going to incorporate this new field into our ticket type object on the back end when we implement our endpoint. But as it stands, this is an overview of the first iteration of the create event page. So in summary, the user interface can be used to create an event, and a field name description has been added to the ticket type object. In this lesson, we're going to design our create event endpoint. That's going to include creating interfaces this endpoint might need. So we're back in our IDE. So before we go any further, we've recently learned about a new field that's going to be on one of our objects. It's going to be on the ticket type object here, and let's expand this. And we scroll up here, it's going to be somewhere here. So let's add a private string description to our ticket type, and we'll add this as well. So we'll say that the name is going to be description. It's now the decision to make it nullable or not. I think we should make it nullable. There we go. So we now have this new description field. So with that done then, let's design the object that we're going to use to create an event. So let's open up our project. And within domain, I'm going to create a new sub-package, and I'm going to call this one entities. And everything that's there at the moment, I'm going to drag into entities. We'll click on refactor, and we'll do this in order to keep things organized. So the object that we are to create is going to model the create event request. So we're going to right click, go new Java class, create event request. And let's add that. But I don't want that to be in domain entities. I'm going to refactor and move this class to be in domain, because strictly speaking, this isn't going to be an entity. Let's open up domain. There's our create event request. Now, perhaps the easiest way to model this is to get our event entity on the right-hand side, and then we can have our create event request on the left. Okay, so let's add the data annotation to create event request. It's safe in this particular case because there isn't going to be any bidirectional relationships. And let's say all ours constructor, no ours constructor, and that should do for the moment. So what information are we going to need in order to create an event? We're not going to need the ID because the server, our Spring Boot backend, is going to generate one. So we can omit that. We are going to need a name, so private string name. Start date, yes, we'll need one of those, although it is optional, but it can be made null, so that's fine. And we're also going to need an end date, which we have there. String venue, yes, we'll also have one of those. Sales start, absolutely, we're going to include that too. Sales end, and now status. So this is an interesting thing. So we're using the event status enum here, and that's completely reasonable to use in our persistence and service layers. Some may argue that you should have different enums for your presentation layer that then map to the enums used inside of your service and persistence layers. Others may argue that enumerations like this are part of the vocabulary of your domain and therefore should go cross-layer, as it were. We're going to do the latter. So we're going to take that event status enum and place it into our create event request. Now we start getting into the objects that event relates to. So we have here the organizer of the event. I'm going to choose to include this in the create event request object. And the reason being is that we can get the user and pass that in to the service layer. So we'll include user. We'll not include attendees. We'll not include staff. And now for ticket types. So we do want to represent ticket types in our create event request. However, it doesn't feel right to use the ticket type object because the object that we're modeling on the left, the create event request, its only purpose is to provide the information to create an event. Whereas ticket type, this one referenced on the right here, is an entity. So here's what we're going to do. We'll open up project. Inside of domain, we'll create a new Java class and we'll call this one create ticket type request. And this will be a Java class. Let's close project on the left. And let's move create ticket type to the left. Okay, we'll add data, all ours constructor and no ours constructor onto our class here. And I'm going to control click through into ticket type on the right, which is placed on the left. So let's drag that. Okay, that took a bit of effort, but we have the ticket type entity on the right and the create ticket type request on the left now. So what information do we need in order to create a ticket type? We can omit the ID because the server will generate one. We do need the name, so we'll place that into our create ticket type request. We do need a price. The description, our new field, we should include that. Total available, we should also include that. And then we have the relationship between ticket type and event. We won't include that. We won't include tickets because we're simply creating the ticket type here. We're not creating any tickets, and we're of course not going to include any audit fields. And then we have the equals and HashCode, which will regenerate actually while we're here on ticket type because we've introduced a new field. Equals and HashCode. Next. So we'll include ID, name, price description, total available. We won't include event, we won't include tickets because we don't want to trigger any bidirectional relationships. Next, create. Okay, so with that done then, I think the create ticket type request object that we have now contains all the information that we need to create a ticket type, which is fantastic because we can close this and close this. And then in our create event request, we can say private list of create ticket type request, and we'll call this one ticket types. And we'll initialize that to be a new array list. And we'll need to import list. There we go, had to import that one manually for some reason. So we're representing the organizer of the event. We're representing the ticket types. We're not going to include the created at or updated at. So I think that's it. So the goal for this object is to capture all the information that we need in order to create an event, because we're going to use this object in our interface that we're going to create in one moment. So you might be wondering, why have we included user in this, which is very much an entity, but we've created a brand new create ticket type request object to represent ticket types. The caller won't be providing the user object. We'll be loading that again from the service layer and then passing it through. However, the representation of the ticket type, and in fact the representation of the event itself, that will be passed in from the user, so the caller of the REST API. So although we could decouple this and use a different user representation, I feel that may have been a bit overkill at this particular time. So we have our create event request object. How do we use it? If we open up project here, and we're going to create a new package inside of Devtiro tickets, and we're going to call this one services. And within services, we're going to create a new Java class, and I'm going to call this one event service, but it's not going to be a class, it's going to be an interface. And I was just about to close projects on the left here, but I've noticed there's a typo in repositories, REST repositories. So let's refactor, rename that, and correct that typo while we're here. Refactor. There we go. The Boy Scout rule in action. So let's minimize that now. So this interface is to represent the event service, a service that's concerned with managing events, their entire life cycle. So we're going to declare a method on the event service, and I'm going to call this one create event. It's going to return an event, so the entity, the event that's been created. The method's called create event, and now we get to declare the arguments. So we're certainly going to need to pass in the create event request, and we'll call that one event. That's the representation of the event that we are to create. However, having just explained the representation of user inside of create event request, I'm starting to feel like there may be a better solution. So I'm going to remove organizer from create event request here. So this only contains the information that represents the event. What I'm going to do instead is over on event service, I'm going to say that the caller must specify the UUID, which will import the organizer ID, like so. So in order to create an event, the caller of this particular method must provide the organizer ID and the bare minimum information required to create an event as represented by the create event request. And that feels like a much cleaner implementation than including the organizer user in this particular class. So in summary, we implemented the create ticket type request class, and that represents the bare minimum information to create a ticket type. We implemented the create event request class, representing the bare minimum information to create an event. And we created the event service interface, which declares the create event method, a method which, once implemented, we'll use to create an event in the application. Having just designed the event service that we'll use to create an event, we know that we're going to be passed the organizer's ID and that we must link a user to an event. The thing is, the user identified by that ID may not exist. So in this lesson, we're going to create the exceptions that we'll use when the user cannot be found. So here we are back in our IDE. So let's create the exception that we'll use when a user cannot be found. So we'll create a new package inside of Devtiro tickets, and that's going to be called exceptions. And within exceptions, I'm going to create a new class, and I'm going to call this one event ticket exception, and it will be a class. Now you might be wondering why I've created such a generically named class. Well, the reason for this is I intend for this particular class to be the parent of all custom exceptions that we'll use in this particular application. And that has the benefit of keeping things organized, but it also allows us to, when we define a catch, we can specify this particular exception type and be confident that it will catch all of our custom exceptions. Let's just expand this. So which exception class are we going to extend? We're going to extend the runtime exception. And that means that we don't have to declare throws of the exception on any methods that throw this exception. The rationale for doing this is that by using a checked exception, so if we were to extend exception, Uncle Bob argues that this will break the open-closed principle, and therefore he recommends that we use runtime exception. So this is in the clean codebook. So we're going to use runtime exception for this. Now, with an exception, we'll need to declare which constructors that we want to use. So let's right-click and we'll go generate, constructor, and we're going to select all of them and click OK. It's generally good practice to include all of the constructors like so. So we now have this generic base custom exception. We're going to create the exception now that represents the user not found. So over in exceptions, I'm going to create a new Java class and I'm going to call this one user not found exception. And it's going to be a class. And we'll extend our event ticket exception. And then we'll right click in here and we'll go generate, constructor, Control A to select all, and then OK. There we go. We now have a custom exception that we can use to represent a user not found. So in summary, we created an event ticket exception, parent custom exception. And we created the user not found exception to represent the invalid state when a specified user does not exist. In this lesson, we'll implement the service layer logic to create events in our application. So back in our IDE, we've already declared that we have an event service. So let's, inside of the services package, create a new subpackage called impl, a convention that you'll often see, and it allows us to collect together all of the implementing classes for our interfaces. And within impl, I'm going to create a new Java class called event service impl, and it's going to be a Java class. And event service impl implements the event service. So let's expand this. And if we hover over here, it will tell us that we have a red squiggle because we haven't implemented the methods declared inside of our event service, namely create event. So we now have our create event method stub. Before we go any further, I'm going to add the @service annotation to the top of this class. I'm also going to add the @required args constructor annotation to the top of this class. The top one marks this class as a service, which will allow us to inject dependencies and also make event service impl available to inject whenever we declare an event service or an event service impl, but will typically declare the interface. And required args constructor, this comes from Lombok and it will generate a constructor for us based on any instance variables that we specify here that are final. And that gives us a nice clean way to create a constructor, which will then inject these dependencies for us. So we've decided that we're going to use this organizer ID rather than passing about a user object. So we're going to need we'll say private final user repository. We'll call that one user repository. We're going to need the user repository to look up these users. So inside of our create event method here, I'm going to say user repository dot find by ID, this one here, passing in the organizer ID. And I'm going to assign that to a variable, which I'm going to call organizer. However, I don't want an optional here, so I'm going to delete the optional type. And instead, I'm going to handle this here and now. So I'm going to say, or else throw. So in the case that the user was not found, we're going to throw a new user not found exception. And we'll put the message in here, string.format, I think. Put that on a new line. And we'll say something like user with ID, and then we'll do a %s to represent a string. User with ID, the ID not found. And then we'll need to pass in the organizer ID. And even though the organizer ID is a UUID, that seems to have worked. Okay, great, perfect. So within the user not found exception, we have the ID of the user that's not found as a message. So we now have our organizer user, or we throw a user not found exception. And we're going to need this organizer in order to create these entities. Let's create ourselves an event entity. So we'll say event to create equals new event. And let's, in fact, open up event and let's stick that on the right-hand side. Great, okay. So we're not going to specify an ID because the way that we've set up our entity, it will generate one for us. We are going to specify the name. So we're going to say event to create dot set name, passing in event get name. So event, of course, is our create event request. So we're going to pass in the name from there. And this is going to be the general pattern that we're going to follow. So we've just done name. Let's now do start. Event create dot set start equals event dot get start. We'll do end. Event create dot set end event dot get end. Venue. Event create dot set venue equals event dot get venue. And now sales start, event create dot set sales start equals event dot get sales start. And now sales end, event to create dot set sales end equals event dot get sales end. And now for status, event create dot set status, and that's event dot get status because we're using that enum throughout. And now our organizer, which we've loaded up here. So event create dot set organizer is the organizer user. And now we have attendees, which defaults to be a new array list. That's fine for us. Staff, again, new array list. Ticket types. We should set ticket types because that's provided in our create event request object. But they're complex objects in their own right. So if we go through ticket type, in fact, before we create our new event, let's say event.getTicketTypes.map, or stream.map, should I say. And this is our ticket type. Let's just pull that over for the moment so we can see. Great. Okay, so we're mapping over the ticket types, which are create ticket type requests. We're going to create a new ticket type object. So we'll say ticket type, or the convention we're following is ticket type to create equals new ticket type. And now we'll need to start setting the values on ticket type, which we just pull that over a little bit. We should be able to work our way through. Scroll that way. Okay. So the first one is going to be the name because we're not setting the ID. We'll have that generated for us. Ticket type to create dot set name is going to be ticket type get name. Next is going to be price. Ticket type to create dot set price is going to be ticket type dot price. It seems we've made an error on the set name. We should be loading from ticket type and not ticket type to create. Okay, so we have loaded the name, set that, loaded the price, set that. Now for the description. Ticket type to create dot set description, ticket type, get description. And now total available. Ticket type to create dot set total available is ticket type, get total available. So we have our event, we have our tickets, created that, updated that. So that should be it for the moment. So let's close this so we can see what we're doing. Close all tabs and group. And we're going to do to list. And of course, we need to return the ticket type to create at the end of that lambda, which means we can then assign this whole block, which we'll call ticket types to create. Great. So we have a list of ticket types. What we can now do is say event to create.set ticket types, paste that in, ticket types to create, and we can rely on any cascades to create those for us. Now, let's just go to the event object. We've done ID, we've done name, start, end, venue, sales start, sales end, we've done status, we've linked the organizer user that we've loaded. We're not going to do attendees staff because they don't even come into the equation yet. Ticket types. We've just set ticket types. We're not going to set created at or updated at because we're relying on our JPA audit annotations to do that for us. And then the rest is just equals and hashcode. So that looks like we have populated the event to create. So all that's left for us to do now is to save this. But currently we have no way of saving it. So if we go over to our repositories package on the left here, create a new Java class, and we'll call this one event repository, and it will be an interface. We're going to follow the same approach that we've done for user repository. We're going to extend JPA repository. Let's just maximize this. We need to specify the type, which is going to be event. That's our entity. UUID is our ID type. We'll put the at repository annotation on the top here, and we now have a event repository to use. So we can go back to event service impl, scroll up. We'll say private final event repository. We'll call that one event repository. Let's import this. Perfect. And now at the bottom of our create method, we can call event repository.save, passing in our event to create, and then we can call return because of course save returns the object that it's just saved, complete with all of the values that it's generated, ID, created at, updated at. Okay, and with that done, that's our first implementation of our create event method. So in summary, we've created the event repository interface, and we've created the event service import class, and we've implemented the create event method. So now that we've implemented our service layer, let's create the DTOs and mappers that we're going to use in our presentation layer. So back in our IDE, let's create those DTOs and mappers that we can use to model our REST API. So within of domain here, we're going to create a new subpackage, and I'm going to call this one DTOs. And within DTOs, I'm going to create a new Java class, and I'm going to call this one create event request DTO. And this is going to be a class. Now you might be wondering why we are creating a create event request DTO when we already have a create event request, which looks like this. There is a couple of reasons for that. The create event request, I expect that to be used in the service layer, whereas the create event request DTO, I expect to be used in the presentation layer. And because the create event request DTO represents exactly what the REST API expects, I don't want changes to the create event request to impact the create event request DTO and vice versa. I want them decoupled. So the convention that we're going to follow is anything with DTO after the name, you can expect that to be used in the presentation layer. Although largely, to begin with, both of these classes are going to be pretty much the same. So much the same, in fact. I'm going to split the screen on the right for create event request. Create event request DTO can be on the left. Let's just close project so we have some space. So to the top of create event request DTO, we're going to add @data, all R's constructor, no R's constructor. And in fact, I'm going to take everything right down to status, copy that, and paste it in here. That's not going to be all that will do though, mind you. We are using this object create ticket type request. If I control click through to this, it represents the bare minimum information to create a ticket type. We'll need a DTO for this as well. So I'm going to, inside of DTOs, create a new Java class called create ticket type request DTO. And it's going to be a Java class. Let's close project again, and I'll pull the DTO to be on the left. So to the top of the create ticket type request DTO, I'm going to add @data, all R's constructor, no R's constructor. And then I'm going to take all the instance variables and paste them in there. However, we're not going to stop there, because inside of our DTO, we're going to add some validations. Now, I don't believe that we included the validation dependency when we were going through the Spring Initializer, but not to worry because we can add it now. So let's open up our project. Let's go to our pom.xml file, which is here. Let's close project so we have some space, and we may just have to pull that over a little bit. So we'll do this just after our Spring Boot Starter web. In fact, I'm going to copy the Spring Boot Starter web dependency, but rather than Spring Boot Starter web, I'm going to include Spring Boot Starter validation. And if we click the little Sync Maven Changes button up here, we now have access to those validation annotations. So let's close our pom.xml file. We are back in the create ticket type request DTO. Let's pull that over. So we have our split screen again. There we are. So now let's add some validations to the top of these. We always want the name of a ticket type to be provided. So I'm going to use the not blank annotation to the top of this. And I'm going to say the message is ticket type, name is required. I'm going to add the not null annotation to the top of price. We always want a price. And I'm going to say the message for this one is price is required. I'm also going to add a positive or 0 annotation to the top of this. We certainly don't want a minus price. So the message for this one is going to be price must be 0 or greater. So we'll allow a 0 price, but certainly not a minus price. So for description, we decided that this was going to be optional, so I'm not going to add any validation to description. We may want to specify a maximum on there. However, we haven't nailed down what the maximum length of a description might be yet, so we'll leave that as it is. And the same for total available. We've decided that this could actually be nullable in cases where perhaps there's an infinite number of tickets available, perhaps for an online conference, for example. So that represents our create ticket type request DTO. So if we go back to our create event request DTO, and for symmetry, let's close this on the right. So we have our create event request on the right. We can say private list of create ticket type request DTO, and we'll call that one ticket types. We'll need to import list. Great. So I'm confident that we have everything from create event request in create event request DTO. So I'm going to close this, and let's now add some validations to create event request DTO. So for name, we always want this provided. So again, not blank. We're going to say the message is event name is required. For start and end, we've decided that these can be nullable. If we really wanted to refine this, we could make sure that the end date is after the start date. But for the first iteration, let's just get it working first so we can come back to that. So we'll not add anything to start or end. We always want venue information. So let's say not blank. And the message for this one is going to be venue details are required, or maybe venue information is required. Okay. Sales start and sales end, they can be nullable. Again, we may want to add some validation that end is after start if provided. We can get to that later. Event status enum. Let's say not null. We always want to make sure that's provided. So we'll say message event status must be provided. And then we have our ticket types. We want to make sure that at least one ticket type is provided, I think. I'm not sure that we've captured that anywhere, but I'm going to codify that in now. So we'll say message at least one ticket type is required. And I'm also going to add the @valid annotation, and that will activate any validation annotations within the create ticket type request DTO nested class, of which we have some. So that looks like our create event request DTO done. Now, the convention that we're going to follow for this particular build, on the basis that it's probably going to have a rather complicated REST API, is that we're going to model the requests separate from the responses. And we'll very rarely use a generic DTO in the presentation layer. So with that in mind, we should create the create event response DTOs now. These will be very simple, and they won't require any validation because they'll be on the return path. So let's open up project. And inside of DTOs, I'm going to create a new Java class, and I'm going to call this one create event response DTO. And it's going to be a Java class. And we'll expand this. We'll say @data, all R's constructor, no R's constructor. Now, what are we going to populate inside of the create event response DTO? Well, it's largely just going to be the same as our event entity, more or less. So let's bring up the event entity. We'll put that on the right-hand side. Create event response DTO on the left. Let's scroll up to the top here. So we definitely want the ID to be in the create event response body. We definitely want the name of the event, the start time if it's been provided, the end time if it's been provided, the venue, the sales start time, sales end time, the status. I'm going to choose to omit the organizer. We'll not include the organizer information. And there's no point including attendees because there won't be any. We've just created the event. Same for staff. We should provide ticket types though. So let's create a DTO separate for that. So over in DTOs here, we'll create a new Java class called create ticket type response DTO. Pull that to the left, close project. And if we were to control click through to ticket type to see the ticket type entity, okay, so let's put the @data, all R's constructor, no R's constructor on the top of create ticket type response DTO. These names are getting quite long. Let's do the ID in there, the name of the ticket type, the price of the ticket type, we want the description of the ticket type, the total available, and we'll omit event because we already have that information. We don't want it nested again. Tickets, we'll omit that because there's no tickets associated with the ticket type yet. Perhaps we will include created at and updated at. There we go. So that's our create ticket type response DTO, which if we close the ticket type on the right and the create ticket type response DTO on the left, we can now use, that's our request, close that one. We can now use our private create ticket type response DTO list of, so list ticket types. Great. So that deals with this particular field in our event mapped to our create event response DTO. Let's also include the created at time and the updated at time. Perfect. Great. Okay. So with that done, we now have DTOs to represent the create and the response. Let's wrap up this lesson by creating the mapper for them. So within Devtiro tickets, I'm going to create a new package called mappers. And within mappers, I'm going to create a new Java class called event mapper. And we'll make this an interface. And let's expand this. So to the top of event mapper, this is going to be a MapStruct mapper. So the convention used here is to specify the mapper annotation. The component model is the string Spring. The unmapped target policy is going to be reporting policy dot ignore. Ignore anything you can't map. And now we can specify some methods in here. So this one is going to return a create ticket type request. So in our service layer, that object. And we'll call this one from create ticket type request DTO. Although I wonder if we can get away with just overloading them from DTO. And then we can specify the create ticket type request DTO as the DTO there. So we need to call this in our create endpoint method to take the response body and convert it into the create ticket type request, which we can use in our service layer. But of course, the create ticket type request is a nested object within the create event request. So we'll do the same thing from DTO. Hopefully MapStruct knows how to deal with that. Create event request. And we'll call this one DTO. So that should map the create event request DTO, let's import that, to the create event request. And then we want to do on the response side of things, we want to return a create event response DTO, and we'll say to DTO, passing in the event. Because the event's what we're going to get back from our service layer after I create. And the create event response DTO contains a subset of the information in the overall event. So that should work. MapStruct should know what to do with that. So with that in mind, we have DTOs for both the create side of things, the response side of things, and then we have a mapper to go from one to the other. So in summary, we created the create event request DTO. We created the create event response DTO. We created the event mapper interface. And the DTOs make use of validation annotations to ensure data consistency. In this lesson, we'll create the event controller and the endpoint callers can use to create events. So we're back in our IDE. Inside of Devtiro tickets, we're going to create a new package and we're going to call this one controllers. Within controllers, we're going to create a new Java class and we'll call this one event controller. And let's expand this. So to the top of the event controller class, we're going to add the REST controller annotation. We're also going to specify a request mapping. We're going to specify the root or the base path of this controller, if you will, and it's going to be /API v1 events. So all endpoints on this controller, their paths are going to start API v1 events. I'm also going to add the required R's constructor to the top of this class as well. And that will allow us to inject the, we say private final event mapper. We need that, certainly. And then the private final event service, which we'll call event service. So we now have access to our event mapper and our event service. So let's create a new public method, which will return a response entity wrapping a create event response DTO. And we're going to call this endpoint create event. Now, before we go any further, let's put the post mapping annotation to the top of this endpoint method because we're going to be using HTTP post. With that in mind then, let's inject a few things. Let's get hold of the JWT, so the token that's been passed by the caller. Bearing in mind at this point, it's already been authenticated. So we're going to use the @authentication principal annotation from Spring Security for this. And we'll say JWT because that's going to be the type of the principal, noting it comes to us from security L2 JWT. And we'll simply call this one JWT. We'll also need to get hold of the request body. So we're going to say @request body. And the request body is going to contain a create event request DTO. And we're going to call this one create event request DTO. We're also going to put the @valid annotation before that to make sure that we have ourselves a valid create event request DTO, that those validation annotations have been activated. So we have a JWT, a create event request DTO. I think that's actually all we'll need for the moment. So let's get to implementing this method. So first of all, let's convert the create event request DTO to a create event request, which we can use in our service layer. For that, we're going to use the event mapper. Event mapper dot from DTO, certainly doesn't matter which one we select really, as long as we pass in a create event request DTO, so the argument to the method here. We can assign that to a variable, which we're going to call create event request. Next, let's extract the ID from the JWT. So we'll say JWT dot get subject. That will return a string. So we're going to have to do UUID dot from string for this. Perhaps we'll extract this out into a utility or something like that. It feels a bit uncomfortable to do it each time, but this should then represent the user ID. Or perhaps better put, the caller user ID. Now we're going to assume, for the sake of the implementation for the moment, that the caller of the REST API endpoint is also the organizer of the event. We could potentially extend it in future for the user to be able to specify other users as organizers, but not for the first iteration. So we have ourselves a create event request and the user ID in UUID format. So next, let's call the event service dot create event, passing in the user ID as the organizer ID and the create event request. Now, if we assign this to a variable, this is our created event. Now, it should be noted that create event does throw an exception. In fact, I'm sure it probably throws several exceptions, but the one that we care about at the moment is the user not found exception. We'll handle that in the upcoming lessons. So we now have ourselves a created event. So let's get a response object. We'll go event mapper dot to DTO, passing in the created event, and we'll assign this to a variable which we'll call created, or perhaps for consistency, we'll just call it the create event response DTO. And now we'll return a new response entity, passing in the create event response DTO. And I'm also going to specify the HTTP status of created, HTTP 201. And with that, we have our initial implementation of our create event endpoint. So in summary, we've created the event controller class, and we've implemented the create event endpoint. At this point in the build, we should be aware of two things. The first one is that the user interface expects any errors in a very particular structure. And the second one is that we have a few exceptions that we're not handling that we should. So in this lesson, we're going to create a global exception handler to handle those exceptions, returning them in the accepted format. So here we are back in our IDE. Let's head over to our controllers package, and we're going to create a new Java class, and we'll call this one the global exception handler. Great, and let's expand this. So this class is going to handle all of the exceptions that we define that bubble up to the top. And then we'll get to control what the responses look like from our REST API. So to the top of this class, I'm going to use the @REST controller advice annotation. And I'm also going to use the SLF4J annotation. This top one tells Spring that it should look here in order to find how to handle certain exceptions. And we could also specify controller advice. That's completely reasonable. But as we have built a REST API here, we're only going to be returning data structures and not pages. We're going to use the REST controller advice annotation. SLF4J annotation, that comes to us from Lombok and allows us easy access to a logger. Because if we get an exception, it makes sense that we want to put that in the log. There's a few exceptions that I have in mind that we should handle, but I think we should start with just the generic exception class. So I'm going to say public response entity, and here we'll need to specify actually the structure that the user interface expects for all errors. So let's go to our project on the left here. We'll go to DTOs, and I'm going to create a new Java class, and I'm going to call this one error DTO. And let's expand this. This is going to be a very simple class indeed. we're going to add @data, all R's constructor, no R's constructor. So error DTO is only going to have a single instance variable, private string error. So this will return any error as a very simple JSON object with the key of error and then a string which describes the error. So with this created, we'll go back to the global exception handler. The error DTO becomes the type in the response entity, and we can name this method handle exception. And the method is going to take just a exception class, we'll call that EX. So this is a general pattern that we're going to follow. We're going to log.error, and we'll say something like caught exception, and then we'll pass in the exception. Then we'll create an error DTO. So we'll say error DTO equals new error DTO. Then we'll say error DTO dot error, or set error, should I say. For this generic exception, we can't really give too much information. So we'll say in the string value, something like an unknown error occurred. We don't really want to pass information about the exception in the message. We don't want to leak internal state, internal details. So we just have to say an unknown error occurred, but we are logging the exception in the logs, part of the reason that we're doing it there. So we now have our error DTO. Let's go about returning it to the user. So we're going to return a new response entity, passing in the error DTO, and we'll go with a HTTP status of internal server error. Now there's one thing missing on this method to complete it, and that's an annotation. We need to add the @exception handler annotation, and we're going to specify the exception class. There we go. So let's move on to some more specialized cases. So our validation annotations are going to throw one of two different types of exception depending on where we've used them. We'll cover both just to be on the safe side. So the first one is the constraint violation exception. So we'll say public response entity of the error DTO type, and we'll say handle constraint violation. There we go. And we'll pass in the constraint violation latent exception coming to us from Jakarta validation. We'll call this one EX. There we go. Now, before we forget, I'm going to put the @exception handler annotation on the top, specifying the constraint violation exception from Jakarta validation .class. Great. So the body for this one is going to be fairly similar. I'm just going to copy this and put it up here. I'm going to change the message to say the particular type of exception that was thrown, or caught in this case, should I say. However, for the error message, we can do a bit better now that we know the type of the exception. So we're going to say EX, which is a constraint violation exception. And we can say get constraint violations, which is a set of constraint violations. We're then going to stream. I think in this particular case, we'll just return the first one. So we'll go find first, and that will return an optional. Let's start putting this on new lines. That will return an optional, so we need to map. And then we'll say violation as the argument type, violation.get property path. There we go. And then we'll concatenate this. So there's some very particular fields that we want in our message. So the property path, so where the violation has taken place. And then we'll say violation dot, is there a message? Yeah, get message. Let's put that on a new line. So that should be a pretty good error message. Now we're returning the details from the violation. However, this should be safe. This is helpful to the user and shouldn't expose any internal implementation details. We'll say or else, and we'll put a message in there like a constraint violation occurred. So let's assign this to a variable, which we'll call error message. And now we can pass this error message into error DTO.setError. And I think rather than internal server error for this one, we're going to return bad request because the user has provided a request body that doesn't meet our requirement. So therefore HTTP 400 bad request. So that's the constraint violation exception handled. Now the other exception that we should handle is the method argument not valid exception. So we're going to say public response entity error DTO, and we'll call this one handle. Here we go, method argument not valid exception. And then we'll need to pass in the method argument not valid exception, and we'll call that EX. And again, before we go any further, I'm going to copy that rather than type it out again. And we're going to say exception handler, method argument not valid exception dot class. So what about the implementation for this one? Well, I'm going to take the handle exception for the generic exception because it's a pretty good starting point. And we'll say caught method argument not valid exception. We're creating a new error DTO. How do we create the error message for this one? Well, this one works with binding results. So we need to do ex.get binding result. Let's just assign that to a variable called binding result. And then we can say binding result dot get field errors. I think there's a, yep, there it is. That'll give us a list of field errors, which if we assign that to a variable, we can see. And I think we'll just return the first one again. So something like field errors dot stream dot find first dot map. And we'll say, we'll call that one field error. Great. We put this on some new lines. There we go. Field error dot get field. And let's just concatenate this with field error dot get default message. We'll need to do an or else for when it's not available. And we'll say something like validation, what we said for the other one, constraint violation occurred. We'll say validation error occurred. There we go. And if we assign that to a variable, which we'll call error message, fix that typo. So error message, we can now pass into set error here. And again, I think we'll return a bad request. So HTTP 400 for this. Okay, and there is one last exception that we should definitely handle, and that's the user not found exception, our custom exception that we're throwing. So for this, we'll say public response entity returning an error DTO, and we'll say handle user not found exception, passing in a user not found exception, which we'll call EX. And again, we'll add the @exception handler to the top here, passing in the user not found exception dot class. And we'll scroll down to the bottom where we have the implementation for handle exception. Scroll to the top, paste that in. Great starting point. So what's the error message going to be for this one? Well, we could print out the message that we're passing in the exception, which is user with ID, whatever the ID is, was not found. But again, I don't want to leak that internal detail. So I'm going to set the message to be something generic. So we'll say user not found. Now, do we return a 404 or a 400? I think a 400. Bad request. Because this exception is going to be thrown by endpoints that have been given a user ID in order to do something. So in our case, create an event. Therefore, if we turn a 404, that's a 404 associated with the event web resource, which doesn't make sense because it's not the event that doesn't exist, it's the user. So we'll go with a HTTP 400. A bit abstract, I appreciate, but I think HTTP 400 fits us here. For the sake of consistency, we'll say user not found exception, caught user not found exception. So with this done then, we should have handled our generic exceptions and everything that extends it. But in more specialized cases, the constraint violation exception, the method argument not valid exception, and our custom user not found exception. So in summary, we created the error DTO class, and we created the global exception handler class. And now all errors are now returned in the expected format. So now that we've implemented the first iteration of our create event endpoint, let's try it out by calling it from our user interface. So here we are back in our IDE. Now, before we can call the REST API via the user interface, we need to run our Spring Boot application. If you haven't already, now is the time to start your Docker Compose environment. I'm going to do that with Docker Compose up. Okay, everything looks to have started successfully, so let's minimize this. Now, the next step is that we'll want to run clean compile with Maven. So if we open up the Maven panel on the right here, we can run clean compile. Now, the reason for this is that we're using MapStruct and Lombok, and they generate code for us. I've experienced some issues if we jump right to running the application, but if we run clean compile, all of those issues go away. I suspect this has to do with some of the generated code being stale if we jump straight to running the application. But let's run clean compile. Build success, looking good. Let's minimize this and close the Maven panel. So the next step is to run our backend application, which we can do with the green triangle up here, or we can go to the tickets application. On the left, we can click on run. Okay, the application's started, by the look of things, started, tickets, application, but we do have a stack trace here. Error relation events does not exist. Error executing DDL. So this is auto DDL, Hibernate trying to generate the tables for us. So if we scroll all the way up to the top, I wonder if there's a reason that we can't do this. Error relation events does not exist. Let's keep going. Same again. Events does not exist. Okay, pretty consistent error message, but it doesn't tell us a lot because events, of course, should be generated by auto DDL just like anything else. Haha. Syntax error at or near end. Where have we used end? We've used end inside of our event entity, which would make sense. Why we're seeing the events relations does not exist if the events table failed to create. Is there any more information that we can go on? Error executing DDL. Syntax error at or near end, which is here. Okay, I suspect end is a reserved keyword in Postgres. If we were to minimize this and go over to our entities, so in domain and entities, go to events and expand this, we're using end as the column name and we're using start as the column name here. I suspect start is also a reserved keyword if I remember rightly. So here's what we're going to do. We're going to keep the name of the instance variables as start and end. However, I'm going to change the column name to be event underscore start and event underscore end. And I can't imagine event underscore start or event underscore end being reserved keywords. So with that done, let's open up the run panel once more, and I'm going to rerun. Great. Okay, so we have some output from Hibernate, creating the various tables, etc. that we need. And the application seems to have started up fine. Perfect. So just to double check that, let's take a look at the tables in AdMiner. So AdMiner is a service that we're also running in our Docker Compose environment, and it's going to allow us to view the database visually. So we have a PostgreSQL database here. We are connecting to it via the server name DB. And the reason for that is if we take a look at, let's minimize that, our Docker Compose environment, or Docker Compose YAML, should I say, the service name of our database is DB. And because we're also running AdMiner inside of Docker Compose, we're able to use this name to connect to our database. I'm also going to copy the Postgres password that we're using because we're going to need that. So the username is going to be Postgres. The password is the password that we just copied. Now let's log in. Looking good. So we're using the Postgres database. Great. And it looks like our tables have been created. We take a look at events here. There we are. So event end and event start. So we've been able to use those particular field names. We select data. There's no rows because we haven't created any events yet. Great. So with that in mind, let's open up our user interface. So I've navigated straight to /organizers, this being the organizers landing page. And I'm going to click on create an event. We're redirected to the login. So I'm going to log in with organizer and password, the user that we created. We've been prompted to change the password because it's not very secure, but this is okay. It's my local development environment. Obviously don't use the password in production. And here we are, create a new event form. So I'm going to open up the inspect and then we'll go networks panel and let's try creating an event. So we're going to not be very imaginative with this one. We'll say test event 1. For the event start and the event end, I'm just going to leave those blank. We'll do the bare minimum information for this one. Venue details. I think venue details we can leave blank as well then. Event sales start, end, we can leave that blank. We do need to provide a ticket type. So let's say ticket test ticket type 1. Price we'll do is 123. Total available 123. Description test ticket type 1. Description. Let's actually change total available to be 456. So it's different in value from our price. Click on save. Test ticket type 1 has been added and we'll keep it in draft mode for the time being. So let's try out creating our event. Okay, so we have an error and an unknown error occurred. We get a HTTP 500, although the payload looks like it's okay. Test ticket type 1 description, test ticket type 1, 123, 456, the venue is blank string. So what could be going wrong? Let's take a look at the stack trace inside of our backend application. So back in our IDE, let's go to the run panel here. That looked blank to begin with. Let's just scroll down. Okay, that is certainly a stack trace. Let's see what we have. We scroll up. No resource found exception, no static resource at API v1 events. No static resource. This generally happens when we are trying to hit a REST API that doesn't exist, a REST API endpoint that doesn't exist, should I say. But I'm certain that we specified this. So let's go over to the controllers, event controller, API v1 events, API v1 events. Okay, we've used the argument name params when it should have been path. So if we restart our backend application now, okay, that's the backend application started up. Okay, so let's head back to our user interface. Okay, so here's what I'm going to do. I'm going to make no changes whatsoever. I'm just going to click on submit again. Venue information is required. So this is an example of our global exception handler catching one of those validation exceptions and then giving us the information. So venue information is required. So we must have made this required and I've left it blank. So we'll say test venue details. And with that done, let's scroll down again. In fact, let's clear the networks panel. And now let's click on submit. 201. Excellent. So at the moment, the user interface doesn't redirect or do anything like that because that's where it is in its development. However, we do get a HTTP 201, which is exactly what we're looking for because that's the status for created. The response, let's take a look at the response here. We have an ID that's been generated for us. The name is test event 1, which matches what we can just scroll up a bit. There we are. So test event 1 matches the event name that we've put in here. The start and end are null, and that's because we haven't specified a start and an end. The venue details, test venue details, that's there. Cell start and end, they're both off, so they're both null. The status is draft, so the status we specify down here. And then we have ticket types. UUID has been generated for us. The name is test ticket type 1, that matches. The price is 123, that matches. Test ticket type 1 description. Yep, that's what we specified in there. In fact, we pull that down a bit. Test ticket type 1 description. Total available 456. And we have the created at and the updated at date times generated for us as well. That's true for both the ticket type and for the overall event object. If we wanted to doubly check this, we can go over to add miner, we can go select data now, and we now get some data in here. Although perhaps what's slightly concerning is that we get 2 entries. Organizer ID. Okay, so the details are the same and they've been made about a second apart by the look of things. If we go back to our user interface, I wonder if I got a bit trigger happy. I did. Okay, so I clicked it twice. That's my mistake. But in terms of the actual event being created here, it looks like, yes, the event has been created and that looks good. I wonder if we can see the organizer ID, actually. We haven't taken a look at the user in the database yet. So we've made a request and our user provisioning filter has created for us this user with this ID. This is when it's created and we have ourselves the email address of the user. This was extracted from the JWT and then the name of the user also extracted from the JWT, created at, updated at. They are our JPA audit fields. So it looks like our user provisioning filter is working as well. Now, for the sake of everything being complete, I'd like to see ticket types. Select data. Great. So we have 2 records. Again, I clicked twice by the look of things, but we have created at, ID, description, name, price total available, updated at, it's all there. The only thing that's not there by the look of things is this event ID. It's null. So let's just look at the ticket entity for one moment. Minimize that. Ticket type. I did say ticket entity, didn't I? I meant ticket type. That's what we're looking at, isn't it? Let's just double check. This is in the ticket types table. Yes, okay. Let's go back. So where's the event link here? Interesting. So it looks like I've missed off adding the event. Actually, that does make sense. Let's take a look at the service layer. Go into services, go into the event service import here. Let's pull that across. Okay, so we extract our organizer. We list our ticket types to create, and then we add the ticket types to the event. But what we haven't done is added the event to the ticket types. So let's cut that. Let's place that up here. And then we can do ticket type to create dot set event, passing in the event. Should I say the event to create? There we go. Now I wonder if we have to persist this event before we can set it on the ticket types. I think we'll have to double check that. Let's restart our backend application. Okay, that's started up fine. Let's try this out. So back on our user interface now, I think we should probably put in some different details just to make it obvious. Test event 2. This time we're going to keep everything the same, I think, for the test case. So we'll say venue details 2. Keep those all off. We'll add a ticket type and we'll say test ticket type 2. Price 123 456. And we'll say test ticket type 2 description. Save that. And then we'll keep it in draft. Click on submit. Okay, HTTP 201. That's been created. Let's take a look at things in our database now. So I'm going to click on select data once more. We have a third record here. ID, created that, description, name, total available. Wonderful. So this one now has an event ID. So that link is there. So we click through to this. There's our event. Okay, so it looks like then we have an event being created successfully, linking to our organizer ID. So our organizer user. We have ticket types, we select data, being created successfully, and then linking through to our event ID. Great. Now I'd like to see a test where we provide all of the data. So back to our user interface. Let's just refresh this page. I'm going to go with test event 3. Event start. Let's specify, let's just pull this down a bit. So event start, let's say the event is going to take place on the 10th of May at 10 o'clock in the morning. The event ends at, let's say, 6 o'clock in the evening. Venue details, let's say online event. The event sales start. So let's say tickets go on sale on the 9th at, let's say, 1 o'clock. And tickets stop being on sale at, let's say, 6 o'clock. For the ticket types, let's say general admission. And the price is, let's say, 100. And the total available, let's say, 200. Description, let's say, access to event. Click on save. Great. Okay, and we'll say this is published. So I think that's all of the information provided this time. So all of the dates as well. So if we pull this up, clear this, and then we'll click on submit, 201. Let's make sure everything's in the payload. Okay, I'm seeing some dates. Start date, 10/6. Sales start, 1/6. Great. And then published. Okay, that's looking good. So let's head over to our database now. Let's start over on events, select data. Okay, so it's this last one here. We can see it has a event end date in there, name, sales end date, great. Sales start date, event start. This one's published, online event. It's got the organizer ID, which is linked there. Let's look at ticket types, select data. So this one at the bottom, created that. Access to event, general admissions, 100, 200, updated at, and there's our link through to our event ID. As a last stop, let's just make sure there's no exceptions or anything in the logs. They look empty, but they're not. Let's scroll to the side. Okay, great. So we have the output from Hibernate doing its interactions with the database, but other than that, it looks like there's been no exceptions. So it looks like the first iteration of our create event endpoint is working as expected. So in summary, we experienced an error when attempting to save an event in the database. Start and end are reserved keywords in Postgres. So we updated the event object to no longer use the reserved keywords, and we've now been able to successfully create an event. So let's recall what we've achieved in the create event module. In UI overview, we've seen that the user interface can be used to create an event. A field name description has been added to the ticket type object. In create event design, we implemented the create ticket type request class and the create event request class. And we created the event service interface with the create event method. In user not found exception, we created an event ticket exception parent custom exception. We created the user not found exception to represent the invalid state when a specified user does not exist. In create event implementation, we created the event repository interface. We then created the event service import class. We implemented the create event method. In DTOs and Mappers, we created the create event request DTO class and the create event response DTO class. We created the event mapper interface, and we ensured that the DTOs made use of validation annotations to ensure data consistency. In event controller, we created the event controller class. In global exception handler, we created the error DTO class. We created the global exception handler class. and all errors are now returned in the expected format. And finally, in try it out, we experience an error when attempting to save an event in the database. We established that start and end are reserved keywords in Postgres. So we updated the event object to no longer use the reserved keywords. And we have been able to successfully create an event in our system. In this module, we'll build the functionality that allows an organizer to list their events. The module is structured like this. We'll start by implementing the service layer for event listing. We'll then create the DTOs and mappers for event data. We'll then build the events controller endpoint. And then we'll test the functionality through the user interface. So now for the learning objectives. So by the end of this module, you will be able to implement list events functionality in the service layer. Implement the DTOs and mappers required to list events in the presentation layer. Implement the list events functionality in the events controller. And test that list events works in the user interface. So with that covered, let's get started. In this lesson, we'll implement the list events functionality in the service layer. So here we are back in our IDE. So let's start implementing our list events functionality. So let's go down to the service layer on the left-hand side here, and we're looking for the event service. Let's just expand this. So the event service already has a single method declared on there, and that's this create event method. Now we're going to introduce a new method today, and this one's going to return a page of event. Let's just import page. Now we're using a page rather than a list because it enables us to use pagination. So rather than listing out everything in the database, we can go page by page, which is usually a more refined approach as it's less resource intensive overall. And we're going to call this method list events for organizer. And it's going to take a single argument, which is a UUID, which is going to be the organizer ID. So rather than list all of the events in the database, it's only going to list the events that this particular organizer is associated with. So the events that they are organizing, which is exactly what they want to see in the dashboard. So with that done, let's click this button here to go to the implementation, hover over the red squiggle and go implement methods. We're going to implement list events for organizer, and that gives us our method stub. So with that done, we now need a way of listing events for a particular organizer. So in order to achieve that, let's go to our events repository here. And we're going to have to introduce a custom method. Now, because this is a Spring JPA repository, we can just create a method with a very particular naming convention, and then Spring Data JPA will work out all the queries for us. So let's go about doing that. This method is going to return a page of event. And we're going to call this method find by organizer ID. And we're going to pass in two arguments, a UUID, which represents the organizer ID, and then also the pageable object, which contains all the information which Spring Data JPA can use in order to return the right data for the requested page. We'll just call this one pageable. Now find by organizer ID works because if we go to event here, and if we scroll down, we have this organizer. And inside of the organizer, which is a user, we have ID. So from that, Spring Data JPA is able to work out the query for find by organizer ID. So with that done, we now have a method that we can use to get a page of these events for the organizer. So going back to the event service import here, let's scroll down to our method stub, and then we can call our repository, event repository dot find by organizer ID, passing in our organizer ID. And of course, we'll also need to pass in the pageable. So let's add that to our repository here. Pageable, go down to the implementation, pageable, and then we can pass that in like so. And if we return this, that should be all that we need to do to implement list events for organizer in our service layer. So in summary, we added the list events for organizer method to the event service interface. We added the find by organizer ID method to the event repository interface. And we implemented the list events for organizer method in the event service import class. In this lesson, we'll implement the DTOs and mappers that we'll need in order to implement the list events functionality in the presentation layer. So here we are back in our IDE. So let's get to creating these DTOs to begin with. So the first one that we're going to create is for the event entity. So the counterpart to this class here. So I'm going to put this on the right-hand side, split right. And then in DTOs, we're already following this pattern where we have create event request DTO, create event response DTO. We can see here request response DTO. We should follow the same convention because consistency is key in any code base. So although the purpose of this particular DTO is to summarize the event so we can list them out on the user interface, we'll call our DTO in this case something like list event response DTO. So let's create a new class here, list event response DTO. Let's go over to the right, so let's drag that to the left, close project on the left there. And now we'll put the @data, all ours constructor, no ours constructor. That handles our boilerplate code. And now we can decide what we want to put into this list event response DTO. Now we want to follow the principle of including the bare minimum information. The less information that we're transferring, the more efficient it will be and less of a chance of any sensitive information leaking out. So what do we want to include? Certainly the ID of the event. The name of the event, yes, we'll have that too. That's useful information. Start and end, yep. I can see all of this information included on the front end in a card when we're listing out all of the events. So ID, name, start and end. The venue detail, yep, we should include that if we can. Sales start, sales end, all useful information. And we'll want to know the status of the event as well. Okay. Organizer. Do we want to include the organizer information in our list event response DTO? I don't think that we do. The user interface isn't going to need this to display information when it's listing out the particular events, at least not at this moment, so we'll not include it. The same for attendees and staff. We don't need to include this information as we're not displaying it anywhere. What about ticket types? So we are displaying ticket type information. Ticket type is a very important concept when it comes to an event. So we should include this in our DTO. Ticket type, so we have a list of ticket types on the entity side. So we should create a DTO counterpart for this ticket type, following the same naming convention that we've used on the left here. Here's what we'll do. Let's open up a project. Let's go to DTOs, new Java class, and we'll create a list event ticket type response DTO. A long class name, but consistent with what we have so far. We've prefixed list event because that's the particular action, if you will, that this belongs to. Ticket type is the particular entity that we're dealing with. And response DTO tells us this is used on the response path, and DTO used via the presentation layer. So let's create this class, drag it over to the left once more, close project, and let's add the data, all ours constructor, and no ours constructor. So what do we want to include in here? Well, let's take a look at ticket type. We should always include the ID. That's crucial information. In the case of the ticket type, so is the name, so is the price, and I would say so is the description. I can see all of this being used on the user interface when we list out our events. Total available, yes, we should also include that, I think. That's useful. Should we include the event? No, because we're already nesting this ticket type in a list event response DTO, so it doesn't make sense to include the bidirectional relationship to event. What about tickets? Do we need to include tickets? No, I don't think that we do. When we're listing out all of the events, we just want to know about the event and at a stretch the ticket types. We don't want to know about the tickets then associated with the ticket types. There's different parts of the user interface for that. What about the created at and updated at date times? Now typically I would include these because it's useful metadata. But following the principle of only returning the bare minimum information, I think we should exclude them for the time being because the user interface is not using them anywhere. We can always add them at a later date. So this is our list event ticket type response DTO. Let's now use it inside of our list response DTO. So we're going to say private list, let's import list, of our list event ticket type response DTO, and let's initialize this to be a new array list. There we go. And that helps with null safety. Let's just pull that across. Oh, we've missed the name, of course. So what we named it on the event side, purely called it ticket type. So we'll need to call it the same thing over here in order for MapStruct to work things out. Then we have the array list. Okay, I suppose. There we go. Wonderful. So we now have the ticket types included. And again, we have created at and updated at. Currently, the user interface doesn't need them, so I'm going to choose to exclude them for the time being. However, again, we can always add them later on. So we now have our list event response DTO. How do we use it? Well, I think we should go over to our mapper now. Let's close these on the right. Let's go over to our event mapper, which is in the mappers package down here. Okay, and let's close project. So we've introduced 2 new DTOs here. The first one, we'll open up project again and scroll up, is the list event ticket type response DTO. So what I'm going to do is I'm just going to, if we go to rename, just to allow me to copy that easily, we're going to paste that in to our mapper here, and we're going to say to DTO, passing in the ticket type entity, and we'll call that one ticket type, like so. So MapStruct will create the mapper method for this particular transformation, which is a nested transformation, which we can then use inside of list event response DTO. We'll call this to DTO again, passing in the event, which we'll call event. Okay, so we already have one called to DTO, so we're going to have to change our convention a little bit. We'll just have to say to list event response DTO instead. So with that done, we now have both the DTOs that we're going to be returning. They're the response DTOs for our list event endpoint. And we also have the mappers to take the entities and convert them to these DTOs. So in summary, we created the list event response DTO, and we created the list event ticket type response DTO, and we updated the event mapper to map to these DTO classes. In this lesson, we'll implement the list events functionality in the events controller. So here we are back in our IDE. So let's open up the event controller here and let's expand this. So we already have our create event endpoint. Let's add a new one. This is going to be using the get mapping annotation because we'll be using the HTTP get verb for this endpoint. Public method, returning a response entity, if only for consistency with what we already have, page of our DTO, which in this case is our list event response DTO. And we're going to call this endpoint list events. Let's open up some braces there. Okay. Now list events is going to take a couple of arguments. The first one is going to be the @authentication principal annotated JWT argument. And we need this in order to get the organizer ID that we're going to pass to our service layer. Now I should be very clear here. At the moment, we have implemented authentication, but we haven't implemented authorization. So we're checking that the user is who they say they are. That's the authentication. Otherwise, we'd be returning HTTP 401s and 403s, which is what you get if you don't provide a valid JWT. What we're not currently doing is checking what the user is allowed access to. Yes, we may be filtering the events to only the events that that particular user is the organizer for, but what we're not doing is checking that the user is an organizer user. But for the moment, this should be fine. Once we start introducing the different types of user, the staff user and the attendee user, then we can start thinking about authorization proper. For the moment, we'll just return the events associated with this particular user. So we need this JWT. We also will need the pageable object. So if we make sure that we get the one from Spring Framework data domain, and we'll call this one pageable, Spring will be kind enough to inject this information for us. There's very standard query parameters that are used with this pageable object, and Spring will look for those query parameters and package them all up into this pageable object, which we can pass right the way through to our repository. This is one of those rare occasions where it goes across the different layers. So this should be all that we need in order to start our implementation. So let's start by calling the event service. So event service dot list events for organizer. And now we'll need the organizer ID. We're already passing the UUID up here, so I'm going to make the decision to use a private method for this one. Again, we may want to refine this particular approach even further, but for the moment, we're going to create a method that returns a UUID, and we'll say it's called something like pass user ID, and we'll require the JWT object to be passed in, I think, like so. And then the implementation of this private method will be exactly what we've done here. So we will return like so. So we'll get the subject from the JWT and then go UUID from string like so. And we're going to replace the implementation up here, passing in the JWT. That's on our create event endpoint. And then we can also use it down here as well, pass user ID, passing in the JWT, and I will assign that to a user ID variable, just like we've done up here. Now, if and when we choose to refine our approach, we only have to do it in one place. So we have our user ID. Let's pass this into our list events for organizer method, and then we'll pass in our pageable as the second argument. And we'll assign that to, now that we have a page of events, we want a page of list event response DTO. So in order to achieve that, we're going to say events.map. We'll give this one the argument name of event, and then we can call our mapper. So we'll say event mapper dot, and it was to list event response DTO, passing in the event, which will give us the opportunity to refactor that. So it's worth pointing out we're calling map directly on the page object here. We're not doing stream.map. So if we were to, for example, assign this to a variable, we can see that it's a page of list event response DTO, which is exactly what we're looking for. However, I'm going to choose not to do that, but instead go response entity dot OK, passing in our body like so, and then we can return this. But let's put it on some new lines just for readability purposes. There we go. So we're taking the JWT, passing in the user ID, and then we're taking the pageable object and passing both the user ID and the pageable object into our service layer method here, list event for organizer, which returns us a page of event entity. We're then able to map that page of event entities to our DTO, which is up here, the list event response DTO, because of course we're in the presentation layer. We want to control the structure that we respond with, and it's going to be this structure here. And then we simply return that as a response entity OK, which will return a HTTP 200. So with this, we should have our first working implementation of our list events endpoint. So in summary, we've added the list event endpoint to the events controller. In this lesson, we'll test our list events endpoint by using the user interface. So here we are back in our IDE. Now, all that's left for us to do is to go over to Maven here. We're going to run clean and we're going to run compile to make sure that we don't get any issues when it comes to Lombok and MapStruct. Okay, we have some warnings, but it seems to be a build success. What are the warnings about? Our use of builder. Okay, so that's fine because we've chosen not to use builder. We can always remove those annotations later. The build success is what we're looking for. So let's look to run our backend application. Great, everything seems to have started fine. So let's head over to our user interface. So here we are back in our browser on our organizer's landing page. I've already taken the liberty of logging in. So let's head over to the create event page. Okay, so we can see that the user interface has been updated. So rather than going straight to the create event form like we saw previously, we're now directed to the list event screen. So let's open up our networks panel so we can make sure that our backend endpoint is working as we expect it to. Network, clear, refresh. Great. So we have some calls being made here. Let's take a look at them. API v1 events, page of 0 and size of 2. So these are our pagination query parameters. Spring Boot pagination starts at page 0 and then works its way up. Size tells us how many records the caller wants returned in each page. In this case, only 2. And there's a reason for that, and we'll see that in a moment. Let's take a look at our response here. So we can see here we have a page. So our actual content itself, our events, is on this content attribute here. So we can see our list of events. Only 2 because we've only requested 2 on this page. In addition to that, we have loads of page metadata. We have some in pageable here. We're on page number 0. Page size is 2. Are we sorting, etc. Total number of pages is 2. Total number of elements is 4. So lots of metadata about our pagination. However, HTTP 200, and we are getting our events returned. So it looks like largely our list events endpoint is working. Let's try it out with some pagination now. If we were to scroll down to the bottom here, we can see some pagination. So page 1 of 2. If we were to click on the next here, we can see that rather than our original records, we have test event 2 here. We have test event 3. And we have some data displayed. So we have the start and end dates and times. We have the sales period, the description, the venue description, so online events, ticket types as well. So it looks like our list events endpoint is working as expected. So in summary, we've tested the list events functionality using the user interface. So let's recall what we've achieved in the list events module. In list events service, We added the list events for organizer method to the event service interface. We added the find by organizer ID method to the event repository interface. And we implemented the list events for organizer method in the event service import class. In DTOs and mappers, we created the list event response DTO and created the list event ticket type response DTO and updated the event mapper to map to these DTO classes. In event controller, we added the list event endpoint to the events controller, and in UI testing, we tested the list events functionality using the user interface. In this module, we'll build an endpoint that allows users to retrieve detailed information about individual events. The module is structured like this. We'll first implement the getEvent service layer. We'll then create the DTOs and Mapper methods. We'll then implement the getEvent endpoint and test the endpoint using the user interface. So now for the learning objectives. So by the end of this module, you will be able to implement the service method that retrieves event details. Implement the DTO classes and Mapper methods needed for the getEvent endpoint. Implement the getEvent endpoint and test that the getEvent endpoint works in the user interface. So with that covered, let's get started. In this lesson, we'll implement the getEvent service layer. So here we are back in our IDE. So we need to implement the functionality to retrieve a single event from the database, returning all its details. And that's what will be used to populate the edit event form on the front end. So in order to achieve this, let's start with our repositories. And let's start with event repository here and let's expand this. So the event repository already has one custom method, and this returns a page of events based on the organizer ID. A page being a collection of events, but we want a single event. So I'm going to add an additional method here. And this is going to return an optional of event. Let's import optional, and we'll call this one find by ID and organizer ID, UUID, and we'll specify the argument name of ID. And for the second one, a UUID, and we'll call this one organizer ID like so. You might be wondering why we've put ID first and organizer ID second. Well, that's because there's already a find by ID method in Spring Data JPA. So we're simply extending that to also filter by organizer ID. And in that way, it's a little bit more consistent. So this method should return an event if both the event matching the ID and the organizer ID exists, otherwise an optional empty. So now that we have this, we can move on to our service layer. So let's open this, go to services, and then go to the event service, expanding this. So we have a create event method, list events for organizer method. Let's add an additional one here. Optional event is the return type. And we're going to call this one get event for organizer, rather than just get event, because it does also filter by the organizer ID. Now for consistency within the scope of this service, we're going to specify the UUID organizer ID first, spelling organizer correctly. There we go. And then we're going to specify the UUID, which is the ID of the event, which is the opposite way that we've done things in the repository. But I feel like having organizer ID first is something that we're doing within the scope of this service. So let's carry that on. So we have this get event for organizer method now. So if we go to the implementation, hover over the red squiggle, go implement methods. Okay. We now have this get event for organizer method stub ready to implement. And to implement this, we're simply going to return event repository dot find by ID and organizer ID, passing in ID and organizer ID, making sure we put them in the right order, because the order is opposite from the order that we've passed them in as arguments up here. And with that, we've implemented our get event for organizer service layer. So in summary, we've added the repository method to find events by ID and organizer ID. We created a service interface method for retrieving events, and we implemented the service method to fetch event details using the repository. In this lesson, we'll implement the DTOs and the Mapper methods that we need in order to implement the get event presentation layer. So here we are back in our IDE. So let's head over to domain here, open up DTOs, and this is where we're going to place our new DTOs. So let's create a new Java class, and we'll call this one get event details response DTO, following the convention of request and response and DTO that we've got so far in our DTOs package. And to the top of this class, we'll go data, all R's constructor, no R's constructor. And let's expand this. And to make things easy, let's also bring up the event entity, placing that on the right-hand side by splitting right. And then we can have the get event details response DTO on the left. So what information do we want to include in the get a single event? So get the event details response. So it's going to be pretty much everything. The ID, yes. We want the name, the start and the end, because we need all of this information in order to populate the event edit form. The venue as well, the sales start, the sales end. We'll also have the status. We won't return the organizer because it's simply not needed. We don't need that information in order to edit the event, nor do we need the attendees or the staff. We do need ticket types, however. So we'll create a new DTO, as is the convention so far, Java class, and we'll call this one get event ticket types response DTO. At data, all R's constructor, no R's constructor annotations on the top. We'll go to the ticket type entity on the right hand side, and then we can start populating the DTO. So we'll definitely want the ID of the ticket type. We'll definitely want the name and the price. Also want the description, the total available. We don't need to provide the event information, so we'll skip that. We're not going to return the tickets because this particular call is only interested in editing the ticket type. We will return the created at and the updated at. We do really have the bare minimum information in the ticket type at the moment. So really, created at and updated at is at the moment the only additional information that we're returning on the details endpoint that we're not currently returning on the summary endpoint or the list endpoint. But that should be useful to the caller. So now we can use this over in our get event details response DTO. And if we close ticket type on the right, we can now declare a private list of, if we import list, get event ticket types response DTO, call it ticket types, so MapStruct knows how to map it, and we'll initialize this to a new array list for null safety. And we'll also include the created at and the updated at in this particular DTO. Because again, that might be useful to the caller. The expectation is that this particular DTO will include all of the relevant details. And although at the moment this really is only created at and updated at, these are the only two additional properties that are on the details as opposed to the summary, they are decoupled now. So you can add more to the details as and when it comes up when you build out the application. And that really is one of the values of this pattern. So we now have our get event details response DTO. What do we do with it? Well, we need to create the mappers, or the mapper method, should I say. So let's open up the mappers package, open up event mapper. Let's expand this, and then let's just close everything else so it's nice and clear. So we've introduced two new DTOs here. In fact, we just scroll up so they're on the left-hand side. Get event details response DTO and get event ticket types response DTO. So we need to add those to our mapper. So let's start with the get event details, or maybe the get event ticket types response DTO, which should probably, strictly speaking, be called the get event details ticket types response DTO. And these class names are getting a bit long. So we have that there. And then we'll say to name of class, passing in the ticket type entity, which we'll call ticket type. So that's done. Let's now do the get event details response DTO. And we'll call this method to get event details response DTO, passing in the event entity, which we'll call event. There we go. So we've introduced two new DTOs in order to control what we return from our get event endpoint. And we've also introduced two mapper functions to take the entities and convert them into those DTOs. So in summary, we created the get event details response DTO to represent complete event information. And we created the get event details ticket type response DTO to represent the ticket type details. And we added mapper methods to convert the entities to these DTOs. In this lesson, we'll implement the controller endpoint that we can use to get an event by its ID. So here we are back in our IDE. Let's open up the event controller here, and let's expand this. So we already have ourselves here a create event endpoint, which we'll minimize. We have a list events endpoint, which we'll also minimize. And we're going to introduce a new endpoint now. So this one's also going to be a get mapping. However, where this one differs is we'll specify a path // and then we're going to use some braces here, and we'll call this one event ID. So the path, we're going to specify the ID of the event that we want. And using this notation, we can then access it within our controller endpoint. So public, returning a response entity of our DTO. So that's going to be our get event details response DTO. And we'll call this one get event. Now we're going to need the JWT because we'll need to get that organizer ID. And we're also going to want to access the event ID in the path. So for that, we'll use path variable. We don't need to specify any arguments because we're going to call the name of this particular variable the same as we specified in the string. So event ID matches event ID. Otherwise, we'd have to specify an argument to this annotation. And thinking about it, event ID, we should make this a UUID because that's the format that it will represent. So with that done, we can get to implementing this particular endpoint. So first we'll need to pass the user ID. So we'll use our private method for this one, pass user ID, passing in the JWT, and we'll assign that to the argument user ID. We'll now call the event service, calling our new endpoint get event for organizer, passing in the organizer ID, which is our user ID, and we'll also need to pass in the event ID that we've taken from the path. And this is going to return to us an optional event. So let's call map. And in fact, let's put this on a new line because we can then call event mapper to get event details response DTO. And then call map again. In the case that we do have a value, let's call response entity : OK. Otherwise, or else, we're going to return response entity dot not found, and then we'll need to call build on that, like so. And if we return this now, we've implemented our endpoint. So we get the user's ID. We then call our service layer to get the event for the organizer. We convert it to the DTO that we created using our event mapper. In the case that we have a value, then we return HTTP 200. In the case that we don't have a value, we return HTTP 404. And with that, we should have a working endpoint. In summary, we implemented a get endpoint to retrieve event details by ID. And we use optional to handle cases where events aren't found. In this lesson, we'll use the user interface in order to test the get event endpoint. So here we are back in our IDE. So let's clean and compile this project to make sure that we don't have any issues with Lombok or MapStruct. Very good, build success. We do have those warnings about the use of builder. However, as we're not using builder, I think we can safely ignore those. We can always remove those a bit later. So let's run our application. Okay, that's the application started up fine. So let's head over to our user interface. So here we are on the organizer's landing page. So I've already taken the liberty of logging in. So let's head over to the create an event page. Okay, so we have a couple of events here. Test event 1, which is specified without a start and end and without a cell start and end. And then we have test event 2, which does have a start and end date, cells period. Okay, very good. And we can see we have this edit button now available. So if we were to click the edit button here, okay, we see some event data. Let's just open up the networks panel and let's refresh the page here. Okay, very good. So we have some requests being made. Let's take a look at so a get request API, v1 events, and then the ID of the event, which is a UID. And we have a HTTP 200 OK. If we look at the response here, we can see our data. So ID in there, name, start and end, venue, published, status, ticket types, and then we have the created at and updated at. So it looks like our get event endpoint is working as expected. Let's just see that it's displaying the data in the user interface. Let's close the networks panel. So we have edit event here, test event 2, the dates, the venue details, the sales dates, and then we have our ticket types here, which is general admission, 100 tickets available. And then we have published. So it looks like our get event endpoint is working as expected. So in summary, we tested the get event endpoint works in the user interface. So let's recall what we've achieved in the get event endpoint module. In implement service method, we added the repository method to find events by ID and organizer ID. We created the service interface method for retrieving events. And we implemented the service method to fetch event details using the repository. In create DTO classes, we created the get event details response DTO to represent complete event information. We created the get event details ticket type response DTO to represent the ticket type details. And we added mapper methods to convert entities to DTOs. In implement controller endpoint, we implemented a get endpoint to retrieve event details by ID. We used optional to handle cases where events aren't found. In UI testing, we tested the get event endpoint's work in the user interface. In this module, we'll implement the update event endpoint. The module is structured like this. We'll first design the update event feature and create the necessary interfaces. We'll then create the custom exceptions that we'll need for error handling. We'll implement the service layer functionality, and then the DTOs and mappers, and then implement the controller endpoint, and then test the feature through the user interface. And now for the learning objectives. So by the end of this module, you will be able to create the objects and interface declaration required to implement the update event endpoint, implement the exceptions we will need to implement the update event functionality, implement the update event functionality in the service layer, implement the DTOs and mappers required to implement the update event endpoint in the presentation layer, and implement the update event functionality in the events controller, and test that the update event endpoint works in the user interface. So with that covered, let's get started. In this lesson, we're going to create the objects and the interface declaration required to implement the update event endpoint. So back in our IDE, so let's design our update event functionality. So first let's start with the objects that we're going to use. So if we go to our domain here, we already have this convention where we have separate objects per functionality. So we have this create event request and this create ticket type request. Now we're implementing a full update endpoint. Full update endpoints replace everything that's in the database with what's provided in the request. Not updating things, of course, like ID or the created at and updated at, that's all dealt with separately. So what this means in practice then is that the update event request, if we copy and paste this, update event request. So the update event request, we can just copy the create event request and start there. I'm going to do the same thing for the create ticket type request, copying that and calling the new class an update ticket type request. There we go. So if we go over to the update event request, and then we're going to replace the type of the ticket types list to be an update ticket type request. There we go. So we now have an exact copy of our create requests, but renamed for update. But there is a very key difference with our update requests. Let's just minimize this on the left so we have more room. The key difference is the ID. So if we start off over in the update ticket type request, I'm going to declare a private UUID, and I'm going to call that ID, like so. In the case of the update ticket type request, the ID can actually be null, and where it is, we'll create a new one. But where the ID is provided, we're going to update that existing ticket type. So over on the update event request, I'm also going to specify an ID, private UUID ID, and we always expect this to be provided because you can only update an event that already exists. And we have all of the fields that we can then update. So let's now head over to the service package here, and we're going to go to event service, and let's expand this. We're going to introduce a new function. This one is going to return an event, and we'll call this one update event for organizer, passing in the UUID of the organizer, which we'll call organizer ID, the UUID ID, which is going to be the ID of the event that we're looking to update, and then we'll pass in the update event request, which we'll call events, to be consistent with what we're doing over on create. Now we're calling this update event for organizer because we're only going to support the caller being able to update events for which this organizer user is the organizer of the event. So if the user as identified by organizer ID is not associated with the event, then we're not going to allow the caller of this method to update the event. But with that done, we now have the objects that we're going to use to model the request, and we have our method declared update event for organizer inside of the event service. In summary, we added the update ticket type request class, we added the update event for organizer method to the event service interface. In this lesson, we're going to create the exceptions that we'll need when we implement the update event functionality. So the update event for organizer method is probably going to be the most complex one that we've implemented so far, and there's quite a lot of things that could go wrong. So we're going to create the exceptions now in order to handle those situations. So if we open up the project on the left here and scroll up to exceptions, we already have a couple of custom exceptions. Well, we have one base exception and then we have the user not found exception. So let's start here. I'm going to copy the user not found exception and paste that. And I'm going to rename it to be event not found exception. You see, when we pass in an ID of an event for a particular organizer, that event ID may be invalid, the event may not exist. So that's an error state that we need to represent, and we'll do so with this exception. But we'll leave the implementation exactly the same because that's perfect for what we need it for. So an event cannot exist. That's one of the first ways this implementation can go wrong. Another one is when we're passing in an ID of a ticket type that doesn't exist. So we'll need an equivalent exception for that, which we'll call ticket type not found exception. And we'll create a third exception as well. Again, I'll just copy and paste this. And this one's going to represent when we hit a more generic invalid state when we're trying to update an event. So I'm going to call this one event update exception. There we go. So now head over to the global exception handler in our controllers here. So let's implement handling these exceptions early on. So we already have our handle user not found exception. Let's copy that block there. We'll paste it in. And we're going to start by handling we'll go in the same order. So this is going to be the event not found exception. Let's just minimize the project on the left so we can see. And we'll call this one handle event not found exception, passing in the event not found exception. We'll log the error out, caught an event not found exception. And the error message for this one we'll say is event not found, and we'll make this a bad request. So that's the first one, the first exception handled. We'll copy that block again. And the next one we'll handle is the ticket type. And we'll pass in the ticket type not found exception, ticket type not found exception, handle ticket type not found exception, the log message caught a ticket type not found exception, and the error message is ticket type not found. Again, HTTP 400 bad request. So next, let's handle the event update exception. Now, I'm going to make the decision that we're only really going to use this exception when it's something that the user has done wrong. So we'll represent this as a HTTP 400. So let's minimize the project on the left. So the exception handler is going to handle the event update exception. We'll call the method handle event update exception, passing in the correct type for the argument. We'll update the log message and we'll set the error to be unable to update event. And we may have to revisit this because it's quite generic, but we'll certainly need to represent the exception state that can happen when we come to update an event. And with that, I think we have all the exceptions that we're going to need in order to implement our update event functionality. In summary, we added the event not found exception, we added the event update exception, and we added the ticket type not found exception. And we updated the global exception handler to handle the new exceptions. In this lesson, we'll implement the update event functionality in our service layer. So back in our IDE, let's head over to the event service here. In fact, let's click this button to go to the implementation, hover over the red squiggle, and we'll go implement methods, and that will give us our update event for organizer method stub. Great, let's minimize project on the left and scroll down because we're now going to implement update event for organizer. So let's get to it. The first thing that we should check is whether or not the event has an ID. So we'll say if event.getID, and we'll say equals null, so null double equals. Then we're going to throw an event update exception, and we'll give this one the message, event ID cannot be null. Of course, we need the new keyword, throw new. Okay, so we now know that the event has an ID. Let's now make sure that it matches this ID argument, because if not, the user is trying to update the ID of the event, which we may want to support later, but at the moment we don't. So we'll say if ID equals event.getID, and we'll put an exclamation mark in the front there to negate it. So if the ID argument does not match the ID on the event, we're going to throw a new event update exception. And the message for this one is going to be provided IDs do not match. Or perhaps a better one would be cannot update the ID of an event. Okay, so we know that event has an ID and we know that it matches this value of the ID argument up here. Let's now go about getting the existing event from the database. So we'll say event repository dot find by ID and organizer ID, passing in the ID of the event and the organizer ID, and this will return an optional. So let's handle the optional by throwing an exception otherwise. So we'll say or else throw, parentheses, arrow, a new event not found exception. And we'll say event with ID, and then we'll do the $s does not exist. And then we'll do a string.format, and we'll do a new line and say string.format, and then we can pass in the ID like so. Okay, so let's assign this to a variable, which we will call existing event. So we now have an existing event. Where do we go from here? Well, I think the simplest thing to do would be to simply start updating the existing event with information from the update event request. So we'll work our way through. In fact, let's get the event and do a split screen so it's obvious what we are updating. So we'll say existing event dot set name, which is the first one up here. Here we are, set name from event get name. Existing event dot set start, event get start. Existing event dot set end, event dot get end. Existing event dot set venue, event dot get venue. Existing event dot set sales start, event dot get sales start. Existing event dot set sales end, event dot get sales end. And that brings us down to here. So it's status next, existing event dot set status equals event dot get status. And then we have the organizer, which we're not going to update. We're not going to update the attendees or the staff. We are going to need to update the ticket types now. So this is where it starts to get a bit complex. So let's close event on the right here, and we'll now get to implementing the ticket type update. So first, let's look to get all of the IDs provided in the event argument. So we'll say event.getTicketTypes. We'll say stream.map, and we'll say update ticket type request, :get ID, and that will give us a stream of the IDs. Let's filter out where we have some null IDs, because that's totally reasonable to have a null ID in there, because that means we'll need to create a new ticket type. So let's say objects non-null in a filter, and then we'll collect to a set. And that will be our set of IDs, which we're going to call request ticket type IDs. That's a set of all of the IDs of the ticket types that we want to create, excluding any nulls. So let's now remove any ticket types from the existing event where the ID isn't in this list. So by omitting the ticket type from the full update, we want to remove that. So we're going to say existing event dot get ticket types, and we'll say remove if, and we'll call this one existing ticket type. This is a lambda. And we'll say request ticket type IDs contains existing ticket type get ID, and then we'll negate that by putting a exclamation mark at the beginning there. So what we're saying is if the request ticket type IDs, so the set of IDs from the request, does not contain the ID of the ticket type currently on the existing event, then we're to remove it because it's been omitted from the request and therefore should be removed. We do need to make sure that we have orphan removal on the event, however. So we go over to the event here, and we're looking for ticket types, which is in fact right here. I'm going to say orphan removal true. And this is going to make it so that Hibernate handles this situation for us and deletes those ticket types. So back to the implementation. So we now removed all of the ticket types not in the request. Let's now get to updating and creating. So let's create an index of all of the existing ticket types by their ID, and that will make it easier to access them. So we'll say existing event.getTicketTypes, we'll call stream, and we're going to collect, not to set, we're going to call collectors to map, and we'll say ticket type, : get ID. So that will be our key. And then the value is just going to be the ticket type itself. So we can use the function.identity, and then that will just be the value itself. So that will be the ticket type. Now we can assign this to a variable, which we'll call existing ticket types index. So that'll be a map where the ID is the ID of the ticket type and the value is the ticket type. Sometimes called a lookup table. This should allow us easy access to those ticket types. So for clarity, I'm going to use a for loop here, I think. So we'll say for update ticket type request, which we'll call ticket type in the event.getTicketTypes. Let's check whether or not it has an ID. So if null equals ticket type.getID, then this is going to be our create case. Otherwise, we need to, I think we'll do an else if. So else if existing ticket types index dot contains key, and we'll say ticket type dot get ID. This is going to be our update case. Otherwise, we're going to throw an exception. So we throw a new ticket type not found exception, because if we get to this point, it means that we have an ID of a ticket type that doesn't exist. So we'll do a string.format like we've done before and say, put that on a new line actually, ticket type with ID, and then we'll pass in the :s does not exist. And then the second argument will be the ID of the ticket type that doesn't exist, which is the ticket type.getID. There we go. So let's handle the create case first. And the create case is going to be pretty much identical to what we're doing up on the create call. So I'm going to copy this logic here. Potentially we could extract it out into a private method, but I'm going to just copy this for the time being. I'm going to paste it in here. So what we'll do is we'll create a new ticket type. We'll set the name, the price, the description, and total available from the ticket type, which is this argument here in the for loop. And then we're going to say existing event dot get ticket types dot add the ticket type to create. One thing that I am going to do though is say ticket type to create dot set event existing event to make sure that bidirectional relationship is set up correctly. So this should create the new ticket type. And because it has a null ID, Hibernate will generate a new UID. So that's the create case sorted. What about the update case? Well, we need to go to the existing ticket types index, and we're going to get by the ticket type dot get ID, and this will be the existing ticket type, or perhaps better put, a reference to the existing ticket type. So this will allow us to update that object. So we'll say existing ticket type dot set name, which will be ticket type get name, and then we'll do existing ticket type set price, ticket type get price, existing ticket type set description, ticket type get description, and then existing ticket type set total available, ticket type get total available. And it's already associated with the event, so we don't need to do anything there. Okay, so the last thing we should need to do then at the end of this is to say event repository.save, passing in the existing event, and we'll return that from the end of this method, and that should complete our initial implementation. So that's the logic complete, but there is something that this particular method is missing. So under the @override annotation, I'm also going to add the @transactional annotation from Jakarta transaction. We're making multiple calls to the database in this particular method. Here we're calling the event repository find by ID and organizer ID. We scroll down, we're making a second call to save. We want this all to happen in the same transaction so the database doesn't get into an inconsistent state. Further to this, if we scroll up to the create method, which is up here, we're doing find by ID, and then we're also doing a save. So actually, we should have also put @transactional on here. Now, although the method works, In high traffic situations, it's more likely that that inconsistent state could have occurred. But with @transactional, the entire method will now happen within a single transaction. So with that, we've implemented update event for organizer. In summary, we implemented the update event for organizer method in the event service impl class. We updated the event class to handle orphan ticket types. In this lesson, we'll implement the DTOs and mappers that we'll need in order to implement the update event endpoint. So back in our IDE, so we're going to follow the same approach that we have done for the service layer, which is to say that we're going to take the create DTOs and we use them as a basis to implement our update DTOs. So let's start with the create event request DTO, copying that, and we'll call this one the update event request DTO. And then we'll copy the create ticket type request DTO, pasting that to be the update ticket type request DTO. And then the same for the responses. We'll take the create event response DTO, pasting that, renaming it to be the update event response DTO. And then we'll take the create ticket type response DTO, copying that and renaming it to be the update ticket type response DTO. Now you might be thinking to yourself, this seems like a lot of work, and perhaps it is, but we've started with the convention of using dedicated DTOs per endpoint. And although these DTOs may be similar to begin with, they're now decoupled, so they can change over time as and when requirements dictate. It's not to say that you always need to do it this way, but only that we're being consistent in doing it this way for this project. So we can't just leave these update DTOs as they are. We'll need to tweak them for what we need them for, which is updating events. So let's start with the request. So if we go over to the update ticket type request DTO, we're going to put on there the private UUID of the ID, because we can provide an ID for a ticket type. And if we do, we want to update that ticket type. And we've got the name, we've got the price, description, and total available. So that's perfect, exactly what we need. So let's now go over to the update event request DTO. And the first thing that I'm going to do is scroll down to the ticket types list and update the type to be the update ticket type request DTO. I'm going to scroll up to the top and I'm going to introduce an ID parameter on this one too, private UUID, and we'll call this one ID. And I'm going to borrow this not null annotation and place it on the ID here to say that event ID must be provided. We must have an ID if we're attempting to update an event. Otherwise, we have the name, the start, the end, which are optional, venue, cell start, cells end, status, ticket types. So that's looking good. Now what about the response path? Let's go to the update ticket type response DTO. That's the ID, name, price, description, total available, created that, updated that. So everything that we need, we can leave this one as is. Let's copy this though, this class name, because we'll need to update it in the update event response DTO. So ticket types will be returning this type here, but otherwise this is exactly what we need. So with that done, let's now handle the mappers. So we'll need to bring up the event mapper here. We scroll down. So let's deal with the request path first, whereby we're going to receive an update event request DTO, which will have a nested update ticket type request DTO. So this one here. So we'll handle this one first. So this is going to return an update ticket type request. And we'll say from DTO is the name of this one, passing in the update ticket type request DTO. So that will handle the nested conversion from the update ticket type request DTO to the update ticket type request. Now let's handle the update event request DTO. So this one's going to return an update event request. And we'll say from DTO, and then we're going to pass in an update event request DTO, which we'll call DTO. So that's the request path sorted. We now need to do the response path. So this is going to return an update ticket type response DTO. And we'll say to DTO, we may get a name conflict. And we're going to pass in a ticket type. Yep, we do get a name conflict. So we'll say to update ticket type response DTO. And then we'll need to do the event. So this one's going to return an update event response DTO. We'll say to DTO. Again, we may get a conflict. And we're going to pass an event to this one, like so. So we'll update the name so we don't get a conflict any longer. Wonderful. So this is now the DTOs and mappers that we need for both the request and the response, with the DTOs updated in order to support updating of an event. In summary, we created the DTOs required for event updating, and we updated the event mapper to handle the new event update classes. In this lesson, we'll implement the update event endpoint on the event controller. So back in our IDE, let's head over to the event controller here. We'll expand this, and we can get to implementing our update event endpoint. So we already have an endpoint here for get events. We'll minimize that. List events, we'll minimize that. And then we have create event. Now, as these endpoints are so similar, I'm going to copy create event, renaming it to be update event. And now we can get to updating this particular method to support event update. So we're not going to be using post for this. This is a full update, so we'll be using a put mapping, specifying in the path the ID of the event that we want to update. So event ID, like so. We're not going to be returning a create event response DTO, but instead an update event response DTO, which we can import. We are going to need the JWT. We are also going to need the path parameter. So path variable, a string, or in fact, no, it's not a string, but a UUID, which we'll call event ID to match what we've declared inside of the path there. So we now have access to the event ID that was passed in the URL. For the request body, we're not going to have a create event request DTO, but in fact an update event request DTO, which we'll rename over here. And we are going to keep that valid annotation in order to activate our validation annotations there. So event mapper from DTO, let's delete that and assign it to a variable of type update event request. We'll now call the update event for organizer method on the service layer, passing in the ID of the user, the event ID from the URL, and then our update event request object from the request body. And this should give us an updated event, or throw an exception, which will be handled by the global exception handler. So now that we have our updated event, let's now turn it into a DTO that we can use in the response. So we'll say event mapper dot to update event response DTO, passing in the updated event. And this will be our update event response DTO, which we can now pass in the response entity. But we're going to use HTTP 200 OK. So rather than construct a new response entity like that, we'll say response entity.OK, and we will return that. So we're using HTTP put, specifying the event ID in the URL. We're returning an update event response DTO. The endpoint's called update event, and we need the JWT. We need the event ID from the URL path. And we need a request body, which is the update event request DTO. We convert our DTOs into the objects that we use in our service layer. We pass the user's ID. We call the update event for organizer method in our service layer, passing in the relevant information. And then with the returned updated event, we convert it into a DTO and return it with a HTTP 200. And with that, we have our initial implementation of our update event endpoint. In summary, we implemented the update event endpoint on the event controller. In this lesson, we're going to test our update event functionality by using the user interface. So we're back in our IDE because we're going to run clean and compile to make sure that we don't have any issues with MapStruct or Lombok. Perfect, and we have a build success. So with that done, let's now run our application. Perfect, so that's the application started up. So let's open up the user interface in our browser. So here we are on the organizer's landing page. So let's click on create an event here. We need to log in, of course, organizer and password. Let's spell that correctly this time. Okay, and we've been redirected to the list events page. So we have test event 1 there. That's missing some dates. That's a bit of a test record, a bit incomplete, but we have a much better test record here, test event 2. This has a start date, a sales period, venue information, a ticket type. So if we click on the edit button in the bottom right here, we now see the edit event page. And we can see some information about the existing event, the ID here, when it was created, when it was updated. And we can see all the event's information. The user interface is using the get event endpoint in order to populate this information. So test event 2, May 12th, start at 2, ends May 13th at 3, a very big venue. We've got an event sales start and end, starting on the 10th of May at 3 and ending on the 11th of May at 5. And then we have a general admission ticket, 100 available, $99, and we're in publish status. So let's change everything. We'll go with test event 2 updated. The event will start, I think, a day later on the 13th at 15, which is 3 o'clock. And then it will end on the 14th at 16, so 4 o'clock. A very big venue. We'll just say updated after that. Again, we'll just go a day later on this one. So the 11th at 16, which is 4 o'clock, to the 12th, let's say, 18, which is 6 o'clock. And then we have this general admission ticket. Let's update let's just say updated in the title there. Let's make the price 88, and let's make it so there is 111 available. Standard entry updated. Save this. Let's add a new ticket type, and we'll say updated ticket type 2 perhaps, and we'll go with 333-444 and the description 555. Why not? And we click on save here. We now have 2 ticket types, and we'll keep it in published status. Now let's open up our network panel because I'd like to take a look at the JSON that we send. So with that done, let's click on update. Okay, we've been redirected back to the list events page. Let's take a look at the request that was sent. We have a HTTP put to API v1 events and then the ID of the event here. The payload, we can see the ID in the payload, the name including the word updated, the start and the end dates, the sales start and end dates, still published. The venue has the word updated in it also. And if we go and expand the ticket types here, we can see that we have the first one, general admission updated, standard entry updated, 88 and 111. And if we scroll down here, here's our updated ticket type 2. And we went with 333-444 and 555. So with that done, it looks like it's been a success. But let's doubly check this by going back to the edit page now. And this will trigger a fresh GET call. So here's our HTTP GET call here. So let's compare this to what we had before. We can see the word updated in the event name. We can see the updated start and end dates. The word updated in the venue details. The updated sales start and end dates. Updated ticket types. Well, there's our general admission with the word updated in it. 111, $88. And then we've got our updated ticket type 2, 333-444, 555. And still in publish state. So it looks like our update event endpoint is working as expected. In summary, we tested the event update functionality in the user interface. So let's recall what we've achieved in the update event module. In update event design, we added the update ticket type request class. We added the update event for organizer method to the event service interface. In exceptions, we added the event not found exception. We added the event update exception. And we added the ticket type not found exception. And we updated the global exception handler to handle the new exceptions. In update event service, we implemented the update event for organizer method in the event service import class. And we updated the event class to handle the orphan ticket types. In DTOs and mappers, we created the DTOs required for event updating. We updated the event mapper to handle the new event update classes. In event controller, we implemented the update event endpoint on the event controller. In UI testing, we tested the event update functionality in the user interface. In this module, we'll implement the delete event endpoint. The module is structured like this. We'll start by implementing the delete event service layer. We'll then implement the delete event controller endpoint before testing the delete functionality in the user interface. So now for the learning objectives. So by the end of this module, you'll be able to implement the delete event service layer, implement the delete event endpoint in the presentation layer, and test the delete endpoint in the user interface. So with this covered, let's get started. In this lesson, we'll implement the delete event functionality in our service layer. So back in our IDE, let's head over to the event service here, and we're going to add a new method. Let's minimize that so we can see. This one is going to return void, nothing at all. And we'll call this one delete event for organizer, passing in the UUID representing the organizer ID and also the ID of the event. So we'll copy that and paste that in there. So the implementation of this method is only going to delete the event if the organizer has access to it. So that's to say, if the ID here represents the user that organized the event, only then does this implementation allow for the event's deletion. So let's head to the implementing class here, hover over the red squiggle, implement methods, okay. And we now have our method stub ready to implement. We're going to be making a few calls to the database in this one. So let's put @transactional on the top here so we don't forget. So let's start by calling the event repository and actually, no, let's not call the event repository because if we scroll up here, we should already have a method, which if we minimize the update, here we are. We have this get event for organizer method, which will, yes, call the repository, but let's use this as a layer of abstraction. So we'll call get event for organizer, passing in the organizer ID and also the ID of the event that we want to delete. And we'll call on this, if present, we're going to call event repository delete. I think it's just delete. Yes, it is, because we are returning an event from here and we don't need to return anything. So this is the whole implementation of this method. Now note that this method is not going to throw an exception if, for example, the organizer doesn't have access to the event. And perhaps that's something we may want to add in future. For the minute, it's a very simple implementation, which is simply going to return void. And if the event exists and the user has access to it, it will delete it from the database. In summary, we added the delete event for organizer method to the service layer. In this lesson, we'll implement the delete event endpoint on our controller. So we've just implemented delete events for organizer. So let's go over to our event controller and look to use it. So if we scroll down to the bottom here, I'm going to add a new method here. This one is going to use a delete mapping and the path is going to be / and embraces event ID. This one's going to return a response entity of type void and we'll call this one delete event. We are going to need the authentication principal and the path variable. So I'm going to copy those from our get event function. There we go. So we don't need to do any mapping in this one. We can simply call the event service dot delete event for organizer. We will need the organizer ID. So I am going to use the call to our private method here. So we'll pass in the user ID and then the event ID, and then we'll return a response entity dot no content dot build. And with that, we have an initial implementation of our delete event endpoint. So in summary, we implemented the delete event endpoint. In this lesson, we're going to test our delete event endpoint by using the user interface. So here we are in our IDE. We're going to start here by running clean and compile to make sure we don't have any issues with MapStruct or Lombok. Very good, we have a build success. So let's now run our application. Very good, so that's our application started up fine. So let's head over to our browser. So here we are in our browser on the list events page. So we have some events here. We've got some test data on a second page, some more test data. So let's go about deleting test event 5 as our test, I think. So let's open up our network panel so we can see what's going on. And down here on the bottom right of the card, we have this delete button, which is new. If we click on it, we get this prompt. Are you absolutely sure you want to delete test event 5? If I'm not sure, I can click on cancel and nothing happens. But if I am sure, I click on continue. And if we look here, we get a HTTP 204 back from this delete call to API v1 events and then the ID of the event here. Now, the page has refreshed. We're on page 2 and there's currently no records on there because we have test event 3, test event 4. So it looks like test event 5 has been deleted successfully and our delete event endpoint is working as expected. So in summary, we tested the delete event functionality works in the front end. So let's recall what we've achieved in the delete event module. In delete event service, we added the delete event for organizer method to the service layer. In delete event endpoint, we implemented the delete event endpoint. And in UI testing, we tested the delete event functionality works in the front end. In this module, we'll implement the list published events endpoint. We'll use this endpoint to populate the attendee landing page. The module is structured as follows. We'll first implement the list publish events service layer, then the DTOs and mappers. Then we'll implement the REST API endpoint, and then we'll test the endpoint using the user interface. So now for the learning objectives. So by the end of this module, you will be able to Implement the list publish event service layer. Implement the DTOs and mappers required for the list publish events endpoint. Implement the list publish event endpoint in the presentation layer. And test the list publish event endpoint in the user interface. So with this covered, let's get started. In this lesson, we'll implement the list publish events service layer. So here we are back in our IDE. Now we're going to be returning published events. And as we're still dealing with events here, it makes sense for us to update the event service. So let's go to the event service here. And we're going to add a new method to this one. And this is going to return a page of event. And we'll call this one list published events. It's going to take a pageable, which we'll call pageable. Very good. Now, if we go down to the implementation, hover over here, go implement methods. Okay. We now have this method stub ready to implement. Now we're going to need some sort of way to get published events from the database. So that to me sounds like a custom method on our event repository. So if we go to the event repository, we're going to add a new method here, and this is going to return a page of event. And we'll call this one find by status, where the first argument is going to be the event status enum, which we'll call status. So that's the status to filter by or to search by. And then we have the pageable object, pageable, like so. So now that we have find by status, we're going to take this, go to our implementation, scroll down to the bottom here, and then we can call event repository dot find by status. The status we're going to use in this case is going to be published, and we can pass in the pageable object. And if we return, this will return a page of all published events in our application. In summary, we added the find by status method to the event repository interface. We added the list published events method to the event service interface. And we implemented the list published events method in the event service import class. In this lesson, we'll implement the DTOs and mappers that we'll need to implement the list published events endpoint. So let's start with the DTO. So if we go to our domain here, go to the DTOs package, and we're going to follow the naming convention. And this is going to be the response DTO from the list published events endpoint. So we'll say new Java class, list published event response DTO. There we go. And we'll say data, all R's constructor, no R's constructor. So here's what we're going to do. Let's open up the list event response DTO and let's split this on the right. And then we can close project and we can open up our new list published events response DTO. The list published event response DTO is going to be a subset of the list event response DTO. So what that means in practice is that this new DTO is going to have the ID, the name, the start, end, and the venue, but that's it. So if we copy that, paste that across, this is all we need to include in this particular response. And you might be asking why that is. Well, this is all the information that we need in order to display the cards on the attendee landing page. We don't need to include any more information at this point, so that's what we'll include. So let's copy this name here. And if we go to our project, go down to the mappers here, open up event mapper, let's close what we don't need. And we're going to add a new method to this. It's going to return our list published event response DTO. We'll call it to list published event response DTO, passing in the event. And that's all we need to do for mapping. Because we've used all of the same instance variable names, MapStruct can work everything else out. So with that, we've created our DTO and we've created a mapper that will allow us to convert an event into the DTO. In summary, we created the list published event response DTO class, and we added the toListPublished event response DTO method to the event mapper interface. In this lesson, we'll implement the list published event endpoint. So here we are back in our IDE. Now, although we are dealing with events in our service layer, I'm going to suggest that at the presentation layer, we should treat the published event as its own thing. So with that in mind, I'm going to create a new controller, and I'm going to call this one published event controller. And if we minimize that, now to the top of this class, we're going to put the @REST controller annotation, marking this as a REST controller. And then for the request mapping, we're going to specify the path of /API /v1 published -events. So now for the list published events method, we'll do a get mapping, public, returning a response entity, which is going to include a page of the published event list of Here it is, list published event response DTO. And we'll call this one list published events. And it's going to take a pageable as an argument there. We'll call that one pageable. And now we can implement this method. So we're going to need the event service in this one. So let's do required args constructor, which will allow us to create a constructor easily from a private final event service, which we'll call event service. And of course, we'll also need the event mapper. We'll say event mapper, calling that one event mapper. Now, let's say event service dot list published events, passing in our pageable object. We'll now need to map this, and we'll call our event mapper to list published event response DTO. Let's put that on a new line. And we're going to wrap this in a response.ok like so. And that will return a HTTP 200 where it's a paginated list of our published events. But that's not all, because we said this was going to be a public endpoint. And at the moment, we're in that catch-all configuration in Spring Security, which will require us to provide an access token in order to hit this endpoint. So let's change that. So if we go over to the config directory here, security config, and then we'll close project, and we're looking for this block here. So we currently have a catch-all rule in there. In fact, if we just do some new lines, we're going to move this comment down, because technically speaking, that's the catch-all rule. And above that, we're going to specify our new endpoint. So we'll say request matches. It's going to be a HTTP GET method. And we're going to be very specific. So we're going to say to /API v1 / published events. And we're going to say permit all. So all GET calls to API v1 published events are going to be allowed through, but everything else is still going to require authentication, essentially making this endpoint public. And with that, we should have our new endpoint ready to use. In summary, we created the published event controller class. We implemented the list published events endpoint, and we made the list published events endpoint public. Let's now test our new endpoint by using the user interface. So we'll start off back in our IDE. We're going to call clean and compile. Let's run this. Build success, so everything's in order. So let's now run our application. Great, that's the application started up fine. So let's head over to the user interface in our browser. All right, so we are on localhost 5173 /. So this is our attendee landing page. So it's changed ever so slightly. It's not completely refined and ready for production, but what it does show is that we have this hero image up here, the ability to log in. We're currently not logged in, and we can see test event 3 and test event 4, which if we do log in with our organizer user, we can see on the organizers list event page, test event 3 and test event 4. But if we log out here, we can see that we're able to get these without being logged in. So if we go to our networks panel, let's filter by all calls to API, refresh the page. There we go. We can see that we're getting HTTP 200 back from our new endpoint, API v1 published events. And we want the first event and we want the first 4. In this case, we only have 2, so only 2 cards are displayed. Now you might be wondering about the images. Well, the images are actually random. We haven't implemented the infrastructure to upload and manage images. But to kind of complete the look, make it look a bit better, we have these random images in play. But everything else is from our published event. The name, we have the venue details and the date as well. So with that, it looks like our list published events endpoint is working as expected. In summary, we tested the list published events endpoint works by using the user interface. So let's recall what we've achieved in the list published events module. In list published events service, we added the find by status method to the event repository interface, and we added the list published events method to the event service interface, and we implemented the list published events method in the event service import class. In DTOs and mappers, we created the list published event response DTO class, and we added the toList published event response DTO method to the event mapper interface. In list published event endpoint, we created the published event controller class, and we implemented the list published events endpoint. In UI testing, we tested the list published events endpoint works by using the user interface. In this module, we'll implement the published event search functionality. The module is structured like this. We'll start by implementing the search functionality in the service layer. We'll then update the controller to handle search requests. and then we'll test the search functionality through the user interface. So for the learning objectives, by the end of this module, you'll be able to implement the published event search functionality in the service layer, update the published event controller to support optional searching, and test the search published event functionality by using the user interface. So with this covered, let's get started. In this lesson, we'll implement the published event search functionality in the service layer. So we're back in our IDE, let's head over to the services package, we'll go to event service, and we're going to introduce a new method here. This is going to return a page of events, much like our list published events, but we're going to call this one search published events. It's going to take a string query and a pageable, which we'll call pageable. So with this added, let's go down to the implementation, hover over the red squiggle, go implement methods, okay, and now we have our method stub. So where this differs, let's actually close out so we can see. So where this differs from our list published events is this is going to just list out all published events, whereas this one is going to list out only the events which match the query. And we're going to allow the user to query using terms from the event name, the venue name, and more can be added as and when requirements dictate. So how are we going to do this? Well, we're going to have to implement some search functionality. Now we could use a full-blown search technology like Elasticsearch, but in this case, we're going to leverage PostgreSQL's text search abilities. So to do this, we're going to go to the event repository and we'll introduce a new method. This is going to return a page of event, and we're going to call this one search events. It's going to take a parameter, which we'll call search term, string search term, and of course we'll need that pageable as well. Now this is one of those instances where Spring Data JPA isn't going to be able to work out the particular query that we want. So we're going to use the query annotation here, and then we're going to specify a string value to the query annotation. Now this query is a bit complicated, so I'll put this in the lesson notes rather than type it all out, but we will go through it after we have it. So here we are. Now it is worth noting that this query is very specific to PostgreSQL. So we're using PostgreSQL functions here in order to search for the search term, which we can see highlighted here, in two different places. We're searching in the name field and also the venue field. Both of these are, if we bring up the event actually, name and venue are both string fields. So we're able to do a text search on these fields. Let's go back. This query also supports pagination via the pageable here. And I will point out this part here. So it filters to only return published status events. So it might look quite complicated, but at a high level, we're searching on the name and venue fields using text search, we're supporting pagination, and we are only returning published events. So now that we have this search event method, we can go ahead and use it in our service layer. So back to event service import here. Let's scroll down to the function we're implementing. Here we are. And we're simply going to do a pass through. So event repository dot search events, passing in the query as the search term, and then we'll pass in our pageable object as well. So let's return this. And with that, we've implemented the search published events functionality in our service layer. In summary, we added the search events custom query to the event repository interface. We added the search publish events method to the event service interface. And we implemented the search publish events method in the event service import class. In this lesson, we'll update the published events controller to support search. So back in our IDE, we have here our published event controller. So let's scroll down to its one method, list publish events. So we're going to add search functionality to this particular endpoint. So when the user specifies a query, we search, otherwise we list. We could potentially have a separate endpoint for this. However, as it only differs by a query parameter, we'll use the same endpoint. So let's introduce this query parameter then. So we're going to say at request param, like so, and we'll say required is false. This is optional. And we'll say it's the string of Q. So Q is a bit of a convention that you'll see on search endpoints, and it's short for query. So we have a nice, concise, functional approach here, but I think for the sake of making everything clear, we're going to do this in a slightly simpler way. So let's say we're going to have a page of events. We'll call this one events, like so. And now we're going to do an if statement. So if q is not null, and we'll say q.trim.is empty, and then we'll put an exclamation mark at the front here. So if q is not null and q is not empty when we trim it, then we're going to say events equals event service.search published events, passing in our query q, and then our pageable object. Otherwise, events is going to be event service dot list published events, passing in our pageable object. So we now have events. So we're going to pass in events here, like so, and we're going to return a response entity OK after converting all of our events into a DTO. So in summary, if the query is provided, then we're going to search. If the query is not provided, because it is in fact optional, then we're just going to list all the published events. We're going to map the published events to a DTO, which is the list published event response DTO, and then we're going to return a HTTP 200. And with that, we've added search functionality to the list published events endpoint. In summary, we added the search published events endpoint to the published events controller. In this lesson, we'll test the published event search functionality by using the user interface. So we're back in our IDE. We're going to run clean and compile. There we go, the application started up fine, so let's head over to the front end. So here we are in the front end, and we can see here test event 3 and test event 4, which is our 2 test published events. So let's see what we can do for testing on this. So let's inspect, go to our networks tab here, pull that down, and let's try this out. So let's first search for just the word test, because the word test should appear in both of these. So we'll go with test, and let's click on search. We still have 2. Test was sent, 200 OK, and our response is the 2 events. Very good. Now let's go with test event 3, and we'll search for this. We only get back test event 3, test event 4, we get test event 4 back. Very good. Okay, let's delete that, and let's click on search again, and we get both of them back. So let's now search for the word details, which appears in this venue details, but not in this one. So we'll search for details, expecting test event 3. Very good. So although it's fairly basic search functionality, it looks like our search events functionality is working as expected. In summary, we tested the search event functionality using the user interface. So let's recall what we've achieved in the published events search module. In search service layer, we added the search events custom query to the event repository interface, and added the search published events method to the event service interface, and implemented the search published events method in the event service import class. In search controller updates, we added the search published events endpoint to the published events controller. And in UI testing, we tested the search event functionality using the user interface. In this module, we'll implement the get published event details endpoint, and we'll use this data to populate the published event page, where a user can view details of an event and eventually purchase tickets to that event. So now for the module structure, we'll first implement the get published event functionality in the service layer. We'll then implement the DTOs and mappers. We'll implement the get published event details endpoint, and then we'll test the functionality through the user interface. So now for the learning objectives, by the end of this module, you will be able to implement the service layer functionality to get a published event, implement the DTOs and mappers needed to implement the get published event endpoint in the presentation layer, and implement the get published event endpoint in the presentation layer. And finally, test the get published event functionality by using the user interface. So with this covered, let's get started. In this lesson, we'll implement the get published event service layer. So here we are back in our IDE. Let's head over to the event service here, and we're going to introduce a new method. This one's going to return an optional of event, and we'll call this one get published event, and it's simply going to take one argument, a UUID, which represents the event ID. If we go down to the implementation now, hover over here, implement methods, okay. We now have this method stub ready to implement. Now we're going to need some way of getting a event by its ID but only if it's in published status. So in order to do that, let's create a new custom method or custom query inside of our event repository. Let's minimize that so we can see. So this one's going to return an optional of event, and we'll call this one find by ID and status. And we can make use of Spring Data JPA's naming conventions for this one, providing we pass in the ID, a UUID, and then an event status enum, which we'll call status. Now we can use this inside of the implementation, which we scroll down here, should be a call to event repository dot find by ID and status, passing in the ID, and then making sure the event status is set to published. And let's return this. And with that, we've implemented the get published event service layer. In summary, we added the find by ID and status method to the event repository. We added the get published event method to the event service interface, and we implemented the get published event method in the event service import class. In this lesson, we'll implement the DTOs and mappers that we need to implement the get published event endpoint in the presentation layer. So back in our IDE, let's go over to the domain package here into DTOs, and we're going to take a look at the get event details response DTO. So the DTO that we are to create, which will be get published event details response DTO, will be a subset of this particular class. So what we'll do is we'll copy this, calling the pasted class get published event details response DTO. A long name, but very descriptive. And in the pasted class, we're going to decide what we want to include. ID, yes. Name, yes. The start and the end time of the event, yes, let's include that. The venue details, absolutely. The sales start and sales end, no, let's not include this because the attendee only wants to know whether or not they can buy the tickets. They don't necessarily want to know the window they can buy them in. The same for status. Let's exclude this because all of the events will be published. And let's exclude updated at and created at. The attendee user doesn't want to know about that. Now, we will include the ticket types and we will need a different DTO for this one. So let's go here, identify where it is. Here we are, get event details ticket type. The name will get longer when we paste it. We have here get published event details ticket types response DTO. And we'll include the ID, name, price, description. Will not include total available, created at, or updated at, because the attendee user doesn't want to know about any of that. So let's copy the name of this DTO. We'll go back to our get published event details response DTO and make sure that ticket types uses this as a type. So that's our DTO. Let's now go over to the mappers class and we can deal with the mappers next. Here we are. Let's expand this. So let's return this and we'll say to get published event details response DTO, passing in the event. But of course, we'll also need to handle the get published event details ticket types response DTO. So let's paste that there and we'll say to name of that class, passing in the ticket type, which we'll call ticket type. And now this particular method can be used by MapStruct in this one here. So with that, we have both our DTOs and our mapper methods ready to use. In summary, we added the get published event details response DTO and the get published event details ticket types response DTO classes. And we added the mapper methods. In this lesson, we'll implement the get published event endpoint. So back in our IDE, we have the published event controller class open. So let's get to implementing our new endpoint. So we already have an endpoint which lists and searches for the published events. Let's introduce a new one to get the published event. So this one will also be a get mapping, but this one's going to specify a path. And in that path, we're going to specify the event ID, public response entity, returning our new DTO, which is the get published event details response DTO. And we'll call this one get published event details. And in the arguments, we're going to specify a path variable. It's going to be a UUID, and we'll call this one event ID. Let's import UUID here. Great. Now for the implementation of this method. Let's just remove that trailing comma. So we're going to call the event service. dot get published event, passing in the event ID, and then we'll call dot map, because if we find the event ID, we'll want to call the event mapper to get published event details response DTO, and then we'll call map again because we'll want to return a response entity, OK, or else we're going to want to return a response entity not found, build. And if we return this from our method now, but that's not all. We'll want to make sure that this is a public endpoint. So let's go over to the security config here. Config, security config, expand this. And we've been very specific so far. We said the get call to API v1 published events. Well, I'm going to put a / and then 2 asterisks after that as a wildcard. So this should also match when we specify the ID as well for our get published event details. So with that done, we've implemented the get published event details endpoint. In summary, we implemented the get published event endpoint and we updated security config to make calls to the make get published event endpoint public. In this lesson, we'll test the get published event endpoint by using the user interface. So back in our IDE, let's open up Maven here and run clean and compile. Great, we have a build success, so let's run our backend application. Okay, that's the application started up fine, so let's head over to the user interface. Okay, so here we are on the attendee landing page. Test event 3 and test event 4. So let's click on test event 3 here. Okay, great. So we can see here we have the published event details page. And let's take a look at the network call that we've got here. So we can see HTTP 200 OK, made to API v1 published events, and then the ID of the event. And there's no authorization header. So we've been able to implement this endpoint and make it public. And in the response, we have the event details and our various ticket types. So let's take a look at the information on the page. Name of the event, venue details, dates of the event, a random image, and then we have the various different ticket types. VIP entry, platinum entry, standard entry, and then the different prices, and then the ability to purchase tickets. But of course, we've yet to implement this. So all of this information matches if we log in now. Organizer password. Here we are, test event 3. We can see here the various information, test event 3, the dates, test event details 3, and then the ticket types, VIP entry, platinum entry, and standard entry. So it looks like our get published event details endpoint is working as expected. In summary, we tested the get published event details endpoint through the user interface. So let's recall what we've achieved in the get published event module. In service layer, we added the find by ID and status method to the event repository and added the get published event method to the event service interface and implemented the get published event method in the event service import class. In DTOs and mappers, we added the get published event details response DTO and get published event details ticket types response DTO classes and added these classes corresponding mapper methods. In get published event endpoint, we implemented the get published event endpoint and updated the security config to make call to this endpoint public. In UI testing, we tested the get published event endpoint through the user interface. In this module, we're going to add the new users and roles that we'll need for our event ticket platform. The module is structured like this. We'll first configure the attendee user and role. We'll configure the organizer role, remembering that we already have the organizer user. We'll configure the staff user and role. And now for the learning objectives. So by the end of this module, you'll be able to add the organizer role, attendee user and role to Keycloak, and add the staff user and role to Keycloak. So with this covered, let's get started. In this lesson, we're going to add the attendee user and the attendee role to Keycloak. So here we are on localhost 1990. So this is the Keycloak admin login. So I'm going to log in with the admin username and the admin password. Okay, so we are logged in here. The first thing we'll need to do is to make sure that we're on the correct realm. So if we go to manage realms here, we can see we have several realms. We want to make sure that we have the event ticket platform realm active at the moment as our current realm. With that done, let's now go over to our users. So we already have the organizer user that we've been using so far. So we're going to add a new user now. And the username for this one is going to be attendee. And the email address, we'll go with whatever your email address is, and then we'll go with attendee at, and I'll just use Devtiro for mine. Okay, so that's our attendee username. We have an email address there. We'll go with the first name of attendee and the last name of user. And then we're going to create this user. We'll go over to credentials. We'll set a password. And as we are in a dev environment and we just want to be able to log in with a attendee user, we're going to specify the password as password. Obviously, don't do this in production. And we're also going to disable temporary to make sure that we don't have to reset the password when we log in as this user. So we now have an attendee user that we can log in with the username attendee and the password of password. The next thing that we'll want to do is to assign a role to this user. And this is how we're going to tell an attendee user from an organizer user from a staff user. So to achieve this, let's open up the menu on the left and we'll go to our realm roles. And we're going to create a role. Now the role name that we're going to go with here is going to be role_attendee. And we'll create this, we'll save this. And with this created, we can now go over to our user, the attendee user, go to role mapping, we're going to assign a role, we'll filter by realm roles, and we're going to assign the role of attendee to this user. So we now have an attendee user with the role of attendee. Now, while we're here, let's assign the role organizer to our organizer user. So we'll go back over to the menu on the left, go to realm roles. We're going to create a role, role_organizer. Save this. Then we'll open this up on the left. We're going to go to users, go to organizer, role mapping, assign role, filter by realm roles, and we're going to assign role organizer to our organizer user. And we can now use this information in both our front end and our back end in order to determine what type of user we're working with. In summary, we added the attendee user to Keycloak, we added the role attendee role to Keycloak, and we added the role organizer role to Keycloak. In this lesson, we're going to add the staff user and the staff role to Keycloak. So here we are back in Keycloak and we are already logged in. We're on the users page. We can access this page from the side menu here. So let's add the staff user. Add user. The username for this one is going to be staff. The email is going to be the same format that we've been using so far. There we go. We can use this flag in order to use our email address, but then differentiate it. So for the first name, we're going to go with staff. And for the last name, we're going to go with user. And we're going to create this new user, go to credentials, set password. We'll go with the very simple and very unsecure string of password, setting temporary to be off. And this is only really appropriate in our local development environment and of course not production. So we have a user, a staff user that we can log in with the username of staff and the password of password now. So let's now deal with the staff role. So let's go to the realm roles here. We'll create a role and we'll call this one role_staff and then we'll click on save. And now if we go over to our users here, look for our staff user, role mapping, assign a role, filter by realm roles, we can assign the role of staff to our staff user. With that, we now have three different users. We have an organizer user, we have a attendee user, and we have a staff user, and they each have assigned their own appropriate role. So in summary, we added the staff user to Keycloak, and we added the role staff role to Keycloak. So let's recall what we've achieved in the new users and roles module. In attendee user, we added the attendee user to Keycloak, and we added the role attendee role to Keycloak, and we added the role organizer role to Keycloak. In staff user, we added the staff user to Keycloak, and added the role staff role to Keycloak. In this module, we'll implement the purchase ticket functionality, which also includes generating a QR code. Again, to avoid any confusion, we will not be integrating with a third-party payment provider. We will instead be mocking out the particular payment logic in order to avoid all of the challenges that comes along with processing real payment data. So the module is structured as follows. We'll first design the QR code generation functionality. We'll then implement the QR code generation in the service layer. We'll then implement the ticket purchase in the service layer. We'll then implement the purchase ticket endpoint before testing this new endpoint in the user interface. So now for the learning objectives. So by the end of this module, you'll be able to design the service layer functionality to generate a QR code. Implement the service layer functionality to generate a QR code. Implement the service layer functionality to purchase a ticket. Implement the purchase ticket endpoint. And test the purchase ticket endpoint by using the user interface. So with this covered, let's get started. In this lesson, we'll design our QR code generation functionality. So we're back in our IDE. Let's head over to the entity that represents the QR code. So in domain, entities, and we want QR code here. Here we go. So there's a few things that we'll want to update on this QR code entity now that we know more about our system, having started to build it out. The first thing that I'm going to do is remove the generated value from the ID on QR code. And the reason I've done this is that we want to manually generate the UUID that the QR code uses as the ID before we save it. And the reason we'll want to do that is because we want to bake it into the QR code itself. So when the QR code is scanned, we can use that ID to look up the QR code in the database. Now, the second thing that I'm going to do here is for the value instance variable here, I'm going to specify a column definition of text. And the reason I'm doing this is we're going to store the QR code image in the database. Now, this doesn't scale very well. However, for an initial solution, it's appropriate, I'd say. It would allow us to get moving, get this functionality built with minimal additional infrastructure. The move to specify text rather than the default varchar means that this particular field will expand to fit whatever the size of the contents, which in our case is going to be a base64 encoded QR code image. But just calling it out again, this only goes so far, and we are going to be storing quite a bit more data in the database by base64 encoding and saving images. So bear that in mind if you're looking to scale out a solution like this. So now I'm going to start the application. And the reason I'm doing this is I want to see whether or not changing the column definition to be text will automatically update the type in the database. Because we're using auto DDL, but sometimes you just need to double check. So the application started up. I'm now going to load up AdMiner. So here's AdMiner running on localhost 8888. This is running in our Docker Compose environment. So I'm going to specify PostgreSQL. The username is Postgres. Password is change me in prod ! Login. We'll go to our Postgres database, which is the one that we're using. And I'm going to click on QR codes here. So the value is now text. Great. So that means that when we store a base64 encoded image in there, it won't be limited by the default varying character 255 type. So with that done, let's head back to our IDE. Here we are. We can actually stop this running now. We don't need that running. Okay. So if we take a look in our repositories, we're going to want to save and recall QR codes from the database. So let's take this moment to create a repository for our QR code repository, which is going to be an interface. Let's just fix that typo. Okay. And this is going to extend JPA repository, where the type is going to be our QR code and UUID is going to be our ID type. So we now have this QR code repository that we can use. Let's not forget the repository annotation on the top. So let's now, inside of these services here, define a QR code service interface. So we'll say QR code service interface, and this is going to be where we declare the function to generate our QR code. I think this will simply return our QR code entity, and we'll call this generate QR code, and it will take the ticket entity as a argument like so, because we need to save the QR code against the ticket. There we go. Now, I think we should handle the case where the QR code generation fails for whatever reason. In order to do that, I'm going to create a custom exception, which is just going to follow the same pattern that we've been doing so far. So I'm going to copy one that we've got. Rather than event not found exception, I'm going to call this one QR code generation exception. And then over in our error controller, or our global exception handler, should I say, we're going to handle it. And again, exactly the same way we've been doing so far, QR code generation exception. And we'll say handle QR code generation exception, making sure that's the type that we pass in. We'll specify the type in our error message, and we're going to return an error which is unable to generate QR code, and not a bad request, but an internal server error. So this will give the user interface enough information that something's gone wrong, but if we've been unable to generate a QR code, that's definitely a problem within our application rather than something the user has done. So we'll go with a HTTP 500. A few things that we've done in here. We've updated our QR code entity. We've created a QR code repository, we've defined a service with the generate QR code method, and we've created a custom exception to handle the case where we are unable to generate a QR code. So now that we have all of this in play, we can now move on to implementing the generate QR code functionality. In summary, we've updated types in the QR code entity, added the QR code generation exception, and we added the QR code service, and we added the QR code repository. In this lesson, we'll implement our QR code generation functionality. So we're back in our IDE. So let's go over to our services here. We'll go to import, and we're going to create a new Java class, calling this one QR code service import, and this will be a Java class. And we'll implement QR code service. And if we hover over here, we implement our methods, generate QR code, and we now have a method stub that we can use. So before we do that, let's add the service annotation, required as constructor. And now we can start to think about how to implement this particular functionality. Now there's already a well-established library for this, and that's crossing. At least I believe it's called crossing. So if we go to pom.xml here, we'll scroll down to just before our test dependencies, and we're going to include these two dependencies here. We're going to need both core and the Java Standard Edition dependencies. I'm going to include those and make sure that we refresh our Maven changes. Very good. So this will allow us to generate our QR code. Now, in order to make good use of this library, I think we should create a bean for it. So up in config here, I'm going to create a new Java class, and I'm going to call this one QR code config. And we're going to put the @configuration annotation on the top here, because we're going to declare a bean inside of this particular config file. So public QR code writer, which you can see comes to us from that library. And we'll call this one QR code writer. And then we're going to return a new QR code writer. And this will now allow us to inject this wherever we do need it. So back in our QR code service import, let's just make a bit more room. I'm going to declare a private final QR code writer, which we'll call QR code writer. And we're also going to need the QR code repository as well, which we'll call QR code repository. So let's get to implementing this. The first thing I'm going to do is generate a UUID. So UUID, random UUID, and I'm going to assign this to a variable called unique ID. And this is going to be the unique ID that we bake into our QR code and then use it to look up the QR code in the database. So it's also going to be the QR code ID. And this is exactly why we removed the auto generation of the IDs for QR code, because we're going to do it manually. So next we're going to want to generate our QR code. So I'm going to declare a method call, generate QR code image, and we'll pass in the unique ID here, and we're going to want to assign this to a string called QR code image. So this is going to be base64 encoded. And it's red because this method currently doesn't exist. So we're going to create it like so. And we can now focus on taking a UUID and then returning a base64 encoded QR code image inside of this private method. So the first thing that we're going to want to do is generate something called a bit matrix. So we'll do QR code writer dot encode, and we're going to pass in our unique ID dot toString, because we're going to bake in the string representation of our UUID. Next, we're going to specify the barcode format. So we can generate more than just QR codes with this library, but we want a QR code. So barcode format dot, and we want QR code. And now we want to specify the height and the width. So I'm going to create a couple of private static finals up here, and we'll make these just ints, and we'll say QR height. And let's do something like 300 pixels. And then we'll copy that and we'll say QR code width is also going to be 300. We could pass this in as configuration. However, for the moment, we'll just hard code these as statics. So we'll go, what did it ask for next? The width. So we'll go QR code width and then QR code height. And then we should be able to assign this to a variable, which we're going to be calling bit matrix. We are getting a red underline, and that's because it throws an exception. So we'll add that exception to the method signature, and we'll handle that in a moment. So we now have a bit matrix, but what can we do with a bit matrix? Well, we can turn it into a buffered image. and then that will allow us to turn it into a base64 encoded string. So we'll call the matrix toImageWriter, which has some static methods on there. One is toBufferedImage. So if we pass in our bit matrix, we now have a buffered image that we can use, just a Java buffered image, which is great because then we can, if we scroll down here, we'll create a byte array output stream like so. We'll say byte array output stream equals a new byte array output stream. And we're putting this inside of the try here because then it will close the byte array output stream when we're done. So let's say image IO. And we're going to write the buffered image, which we should probably rename to be something like QR code image, perhaps, to make it obvious what it is. So we're going to write the QR code image. We're going to write it as the format of PNG, and then we'll pass in our byte array output stream like so. We're getting some red underlines, and that's because we have some unhandled exceptions. So let's add that to the method signature as well. There we go. That's a bit better. So we've written the buffered image to the byte array output stream. So let's get the bytes for this particular byte array output stream. So we're going to say baos.toByteArray. We'll assign that to a variable, which we'll call our image bytes. And now we can return using the base64 from Java util getEncoder.encode to string the image bytes like so. And with that, we've been able to generate a QR code image and convert it into a base64 encoded string. However, we do have these exceptions that we do need to handle. So if we scroll up to the top here, we're going to wrap the content of the generate QR code method in a try, like so. And then we'll say catch any exception. We could be a bit more specific. In fact, let's be a bit more specific. So we'll say writer exception or IO exception. Either can be called EX. Oh, copy and paste error. Let's try again. I think I may have copied the wrong one there. Let's try that again. So let's add that to the method signature, IO exception. So now we should be able to specify like so. Very good. So what we'll do in this case then is we'll throw a new QR code generation exception, and we'll say failed to generate QR code. And then we'll pass in the exception that was thrown. And now we can focus on what we're going to do with our base64 QR code image now. Well, we want to save it in the database. So let's create a new QR code. QR code equals new QR code. We decided not to use those builders, remember? And we'll say QR code dot set ID is going to be the unique ID that we generated here. We'll say QR code dot set status. And this is going to be the QR code status of active. QR code set value is going to be our base64 encoded QR code image string. And then we're going to set the ticket, and that's going to be the ticket argument that's been passed in to the method up here. And now we can use our QR code repository dot, and we're going to call save and flush on the basis that we're going to be calling this from a method that's also doing some transactional stuff. So let's just flush straight away. And we're going to pass in the QR code like so. And if we return this, we complete the initial implementation of our method. So we generate a random UUID. We generate our QR code image by going bit matrix to byte array to base64 encoded string. We then create our QR code entity, populate it with the information that we have, including our base64 encoded string. We save it to the database and we return the QR code entity. And with that, we have the initial implementation of the generate QR code method. In summary, we added the crossing dependency and implemented QR code generation. In this lesson, we're going to take the generated QR code logic and use it to implement the ticket purchase logic. So we're back in our IDE here. So let's start by going over to our services, and we're going to create a new Java class inside of here. And we're going to call this one ticket type service. And this is going to be an interface. So I'm doing this on the ticket type service because we're kind of creating a ticket from a ticket type. So it feels like this logic belongs to the ticket type. So inside of this particular interface, I'm going to specify a method that returns a ticket, and we'll call this one purchase ticket. And then it's going to take a UUID, which is going to be the user's ID, the user who's purchasing the ticket of that particular ticket type. And we'll also need the UUID, which represents the ticket type. And that will allow us to generate a ticket from that particular ticket type. Now, before we go ahead and implement this, I think we're going to have a couple of error cases that we'll need to handle. The first one is if we attempt to look up a QR code and can't find it. And the second one is if we try and purchase a ticket and there's no available tickets and the tickets are sold out, then we need to handle that error case too. So over in our exceptions here, I'm going to copy just the generic custom exceptions that we've been using. And the first one that I'm going to create is QR code not found exception. And the second one that I'm going to create is going to be called tickets sold out exception, like so. And then before we implement our functionality, let's just make sure we're handling these exceptions in our global exception handler. So we'll copy this. And first we'll handle the QR code not found exception. So handle QR code not found exception. And we'll set the error message to be QR code not found. And we'll make this an internal server error, I think. That still makes sense because if we can't find the QR code, then something may well have gone wrong. So the next one that we're going to handle is going to be the tickets sold out exception. And we'll update the method to handle this one. And we're going to reply with the error message of tickets sold. We'll say tickets are sold out for this ticket type. And we're going to return the HTTP of bad request, I think. So a HTTP 400. So if the tickets were sold out when the user was trying to purchase it, technically not the user's fault, but it's an error on the client side, I would say. So we're going to go with a HTTP 400. So with that done, we're now able to use these exceptions in the implementation of our functionality. So let's create a new class inside of the services impl, and we'll call this one ticket type service impl, implementing the ticket type service that we've just declared, and we'll hover over the red squiggle and implement those methods. Okay, so before we go any further, I'm going to add @transactional to the top of this annotation because we're going to be dealing with the QR code entities and the ticket type entities and probably ticket entities. So multiple database calls, let's make this transactional so it's atomic. I'm also going to add the service annotation to the top here. And we're going to need a few dependencies. So we'll first need to get hold of the user from the user repository. So we'll say user repository. And to inject that, we're going to need the required arguments constructor. Let's just make a bit more room. So we need to look up the user who's purchasing the ticket. And we decided that any user type can purchase a ticket. We're also going to need a way of retrieving ticket types from the database and also tickets. So I don't believe we yet have a repository for those. So let's create one. So ticket repository is going to be our first one. Extends, we'll go with JPA repository. This one deals with the ticket entity and it's a UUID type, which we'll import like so. And we'll put the repository annotation on top. And I'm simply going to copy this and create a ticket type repository, changing the type to be ticket type rather than ticket. There we go. And then back over in our ticket type service impl, we're going to inject the ticket type repository like so. And then we'll inject the ticket repository also. And then of course, we'll need a way of generating QR codes. So we're going to inject the QR code service, which we'll call QR code service. Okay. So now that we have all of these dependencies, let's go about implementing the logic. So the first thing that we'll do is look up the user repository, find by ID, passing in the user ID, and we'll say or else throw, because this will return an optional. And we're going to throw the new user not found exception, and we'll do a string.format in here, and we'll say user with ID, and then we'll say the ID was not found. And then we can pass in the user ID there, like so. And we'll assign this to a variable, which we'll call user. So we've looked up the user in the database, or we've thrown a user not found exception. Let's now do the same thing with the ticket type. So we'll say ticket type repository dot find by ID, passing in the ticket type ID, or else throw. And I believe, do we have a ticket type not found exception? Yes, we do. Wonderful. So we'll throw one of those. New ticket type not found exception, and we'll copy this string.format and we'll say ticket type with ID not found, making sure we specify the ticket type ID as the argument there, and then we'll assign this to a variable, which we're going to be calling ticket type. So we now have the user and the ticket type specified by these IDs. Now the next thing that we're going to do is we're going to check that there are tickets available. So we're going to say ticket repository, and we'll want to count up all of the tickets of a certain type. So over in ticket repository, let's add a new method in here. It's going to return an int, and we'll call this one count by ticket type ID. And if we specify a UUID here of ticket type ID like so, then Spring Data JPA is going to work out the query for this particular function. And now we can use it over here by calling count by ticket type ID, passing in ticket type dot get ID, or we could simply use the ticket type ID up here if we wanted to. And we'll call this one purchased tickets. Fix that typo. Purchased tickets of that particular ticket type. Now we're going to want to get the total available tickets. Now, yes, we are using @transactional here. So if an exception is thrown, then everything, all the logic in here is going to be rolled back in the database. However, we are going to have a concurrency challenge if, for example, we get the ticket type repository, we get back the number of available tickets, let's say 100, and let's say two users at near enough the same time get the count, and let's say there's 99 available. If they then both try and purchase a ticket, if we're not accounting for it, it could lead to some inconsistent states in the database. So it's a bit abstract, but in order to account for this, over in the ticket type repository here, which we'll go to like so, we're currently using find by ID, but I think we should create a pessimistic lock. So the way that I'm going to do that is by specifying the function find by ID, but with a lock. So we'll say optional of ticket type. So near enough the same return type as find by ID. We're going to call this one find by ID with lock. And we're going to specify the UUID of ID. However, I think we should probably be a bit explicit with this one. So we're going to say param of ID. And then we can specify that particular variable inside of a query annotation. So before we do that though, let's not forget the lock annotation. And we're going to specify lock mode of pessimistic right. And the reason we need to do this is the default for most databases is going to be, we try and find it. Here we are, read, so optimistic, which allows for this case to take place. So let's just complete this, making sure that we're explicit so everything works. Query, select, ticket type from ticket type TT, where ticket type.id equals ID, which is the ID param here. So this will do a find by ID, and we've made sure of it by specifying the query up here with a pessimistic right. So now if we go back, rather than call find by ID on the ticket type repository, find by ID with lock. And what that will mean is if two users get to this point in the code, one will have to wait here while the other one gets the lock and continues on. So let's continue implementing this, and then we'll circle back to this just to make sure we understand it. So purchase tickets, we know how many of those we have. We're now going to go ticket type dot get total available, assigning that to total available. And then we'll say if tickets purchased, or purchase tickets we call it, isn't it? Purchase tickets plus 1 is greater than tickets available, which is total available. Then we're going to throw a new tickets sold out exception. Otherwise, we'll continue, which we'll say to do. So with this logic in mind, then we're basically saying how many purchase tickets are there of this particular ticket type? How many are available? If I purchase one more, will it exceed total available? If it will, throw this ticket sold out exception. If not, continue on to this to-do that we have. So with this implemented, hopefully this lock makes a bit more sense. @transactional will roll back, but it won't necessarily handle this concurrency, which will only really come about when two users try and do this at near enough the same time. So two users come along, one grabs the lock, goes ahead and does his calculation, either continues on or ticket sold out exception, releases the lock, and the second user comes along, and then this calculation, in theory, should always then be correct. So with that done, let's continue on to this to-do. So let's create a ticket. So we'll say ticket, and we'll call this one ticket equals new ticket, and we're going to set the status to begin with, and that's going to be purchased. And then we're going to set the ticket type, so ticket.set ticket type, to be the ticket type object up here, putting that link in place. We're then going to say ticket.set purchaser to the user that we looked up at the top of the method here. And now we'll need to save our ticket. So ticket repository.save ticket, and we'll call this one saved ticket, because we'll need a saved ticket in order to generate a QR code. So QR code service dot generate QR code, passing in our saved ticket. And that should set the link between QR code and ticket. And I'm pretty sure we'll need to do one more save. Maybe we can optimize on this, but let's say repository dot save the saved ticket to make sure that link is definitely saved. And then we'll return this. There we go. So I think there is probably some room for optimization in here. But at a high level, we're looking up the user and the ticket type. We're then putting a lock in place so that this ticket sold out functionality is only ever dealt with by one user at any given time. So we work out if there are tickets available to purchase for a particular ticket type. If there's not, we throw a ticket sold out exception. If there are, we create a new ticket entity. We then generate a QR code, setting up the link between ticket and QR code. We then go ahead and save the ticket, returning it from this method. So with that, I believe we have the initial implementation of our purchase ticket functionality. In summary, we implemented the initial purchase ticket functionality. In this lesson, we'll implement the ticket purchase endpoint. So back in our IDE, let's go ahead and create a controller here, and we'll call this one ticket type controller to be consistent with this idea that we're generating a ticket from a ticket type. So this is going to be a REST controller. Let's make a bit more room. So a REST controller, we'll put the required arguments constructor on there because we'll need some dependencies, and we'll specify a request mapping now, where the path of this is going to be /API v1 events, and then we're going to specify the event ID, and then ticket-types, because ticket types are only associated with an event. Now let's specify a private final ticket type service, because we'll need to use this to purchase a ticket. And that endpoint is going to be a post mapping, where the path of this is going to be / we need the ticket type ID, and let's just say ticket after that, because we're purchasing a ticket, we're generating a ticket from a ticket type. So that should do it. So if we now say public, returning a response entity of void. And we're doing this because we're technically not taking any payment. No information is really passing to and from the server other than the user information, which is the JWT in the header, and the URL information, including the event ID and the ticket type ID. If you're implementing integration with a third-party payment system, this implementation would likely be a bit different, depending on which third-party integration you'd be going with. But for our purposes, response entity void should work. And we'll say purchase ticket. We'll need the JWT, so we'll say authentication principal, passing in the JWT, which we'll say is JWT. And then we'll say path variable, and we'll get hold of the UUID of the ticket type ID, because even though technically ticket types are associated with an event, so we specify the event in the URL here, we're not going to be needing it for this particular functionality. So now that we have the JWT and the ticket type ID, we can call ticket type service dot purchase ticket, and then we'll need to get the JWT from the user. So we're already doing that over on the published event controller here. No, because that one's public. It would have been on the event controller. Here we are. So what might be worth doing is if we create a new package, we'll call this one util, and in here we're going to create a new Java class called JWT utilities, or util, public final class. This is going to be a utility class. So we'll also specify the default constructor as private, like so. And then over in the event controller, so we could use the refactor tools, but I'm simply just going to cut this, go over to the JWT util, paste this in, and make it a public static method, which we can then use over in the event controller by importing it, like so. But then we can also use it over in the ticket type controller by also importing it over here too. So if we pass in the JWT, we now have the UUID representing the user, and now we'll pass in the ticket type ID, and that will purchase a ticket, remembering that purchase ticket, although it does return a ticket entity, we're not going to be returning that to the user, we're just going to be returning void. The user interface isn't going to be displaying the ticket information at this time. So let's return a new response entity, HTTP status of, we'll go with no content because there's technically no content on here. There we go. And with that, we have the initial implementation of our purchase ticket endpoint. In summary, we implemented the purchase ticket endpoint. In this lesson, we'll test our purchase ticket functionality by using the user interface. So back in our IDE, let's go ahead and open up the Maven panel here. We're going to go clean and we're going to go compile. Okay, build success. Let's start our backend application. Okay, very good. So that's the application started up. Let's head over to our browser. Okay, so we are on the attendee landing page. So let's select test event 3. And for this one, we're going to go with the standard entry, I think. Let's just open up the inspect and networks panel here. So let's click on purchase ticket. So we're being asked to log in. So I'm going to log in with the attendee user that we created a moment ago. Okay, so this is a mock page. Again, we are not entering real credit card information here because that comes with a whole heap of challenges. If you do want to integrate with a third-party payment provider, then that's an option for you, but we're just going to use this mock page. So we're entering some mock payment information, which we're going to pretend is genuine and valid. And if we click on purchase ticket now, we get a HTTP 500, an unknown error. Let's see why. Okay, we cannot invoke the save and flush because the QR code repository is null over in the QR code service. Let's see why that could be. So let's minimize that so we can see. So QR code repository is null because we missed off a final. Perfect. Let's restart the backend. Okay, restarted once more. Let's go back. And if we click on purchase ticket now, thank you. We're redirected back. Let's take a look at the HTTP 204 no content. So it looks like that's gone ahead. There is one way of confirming that though, and that's by going over to, and we'll start off on tickets, I think. So select the data from tickets. So we can see some of my testing here, but we're looking for the very latest one, which will be down the bottom, this one here. So the purchaser ID is the attendee user. Perfect. I can confirm that this is the time right this very moment. So that seems to match up. The ticket type ID is the standard entry for 999, so that works too. Let's go over to the QR codes, select some data. Again, making sure that we get the one that matches the times, the latest one here. We have one active, and we have a big, long base64 encoded QR code image here. And if we click on ticket ID, we should go back to the one. Yep, here we are, the one that was purchased just a moment ago. So although we can't yet see our QR code image, and we will see that very, very shortly, it looks like we're able to purchase tickets and generate QR codes, and we can see them here in the database. So in summary, we fixed a null pointer exception bug, we created a ticket in the database, and we created a QR code in the database. So let's recall what we've achieved in the purchase ticket module. In QR code generation design, we updated types in the QR code entity, added a QR code generation exception, and added the QR code service, added the QR code repository. In QR code generation service layer, we added the crossing dependency, implemented the QR code generation. In ticket purchase service layer, we implemented the initial purchase ticket functionality. In ticket purchase endpoint, we implemented the purchase ticket endpoint. And in UI testing, we fixed a null pointer exception bug, created a ticket in the database, and created a QR code in the database. In this module, we'll add role-based security to our application. This allows us to control which users can access specific parts of our application based on their assigned roles. The module is structured like this. We'll first extract the roles from the JWTs, And then we'll lock down the events controller endpoints to only organizer users. So for the learning objectives, by the end of this module, you'll be able to implement the role extraction from the JWT and lock down access to endpoints to certain roles. So with this covered, let's get started. In this lesson, we're going to extract the roles from the user's access token. So here we are back in our browser, and I'm on the events page logged in as the organizer user. If I go to inspect here, go to network and go to refresh, we can see the calls being made to list out the events. However, what we want is this bearer token value. We can miss off the bearer prefix, we're just looking for the JWT. So if we copy this and then go over to jwt.io, we can paste in this value in order to see the decoded JWT. And we can see all of the claims inside of the JWT here. The part that I want to draw your attention to is the realm access claim, which includes a roles claim, which includes some roles. We can see here the role of organizer, which we assigned in Keycloak in order to identify this user as an organizer user. We also have the role attendee and the role of staff. It would be really useful on our backend application to be able to extract this information and then make decisions based on which type of user has made the request. So that's what we'll implement in this lesson. So here we are back in our IDE. Now the way we're going to achieve this is with a custom converter for our JWT. So over in config, we're going to create a new file and we're going to call this one JWT authentication converter. So with that done, let's just expand this to make some room. And we're going to say this implements converter, which comes to us from Spring Framework Core Converter, going from the JWT, which comes to us from OAuth 2 JWT. And we're going to turn that into a JWT authentication token, which also comes to us from OAuth 2. There we go. And if we now hover over the red squiggle here, go to implement methods, and we're implementing convert. So this will allow us to implement the logic that goes from the JWT as provided in the request header to the representation that Spring Security uses internally. So let's create a private method to begin with. This is going to return a collection of granted authorities, and we'll call this method extract authorities. And we'll pass in the JWT as an argument here. So within this private method, we're going to extract the authority, so extract the roles from this JWT. So let's first get the realm access claim. So jwt.getClaim, and that claim is going to be realm underscore access, which matches what we saw over in jwt.io. We'll assign this to an argument called realm access, but it's not going to be an object, but instead a map of string object. There we go. So let's do a check now. So if realm access, and we'll say is null. So if null equals realm access, or we'll say realm access contains key roles, and we'll put an exclamation mark in front of that to negate it. So that's to say if realm access is null, or it does not contain the key of roles, which is what we expect there to be. It's what we saw in jwt.io. We're going to return collections.emptyList. So we'll just return an empty list in that case. Now let's do realm access.get roles because we happen to know that this particular claim now exists. And we'll assign this to, we'll say a list of string, and we'll have to cast this. We may get a class cast exception if something has gone wrong, if the payload isn't what we expect it to be. However, for the time being, I'm just going to suppress this, I think. So let's just do a suppress warnings, and we'll just make this unchecked for the time being. Again, with a bit more time, we could always build that out to be a bit more robust. But we now have this list of roles. So we're going to say roles.stream. We're going to filter for only the roles where the role starts with role underscore, which is the convention that we've used over in Keycloak. Let's put that on a new line. And then we're going to create a simple granted authority, which simply takes a string. So we can do simple granted authority :new. And now we will collect this, and we'll collect collectors to list. There we go. So now we can use extract authorities inside of our implementation, passing in, and let's rename that to be JWT rather than source. Passing in the JWT, we can assign that to a variable which we'll call authorities, and we can return a new JWT authentication token, passing in the JWT, and then the second argument is going to be our authorities. Let's pass that in like so. And I'm going to place, before we forget, the @component annotation on the top of this class. There we go. So we've implemented a custom converter to go from a JWT to a JWT authentication token. And the custom logic that we've implemented is basically to extract the roles from the roles that we've assigned in Keycloak to each of these individual users, creating simple granted authorities, which is the representation of the role that Spring Security uses internally. So let's now go about using this in our Spring Security configuration. So let's head over to the security config here, and I'm going to inject this by placing it inside of the arguments to the method, and we'll call this one JWT authentication converter, not forgetting the comma there, and that will be injected because we put @component on the top. Now, rather than OAuth2 JWT with the defaults, we're going to make use of the Lambda. So let's assign an argument name of JWT, and we'll see JWT authentication converter, passing in the authentication converter that we've injected up here. And with that, we're now using our custom implementation. And as a result, we should now be able to make use of these roles inside of our implementations. So in summary, we added a custom JWT converter to extract a user's role, and we updated the security config to use the JWT converter. In this lesson, we're going to lock down certain endpoints to only certain roles. So here we are back in our IDE. Now, I want to lock down the event controller to only the organizer users. So if we look for the event controller here, expand this, we can see it has endpoints in order to do things like create an event, update an event, list events, get event, and delete an event, which is only things that we'd want an organizer user to be able to do. So there's a couple of different ways to achieve this. We could add annotations to the event controller or the event controller endpoint methods here in order to restrict access. But because we're making the blanket decision that only organizer users can access this particular controller, over in security config here, there is a simpler approach. We're going to add another request matcher. And this one is going to specify /API v1 events, which is the root URL for every single endpoint in the events controller. And we're going to say has role, and then we'll say organizer, like so. So that simply says every single endpoint in the event controller, in order to call the endpoint, the user must be an organizer user. Note that we're missing off the role underscore prefix. That's taken care of for us by Spring Security when we use this has role method. So if we were to start our backend application now, there we go, looking good. So let's head over to our browser. So here we are, I'm logged in as the organizer user, so OR for organizer. So if I refresh this, I can see that I get HTTP 200s back from the events list endpoint, which is great. That's exactly what we expect. It looks like we've been able to extract the role successfully and then use that to allow this user access to the endpoint. So for a negative test, if we were to log out here and then log in as our attendee user, so attendee password. So I've had to manually navigate over to dashboard events. So type in the URL manually because this endpoint isn't immediately available on the front end to an attendee user. However, the key point that I want to point out here is the request being made to list events now receive a 403 forbidden because this is a user with the attendee role and not the organizer role. So it looks like we've introduced this authorization and it seems to be working as expected. In summary, we locked down the event endpoints to only organizer users. So let's recall what we've achieved in the role-based access module. In extract roles, we added a custom JWT converter to extract a user's role, and we updated the security config class to use the JWT converter. In lockdown endpoints, we locked down the events endpoints to only organizer users. In this module, we're going to implement the list ticket endpoint. The module is structured like this. We'll first implement the list ticket service layer functionality, create the DTOs and mappers, implement the list ticket endpoint, and then test the new endpoint through the user interface. So now for the learning objective. So by the end of this module, you will be able to implement the service layer to list a ticket, implement the DTOs and mappers to list a ticket, implement the list ticket endpoint, and test the list ticket endpoint by using the user interface. So with this covered, let's get started. In this lesson, we're going to implement the list ticket service layer. So here we are back in our IDE. So let's start over in the repositories package here, and we'll head to the ticket repository. So the goal of this is to list the tickets that a user has purchased. So let's introduce a new method for this. This one is going to return a page of tickets. Let's import page. And we'll call this one find by purchaser ID. And it's going to take a UUID representing the purchaser ID. Purchaser ID, there we are. And it's also going to take the pageable object, which we'll call pageable, like so. So Spring Data JPA should be able to work out the query for this one, because on ticket, we have this concept of a purchaser, which is a user. So with that in mind then, let's head over to the services package here, and we'll need to create a new interface, so a new Java class, and we'll call this one ticket service. It'll be an interface, and the method that we're going to declare on this interface, we'll call this one, well, it will return a page of ticket. That much is certain. Let's import page and ticket, and we'll call this one list tickets for user, and we'll pass in the UUID, which is going to be the user ID, and then also the pageable object, because we'll get that, or Spring will inject that for us, so pageable. Okay, so with that done, let's create an implementation for this. New Java class, ticket service import, and let's close that on the left now. And we'll add, before we forget, the @service annotation to the top of this, and we'll declare that this implements the ticket service. And if we hover over the red squiggle, implement methods, okay. And there's our method stub. So if we add the required art constructor and then declare a private final ticket repository, which we'll call ticket repository, we can now use this in our implementation of this method. So we'll say ticket repository dot find by purchaser ID, passing in the user ID, and then of course the pageable object. And if we return this, that is all we need to do to implement this method. It's basically a pass-through. But this should allow the caller to list all of the tickets for that user. In summary, we added the find by purchaser ID method to the ticket repository and implemented the ticket service with the list tickets for user method. In this lesson, we'll implement the DTOs and mappers that we need for the list tickets endpoint. So we're back in our IDE, so let's start with the DTOs. So let's go to domain DTOs, and let's create a new Java class, and we'll call this one list ticket response DTO. And we'll add the data, all ours constructor, and no ours constructor to the top of this. Now this is to represent a summary of the overall ticket. Let's just remind ourselves of the ticket entity by placing that on the right-hand side, this on the left. So we're certainly going to need the ID of the ticket. That's very important. We'll also have the status of the ticket. And now we'll also need to represent some information. Now, for the sake of this exercise, I think we'll just represent information about the ticket type. However, we could go as far as to include information about the event as well. We'll just use a ticket type for the moment because I think it will demonstrate what we're looking to achieve here. And you can extend that to the event and other information if you so choose. So if we take a look at the ticket type here, I think the information that we'll need is the ID, the name, the price, and I think that will be it. So for that then, let's create a new DTO here. And we'll call this one list ticket response ticket type DTO, or rather list ticket type DTO response. There we go. Let's put that on the left hand side. Let's close the project files on the left here. We'll add the @data, all ours constructor, no ours constructor, and now we can go about adding what we need here, which is going to be the ID, the name, and we'll go with the price as a bare minimum. There we go. And I think that will do it for this. So if we take this class, go back to the list ticket response DTO, and we'll declare a private list ticket type DTO response, and we will call that the same instance variable name as we have over on ticket here, which is ticket type, and the mapper should be able to work everything else out from there. Talking about the mapper, that will be our next step. So let's head over to the mappers here, And we have an event mapper, but which looks, we close all of these, quite comprehensive at this point. So let's copy this mapper annotation at the top and create ourselves a new Java class. And we'll call this one a ticket mapper. And we'll paste on that annotation at the top to save us some typing. And now we can declare some methods in here. The first one is going to return a list ticket type DTO response. And I'm not too happy with that name. Let's rename that to be a list ticket type response DTO. And then we'll copy that and we'll call this method to name of that class, passing in a ticket type. Just close it on the left, which we'll just call ticket type. And that will convert from one to the other. Why do we have a red underline here? Because we've used the word class instead of interface. There we go. And now for the list ticket response DTO, like so. And we'll say to list ticket response DTO, passing in a ticket, which we'll call ticket. And we'll need to import ticket here. Seems to be some issue with resolving ticket. Okay, just an ID issue. There we go. So we now have the two methods that we need in order to convert the entities to the DTOs for our list tickets endpoint. In summary, we created the list ticket response DTO and the list ticket response ticket type DTO classes, and we created a ticket mapper with mapper methods. In this lesson, we'll implement the list ticket endpoint. So here we are back in our IDE. So let's go over to projects here. We'll go to controllers and we'll create a new controller, which we'll call the ticket controller. And let's expand this. So at rest controller, we'll go with the request mapping. So we can specify a base path, which is API v1 tickets. And then we'll also go with the required Rs constructor, which will allow us to inject our collaborators. So private final ticket service, which we'll call ticket service, private final tickets mapper, which we'll call ticket mapper. And that should be all that we need. So with that done, let's declare a public method returning a page, let's import page, of our list ticket response DTO. And we'll call this one list tickets. Now we'll add the get mapping annotation to the top of this. No arguments needed because we are just going to be using the same base path as up here. We are going to need a few arguments to the list tickets method though. The first one being the authentication principal, which will be a JWT. And we'll need that to identify the user so we can return their tickets. And we'll also need the pageable object as well. And with those two things, we can call the ticket service, list tickets for user, first passing in the ID of the user, which we can use our pass user ID method, which we can statically import now that it's in our utils. And the second thing we need to pass in is the pageable object. This will return a page, which we can call map on, and then ticket mapper. And then we can call to list ticket response DTO, semicolon. And then if we return this should be all that we need to do in order to implement our list tickets endpoint. The user will need to be authenticated. We get hold of the JWT, pass that and the pageable object to our service layer list tickets for user, and then we convert the response, which is going to be a page of tickets, to a page of list ticket response DTO. We could very well go ahead and wrap this in a response entity, but it will still return a HTTP 200. So I'm going to choose to not do that and just keep this a bit simpler. So with that in play, all we need to do now is test our new endpoint. In summary, we implemented the list ticket endpoint. In this lesson, we'll test our list ticket endpoint by using the user interface. So we'll start off in our IDE. We're going to go over to the Maven panel here, clean, compile, run these. That is a build success. So let's go ahead and run our backend application. Very good. That's a build success. So let's head over to our user interface in our browser. So here we are back in our browser on the user interface. So let's log in, and I'm going to log in as my attendee user because I have purchased a ticket with this particular user. Okay, so we're all logged in. If we go to dashboard, we can see we're redirected straight to the list tickets page now, which is this one here. And if we inspect, go to network and refresh this, there we go. We can see the calls being made to our new endpoint API v1 tickets with some page information, and we're getting a response, ID, status, ticket type, and this is the information that's being displayed on screen. We can of course build this out to include more information in a production application, I'd want this to include information about the event, maybe some images associated with the event, maybe some details on how to use the ticket. But for the MVP, this is doing exactly what we expect it to do, which is listing out tickets that the user has purchased. In summary, we've tested the list ticket endpoint using the user interface. So let's recall what we've achieved in the list ticket module. In list ticket service layer, we added the find by purchaser ID method to the ticket repository, implemented the ticket service with the list tickets for user method. In list ticket DTO and Mapper, we created the list ticket response DTO and list ticket type response DTO classes, and created the ticket mapper with mapper methods. In list ticket endpoint, we implemented the list ticket endpoint, and in UI testing, we tested the list ticket endpoint using the user interface. In this module, we'll implement the get ticket endpoint. The module is structured like this. We'll first implement the ticket retrieval in the service layer. We'll then create the DTOs and mappers that we'll need, implement the get ticket endpoint. We'll then implement the QR code retrieval functionality in the service layer, implement the QR code retrieval endpoint, and then perform some user interface testing. So for the learning objectives, by the end of this module, you'll be able to implement the service layer to get a ticket, implement the DTOs and mappers to get a ticket, implement the get ticket endpoint, implement the get QR code functionality in the service layer, and implement the get ticket QR code image endpoint. And finally, test the get ticket endpoint by using the user interface. So with this covered, let's get started. In this lesson, we'll implement the get ticket functionality in the service layer. So here we are back in our IDE. So let's start at the repository, which we can find down here, and we'll start off in ticket repository. So we already have two methods in here, count by ticket type ID and find by purchaser ID. Let's introduce a new one, which returns an optional of ticket, and we'll call this one find by ID and purchaser ID. And this one's going to take two arguments. The first one is a UUID, which we'll simply call ID, and the second one, a UUID, which we'll call purchaser ID. Let's make sure we spell that correctly. Purchaser ID. Great. So Spring Data JPA will be able to work out the query for this one. We simply want to get a ticket by its ID and the purchaser ID. And by doing so, we can make sure that we only return tickets for the person that has purchased them. So with that in play then, we can head over to the ticket service and we'll introduce a second method here. This one also returning an optional of ticket, and we'll call this one get ticket for user, passing in a UUID, which is going to be the user's ID. And then we'll need to pass in a second UUID, which is going to be the ticket ID. And with that done, let's go down to the implementation here, hover over the red squiggle, go to implement methods, OK. And now we have our method stub. This is simply going to be a pass through. So we'll say return ticket repository dot find by ID and purchaser ID, making sure that we pass in the correct order here, the ID of the ticket, which is the ticket ID, and then the user ID as the second argument. And with that, we've implemented the service layer functionality to get a ticket. We added the find by ID and purchaser ID method to the ticket repository and implemented the get ticket for user method in the ticket service. In this lesson, we'll implement the DTOs and mappers that we need to implement the get ticket endpoint. So let's start over in the domain package up here, and we'll create a new class in DTOs, and we'll call this one get ticket response DTO, and this will be a Java class. And for the sake of comparison, let's get the ticket and let's place that on the right hand side here. There we go, and let's close that. Now, this get ticket response DTO ideally needs information from the ticket type, and also the event. Now, we could have these nested inside of this class, but as we have 3 levels of information here, I'm going to elect to flatten it into this get ticket response DTO. This is an option we have available to us because we're using the DTO pattern. We're able to aggregate the data inside of a single object. So let's add the data, all R's constructor and no R's constructor, to the top of this class. And now we can start selecting the information that we want in here. So we certainly want the ID of the ticket. That's very important. The status of the ticket, also very important. Now I'm thinking we go into ticket type and we'll select the price of the ticket, like so. I think it would be useful to have the description of the ticket type as well, perhaps. So let's put that in there. Now let's go to the event information. And I think we should have the event name. Let's call that private string event name. Let's also have the private string of event venue. And then I think we should have the start and end here, but we'll say private local datetime event start, and then we'll copy this and also have event end. So this should give us a lot of information about the particular event, everything that you would expect to see on a ticket. But of course, we've flattened a lot of this information into our get ticket response DTO, so we'll need to handle that in our mapper. So let's head over to ticket mapper here, and let's expand this. And I think we'll have to close all of the tabs in the group in order to see what's going on. So we'll introduce a new method. This is going to return our get ticket response DTO, and we're going to call the name of the method to get ticket response DTO. Let's import that. And we're going to pass in a ticket entity to this method. Now this is where the mapping comes in. So we're going to declare some mapping annotations here. So the target for this one is going to be price, because we know that we need to get the source of the price from ticket.tickettype.price. And this is the pattern that we're going to use to map across this information. So price is done. Let's do description next. Description also comes to us from ticket type. Next, let's do the event name, which is going to be ticket type event.name. And then event venue is going to be event.venue. Event start is going to be event.start. And finally, event end is going to be event.end. And with that, we should have a working mapper. There is a way of testing this, and that's to run clean and compile, remembering that MapStruct will generate this code, and we have a build success. So it looks like this mapper is working as expected. In summary, we created the getTicketResponseDTO class and added the toGetTicketResponseDTO method to the ticket mapper class. In this lesson, we'll implement the getTicket endpoint. So back in our IDE, let's head over to controllers here and look at ticket controller. So we already have our list tickets endpoint. Let's introduce a new endpoint. This one also a get mapping, but where this differs is that this one's going to specify a path that has the ticket ID in there. So public method returning a response entity of the get ticket response DTO, and we'll call this one get ticket. And we're going to need the authentication principal, which is a JWT, and we're also going to need to get hold of the path variable, which is going to be a UUID, and we'll need to match whatever we've called it inside of the annotation. So we'll say ticket ID, and we'll need to import UUID here. There we go. So we can now get to implementing this method. Let's close that. Okay, so let's call the ticket service dot get ticket for user, and we're able to pass into this, make sure we get the order correct, the user ID, which is going to be pass user ID, passing in the JWT, and then we'll need to pass in the ticket ID. We'll then map this using the ticket mapper to convert this into a toGetTicketResponseDTO, and then we'll map this to response entity OK, and then if it's not found, we'll or else returning a response entity not found, and then we'll build that. And then we'll need to return from this. And with that, we have implemented our endpoint. We call the method that we implemented inside of the service layer. We convert using our mapper to the getTicketResponseDTO, returning HTTP 200 if everything's okay, otherwise a HTTP 404. In summary, we implemented the getTicket endpoint. In this lesson, we'll implement the service layer logic to get the QR code image. So back in our IDE, let's head over to the repository to begin with. There's our QR code repository, and to this we're going to introduce some functionality. This one's going to return an optional of our QR code entity, and we're going to call this one find by ticket ID and ticket purchaser ID. And if we just close the side menu there, we need to specify two arguments. The first is a UUID, which we'll call ticket ID, and the second one is also a UUID, which we're going to call ticket purchaser ID. And this should allow us to look up the QR code by using both the ticket ID and the ID of the purchaser, so the user's ID. So with that in play then, let's head over to the QR code service. Here we are. And we already have a method for generate QR code. Let's introduce a new method returning a byte array, and we'll call this one get QR code image for user and ticket. And it will take a UUID, which is going to be the user's ID. And it's going to take a second UUID, which is going to be the ticket ID, like so. And now if we go down to the implementation here, hover over here, implement methods, okay. We can now get to implementing this method. So let's call the QR code repository, and we're going to call the method that we've just introduced, find by ticket ID and ticket purchaser ID. Although we'll need to correct the naming on this. I missed off an R on purchaser. And now we need to make sure we pass in the correct order, the ticket ID first, and then the user ID second. And then we'll say, or else throw. If it doesn't exist, we're going to throw a new QR code not found exception, like so. And we'll assign this to a variable, which we'll call QR code. And now we're going to try and decode the base 64. So we'll do a try catch block for this one. And inside the try, we'll say return base 64 dot get decoder. And then we're going to decode QR code dot get value, like so. And that should return the value. However, we may get an illegal argument exception here. So we should handle that. So let's do a log. In fact, I don't think we have a logger yet. So let's add SLF4J annotation to the top of this class. And then we'll say log dot error. And then we'll say invalid base 64 QR code for ticket ID. And then we're going to place in there the ticket ID and also the error as well. So EX. And I think we'll throw a new QR code, probably not found exception, I think, because it's not found a valid QR code, like so. However, we could have a dedicated exception just for this as well. Okay, so with that, we now have the method that we can use in our service layer to return our QR codes. In summary, we added the find by ticket ID and ticket purchaser ID method to the QR code repository and implemented the get QR code image for user and ticket on the QR code service. In this lesson, we'll implement the endpoint to get the QR code image. So here we are back in our IDE, so let's head over to the ticket controller here, and let's expand this. Now I figured that we create an endpoint which extends the get ticket endpoint by returning the QR code image. So for this, let's add a get mapping, specifying the path of / ticket ID / QR -codes. Now it's only going to return a single QR code, which is going to be the one that's attached to the ticket. So the latest one, and we'll say public, and this is going to return a response entity of a byte array. And we'll call this one get ticket QR code. And this one's going to require the authentication principal, which is the JWT. And we'll also need the path variable, which is going to be the UUID called ticket ID. So with that done, let's now call the QR code service, which I don't think we have access to yet. So let's add that. Private final QR code service. QR code service dot get QR code image for user and ticket, passing in the user ID, which is going to be pass user ID from the JWT, and also the ticket ID. I'm going to assign this to a variable, which is going to be the QR code image, like so. Now we need to construct the headers in such a way to return the image correctly. So HTTP headers, which we'll call headers, equals new HTTP headers. And then we'll say headers dot set content type. And this is going to be a media type of image ping, headers dot set content length. And that's going to be QR code image dot length. And now we're going to return response entity dot OK, where the headers are the HTTP headers that we specified, and where the body is going to be the QR code image. And with that, we've implemented the endpoint to get the ticket QR code. In summary, we implemented the get QR code endpoint. In this lesson, we'll test our get ticket and get ticket QR code functionality by using the user interface. So we're back in our IDE. We're going to start by running clean and compile. There we go, build success. So with that done then, let's minimize that and run our backend application. Okay, that's the application started up fine. So let's head over to our browser. So here we are in our browser and I'm logged in as the attendee user. So if I click on dashboard here, we can see the ticket that we've purchased, which is just the seated ticket here with this ID. If we click on this, we now see that we have a ticket. This is to the big concert, the stadium. We can see a start time and end time. we can see some information and the QR code ticket ID, which matches what we have in the URL. But most importantly, we have ourselves a QR code image. Let's open up Inspect and Network, refresh this. So we can see that we have our call to the get ticket endpoint here, returning the ticket information, big concert, the stadium, matches everything we see on the page. And we can also see that we have the call to the QR codes endpoint here, returning, well, it doesn't show anything here. It's an image, which we can see here represented by this QR code. So it looks like both our get ticket and the get ticket QR code endpoints are working as expected. In summary, we tested the get ticket functionality using the user interface. So let's recall what we've achieved in the get ticket module. In get ticket service layer, we added the find by ID and purchaser ID method to the ticket repository and implemented the get ticket for user method in the ticket service. In get ticket DTO and Mapper, we created the get ticket response DTO class, added the to get ticket response DTO method to the ticket mapper. In get ticket endpoint, we implemented the get ticket endpoint. In ticket get QR code service layer, we added the find by ticket ID and ticket purchaser ID to the QR code repository and implemented the get QR code image for user ticket ID on the QR code service. In get QR code endpoint, we implemented the get QR code endpoint. And in UI testing, we tested the get ticket functionality using the user interface. In this module, we'll implement the validate ticket functionality. The module is structured like this. We'll first implement the ticket validation service layer functionality. We'll then create the DTOs and mappers, implement the validate ticket endpoint, and then test the endpoint through the user interface. So for the learning objectives, by the end of this module, you'll be able to implement the service layer to validate a ticket, implement the DTOs and mappers to validate a ticket, implement the validate ticket endpoint, and test the validate ticket endpoint by using the user interface. So with this covered, let's get started. In this lesson, we'll implement the validate ticket service layer. So here we are back in our IDE. So we're going to start over in the repositories package here by creating a new repository, and we're going to call this one ticket validation repository. And this is going to be a interface rather than a class. We'll extend JPA repository. Let's just expand this, make a bit more room. And the type of the entity that we're dealing with, of course, is ticket validation. And the ID type is the UUID. Now let's put the @repository on the top here. And we now have this ticket validation repository ready to use. So let's now think about the services. So we'll need a new service. Let's create a new Java class, and we'll call this one ticket validation service, and we'll declare it as an interface. Let's expand this. We're going to declare two methods on this service. The first method is going to return a ticket validation, and we'll call this one validate ticket by QR code, and it will accept a UUID, which is going to be the, if we import UUID, we'll say QR code ID, and we're going to declare a second method also returning a ticket validation, validate ticket by, or rather manually, to validate ticket manually, and the UUID is going to be the ticket ID. So this accounts for the two different ways that we can validate a ticket, by scanning the QR code or by entering the ticket ID manually. Granted, at the moment, the ticket ID is a UUID, so in practice, that would be quite difficult to type out by hand each time. So that will likely need optimizing in a real production setting, but for the time being, these two pieces of functionality is what we need. So let's now go to the implementations package here. So impl, create a new Java class, ticket validation service impl, and this will implement ticket validation service. And if we hover over the red squiggle, implement those methods, we now have two method stubs ready to implement. So before we go any further, let's put the @service on the top here, required as constructor. And I happen to know we're going to be making multiple database calls in both of these methods. So we're going to put the @transactional on the top at the moment, and that will save us from doing it on both of the individual methods. So let's start with validate ticket by QR code. We're going to need a few dependencies in order to implement this. Private final, we need the QR code repository. We need the private final ticket validation repository. And for the validate ticket manually, we're also going to need a ticket repository as well. So let's look to implement validate ticket by QR code. So the QR code ID, or better put, the ID that's been baked into the QR code, is simply the ID of the QR code in the database. So to look this up, we would do QR code repository dot find by ID, passing in the QR code ID. Now it should be said, there are ways to improve the security of this. At the moment, we're just taking the UUID, baking it into a QR code, and then using it to look up the QR code entity in the database. So we'll do find by ID. Now we're also going to do an or else throw. In the case that we don't find that QR code, we'll throw a new QR code not found exception, and let's do a string.format, and we'll say QR code with ID was not found. And then we'll pass in the QR code ID, and then we should be able to assign this to a variable now, which we'll call QR code. In order to get the ticket from the QR code, we would do QR code dot get ticket, and that will give us our ticket. Now thinking on things a bit further, if we take a look at the QR code here, we also have this QR code status on here as well. So we could have potentially QR codes in the database that are expired. So to account for that, rather than find by ID, let's introduce a new method on our QR code repository, returning an optional QR code, and we'll say find by ID and status. I believe status was the name of the instance variable that we used. Perfect. And then for the arguments for this one, we're going to pass in the UUID, which we'll call ID, and then the QR code status enum, which is our status. So if we were to use this in our implementation now, we'll pass in the QR code status enum of active. That will ensure that we can only look up active QR codes. So what do we do once we have this ticket? Well, we want to create a ticket validation to be associated with this ticket. So ticket validation, which we'll call ticket validation equals a new ticket validation. And now we can do ticket validation.set ticket to be the ticket, the same one that's associated with the QR code. And we can do ticket validation.set validation method. And in this case, it's going to be QR code scan. So QR scan. There we are. Now for the status of the validation. We can do all sorts of complicated logic here, but I'm going to keep it quite simple for this MVP. So the logic will be this. A ticket can only be validated once. And once it's validated, any attempts to revalidate using that same QR code will come back as invalid. So in order to achieve this particular logic, I'm going to say ticket dot get validations. We're going to stream and we're going to filter because I only want validations that are valid. So we'll say ticket validation status enum valid equals v.getStatus. So we now have all existing ticket validations associated with this ticket that are in valid state. I'm going to do find first, and we're going to map. And in this case, we're going to return a ticket validation status enum.invalid. I think we might need to give this a name. And the reason for this is that we've already validated this ticket once before. We already have a valid ticket validation status. So now we're going to say or else ticket validation status valid. If we assign this to a variable now, we now have our ticket validation status. So if we now save this, ticket validation.set status of the ticket validation status, and now we can return ticket validation repository.save with our ticket validation there, and we have validated our ticket. So we get the QR code ID, we look up the QR code from the database, ensuring that it's active. We then get the ticket associated with that QR code. We then create a ticket validation, setting all the appropriate information, and we determine the status by checking if the ticket has already been validated once before. If it has, then we set it to be invalid. If it hasn't, if this is the first time this ticket is being validated, then this is our first valid ticket validation. We then save the ticket validation and return it to the user. So that's our first method. What about our second one? Well, we're being passed the ticket ID in this case, so we'll need to look up the ticket from the database. Ticket repository.find by ID, passing in the ticket ID, and we're going to or else throw, and I don't think we yet have an exception for ticket not found. Let's just check these. We have ticket type not found, but not ticket not found. So let's create a new one of those by copying and pasting. It's still going to extend event ticket exception. And while we're here, let's go up to the global exception handler and make sure that we've added handling for this. Ticket not found exception, handle ticket not found exception, caught ticket not found exception. And we're going to return a bad request and say ticket not found. So we can now throw a new ticket not found exception. We assign this to a variable. We now have our ticket. And rather than write out all the logic again, we can reuse it from up here. So I'm going to highlight everything here. So this is the start of the flow that accepts a ticket and then returns the saved ticket. So if we were to right click, refactor, extract method now, we're going to call this one validate ticket. And here's our private method that accepts a ticket and then returns the ticket validation, which we can then use in this second method, validate ticket, passing in the ticket, and we can return that to the caller. And with that, we've implemented our two methods. So again, this is just the first iteration. We're not doing things like checking it's the correct event or doing any kind of more refined validation logic than simply checking if the ticket has been validated once before, but we now have a solid base that we can build on. In summary, we implemented the ticket validation service layer functionality. In this lesson, we're going to create the DTOs and mappers that we need in order to implement our validate ticket endpoint. So we're back in our IDE. So let's now go to the DTOs package here, and we're going to create a new Java class. This one is going to represent the ticket validation request. So we'll call it ticket validation request DTO. We'll put @data, all ours constructor and no ours constructor on the top. Now the ticket validation request is going to have two instance variables. The first one is going to be a UUID, which we're simply going to call ID. Now this ID could represent the QR code ID, or it could represent the ticket ID, depending on which validation method we're using. We could potentially use different endpoints in order to separate out the manual validation from the QR code scan validation, but in the MVP, we're simply going to use an enum for this purposes. And the trade-off there is it's slightly less maintainable, but it is quicker to implement. So we'll say private, and we want the ticket validation method, and we're simply going to call this one method. So the ID, which is either the QR code ID or the ticket ID, and then the method, which is either QR scan or manual. So that's the request. What about the response? Well, if we create a new Java class here, we'll call this one ticket validation response DTO. Expand this one, @data, all ours constructor, no ours constructor. Now this is going to take a instance variable, which is a UUID, and it's going to be the ticket ID. So this is different from the request, where it could be a QR code ID or a ticket ID. The response, it's definitely the ticket ID. And we're also going to return the private ticket validation status enum, which we're going to call status. So two bits of information. The first one is the ticket, and the second one is whether or not the validation has been a success or a failure. Is it valid? Is it invalid? So we now have these two DTOs. Let's now look at the mapper. So we're going to create a new mapper here. We'll call this one ticket validation mapper, an interface. And I'm going to borrow the mapper annotation from ticket mapper because it's going to be exactly the same here. Let's expand this. So we're going to place a single method on here. It's going to return a ticket validation response DTO. And we're going to call this one to ticket validation response, and it's going to accept a ticket validation, which we'll call ticket validation. And because the ticket validation doesn't have the concept of a ticket ID, it does have the concept of a ticket with an ID, which we can see here, we'll need to add a mapping where the target is ticket ID, which is the instance variable on the ticket validation response DTO, and the source is going to be ticket.id. And there we go. We don't need to create a mapping method for the request because we're simply extracting the two instance variables and passing those to the service layer. While in actual fact, we're only passing one instance variable to the service layer, and we're using the enum to determine which service layer method we want to call. All this to say, we only need this one mapping method. In summary, we added the ticket validation request DTO and ticket validation response DTO classes, and added the mapping method to ticket validation response DTO to the ticket validation mapper. In this lesson, we're going to implement the validate ticket endpoint. So back in our IDE, let's head up to the controllers package here, and we're going to create a new controller. And this one's going to be called ticket validation controller. Let's expand this. And we're going to place the REST controller annotation, also the request mapping annotation, specifying the path as /API v1 ticket validations. And we're going to put the required arguments constructor on here as well, so we can inject some dependencies. We will need two dependencies, the private final ticket validation service, which we'll call ticket validation service. And we'll also need the private final ticket validation mapper, which we'll call ticket validation mapper. So let's now declare ourselves a post mapping, public response entity, and it's a ticket validation response DTO that we'll be returning, and we'll call this one validate ticket. And it will accept a request body here, which is going to be a ticket validation request DTO, which we'll call ticket validation request DTO. So how would we implement this? Well, first things first, let's do ticket validation request DTO.get method, and this will tell us how the ticket is being validated. Now, as the ticket validation method only has two states that we care about, QR scan and manual, rather than do a switch statement for this, which might be a bit overkill, instead, I think we'll just do an if statement. So our default method, at least from the point of view of the staff member, is going to be QR code scan. So we'll simply check for the exception state to begin with. So if ticket validation method.manual equals the method, then we're going to call the ticket validation service dot validate ticket manually, passing in ticket validation request DTO get ID. That's then going to give us a ticket validation. Otherwise, we're going to assume that we're dealing with a QR code, and we're going to say ticket validation service dot validate ticket by QR code. Again, passing in the ticket validation request DTO get ID. And we'll also have a ticket validation. To keep things a little bit tidier, let's declare ticket validation up here, and then we can assign it like so. Okay, so we validated the ticket. We now have a ticket validation. So we can return ticket validation mapper dot to ticket validation response DTO, passing in the ticket validation. And of course, we'll need to wrap this in a response entity, okay, like so. Again, we could have a clean implementation of this if we used a different endpoint for the manual and QR code scan. Regardless, however, this should do what we need it to do. So before we test our new endpoint by using the user interface, we should lock this endpoint down so it's only accessible by staff members. So in order to achieve that, I'm going to copy this endpoint here, and we're going to head over to security config. And in a similar way that we've done here, I'm going to add a new request matcher where the pattern is going to be the ticket validations endpoint, and I'm going to say has role of staff. And this will ensure that only users with the staff role can interact with the endpoint on the ticket validation controller. In summary, we implemented the validate ticket endpoint. In this lesson, we'll test ticket validation by using the user interface. So here we are in our browser. On the left-hand side, I'm logged in as the attendee user, and on the right-hand side, I'm logged in as the staff user. So if I navigate to the dashboard for the attendee, we have ourselves a ticket, and on the right-hand side, we have ourselves the QR code scanning page, or the ticket validation page. So with that done, let's get hold of the QR code here. Perfect. So we have a QR code on the left, and we also have the ticket ID. On the right-hand side, we have the ability to scan a QR code and also manually input the ticket ID. So this page on the right-hand side is designed for a mobile device, but we can use this webcam in order to test the scanning functionality. So let's open up a network panel to begin with. There we go. And let's attempt to scan this QR code. Okay, we have ourselves, we've tested in quick succession there. So let's take a look at what we've got. So we've sent two validations. So the first one was the ID, which is the QR code ID ending A20. We can see here QR code scan. And the response we got from that one, if we just make this full screen, we can see is valid. Perfect. And that's when we saw the green tick on the screen. And because I didn't move the camera away fast enough, we have this second validation here. And we can see the response for this one is invalid because it's the second validation, and our business logic is built in such a way to only allow a ticket to be redeemed one time. And we can see as a result, we now get a cross on the screen. So if we were to open up our database, so here I am in AdMiner on the ticket validations table, and we can see both of these validations, valid, invalid, both a QR code scan associated with this ticket. So it looks like the QR code scan is working as expected. Now, in order to test the manual scan, let's delete these ticket validations. Let's now go back to our user interface. Great, and I'm going to reset over here, and I'm going to also clear down the network panel as well. So I'm going to copy the ticket ID. And then on the right-hand side here, I'm going to hit manual, and I'm going to paste in the ticket ID, and then click on submit. And we get a green tick. Very good. If we take a look at the network, we can see we have the ticket ID here ending BFC, and it's valid. If I were to pull down the network panel and attempt to validate this ticket a second time, we can see we get a cross now. And that's because our business logic says a ticket can only be validated once. So this is now invalid. We go back to our database and we select data once more. We can see we now have two validations, one valid, one invalid, both associated with the same ticket ID. Although the validation method does appear to be QR scan. I wonder if that's a bug on the front end or the back end. Let's have a look. So looking at the payload here, we can see that we are passing manual. So it doesn't look to be a front end bug. Let's look at the back end. So back in the back end here, let's now go to the ticket validation service, which is here. Expand this. And I can see right away where the issue is. We are hard coding QR code scan in here. So if we extract this to be a parameter in the argument, we can see now validate ticket by QR code specifies ticket validation method QR scan. If we go down to the manual validation, we now have the opportunity to set that as manual. So let's restart our backend. Okay, everything started up fine. Let's head back to the user interface. Or rather, let's go to the database first and delete everything so we can get a fresh test case. Wonderful. Here we are. So let's clear this. Let's reset. Copy the ticket ID once more. I'm going to pull this down, click on manual, paste that in, click on submit, green tick, submit again, red cross. And if we look at our database, select the data, valid, invalid, manual validation method. So it looks like the MVP of our ticket validation is working as expected. In summary, we've tested the ticket validation functionality through the user interface. So let's recall what we've achieved in the validate ticket module. In validate ticket service layer, we implemented the ticket validation service layer functionality. In validate ticket DTO and Mapper, we added the ticket validation request DTO and ticket validation response DTO classes. And we added the mapping method to ticket validation response DTO to the ticket validation mapper. In validate ticket endpoint, we implemented the validate ticket endpoint. And in UI testing, we tested the ticket validation functionality through the user interface. There we have it. Congratulations on making it this far. As a reminder, if you do want access to the lessons in which we build the user interface, there is a link in the description below. Or if you prefer, why not check this out?